Thank you.
Today is your actual birthday? Today is your actual birthday?
Actually, no. It's the date of birth on the record.
Yeah.
Okay.
Okay.
How do I know that? I can only see the record. Shiv Kumar, can you speak few words?
Yeah. He is in October.
Oh, I see. Okay.
This is an old gang. IIT Madras gang.
It goes a long way back, and Umar Shankar.
What about Professor Sudarshan?
No, he is much
junior
junior
to
to
us.
us.
Okay.
In fact, he joined IIT Madras after we left.
Okay.
Okay.
Yesterday I was thinking. So then I knew.
Professor AK,
We are really old.
Yeah, Professor Ekasuresh is already here.
Yeah. So you can also say a few words, and HOD can also. Is it the time started, or we are just checking?
I think
we started. Yeah, we started. It's 10 o'clock, so we started.
I think we can start.
Very good. So the host and moderators have been fixed, no, Soumya?
Yeah, you are the host right now. Where are you?
Okay. And then
all the moderators are here. Yeah, and they are
moderators
co-hosts.
are here. Okay, very good. So I will start the inaugural session, and then Ashutosh and Ritanjali could take over after that. Is that fine?
Yes. Yeah.
Okay, so welcome everyone. It's a good occasion for us to celebrate in this virtual session of Zoom. Happy birthday to Umar Shankar. We feel great.
Thank you.
Of course, now we know that it is his record birthday and not it's okay. So we just went through the records and we thought it was 17th June. So we called all your collaborators and students, and I think you have really a huge list of people who want to come and participate. I've really put a cutoff on, I don't know whether it's called the infrared cutoff, but I have put in some cutoff. But there are people who are present, but they may not be asking questions because the moderators will take over. During the interaction session, they will be asked to speak. Otherwise, they can participate in all the seminars. And I'm sure all your collaborators are all joined already. Shubhabati, Rajganti, Sanjeev, and your former students, Ushak, Shushant, are all here. Okay, and there are many more students, so I'm just listing a few of them. So let me take this opportunity to ask Professor Suresh, HOD, to talk first, and then our Deputy Director, who's also Professor Suresh, to talk after that, and then I will leave it to Urjit to take over. Yeah. Professor
Thank you,
Suresh,
Rama.
HOD.
Can you hear me?
Yeah.
Thank you, Uma. Rama, happy birthday, Professor Umar Shankar, my senior colleague. And of course, I also congratulate on this occasion Professor Kajri. I hope she is around.
Yeah, she is here. She's coming in a minute.
Yes. Please convey my special greetings to her. So before I give some formal speech kind of thing, I remember the day when Rama came to me. I mean, we talked about the official birthday and so on. So Rama came to me at least 4 months back and asking me how to get your birthday, date of birth. So I told, don't worry, we have some record, and immediately we could get. That is how the thing started. And of course, at that time, the thinking was that we'll have a usual physical meeting. Unfortunately, that is not possible now. And therefore, we got into this Zoom. Thanks to Soumya, he has been responsible for all these Zoom-related things and the YouTube channel. We had several events in this, and we are using the same platform for this also. So I think Professor Umar Shankar has been part of the department for the last, I think, 25 years.
Yeah.
Yes. So I know him for the last 20 plus years, initially as my neighbor in the department and a co-instructor in some courses, in 2 or 3 paper setting teams. And every time I interacted with him in these capacities, I always learned some physics, some bit of physics every time. The explanations are very lucid, and actually it cut across fields. He can talk about many fields with some authenticity. He is really a true academic and a scholar and a thorough gentleman. Many people in the department know him, especially the HODs, as a person who can or who always offer to take any course. Most of the time, he doesn't fill the course choices because he knows he can teach anything. At the most, he calls and tells, please give me wherever there is a problem, I will teach. He always cares about his colleagues and offers unconditional help whenever it was required. Taking 2 courses, for example, whenever there was a requirement, he never bothered. In fact, he never asked for a compensation also. And I know specific examples in the past. He never bothered about for a compensation because he knows that it is helping a colleague and that is his responsibility. As a person who always cares about the department as a whole, and also important, especially when it comes to the academic reputation, he was always very firm. He was always very strict because he was worried about the colleagues, he was worried about the students, but he was also equally worried about the reputation of the department. He never allowed it to kind of decay. So I had the opportunity to interact with him much more closely after I became head of the department because he was in 2 important committees. He was a member of DPC and DPGC. And both these committees have a lot of responsibilities. And many times as a senior member, I used to go to him even outside the meeting. I used to go to him. And whenever I went to him, whenever I presented a problem or asking his advice, he always took the problem as his problem. In fact, he gave advices in such a manner that the problem is his, not mine. So that way he was very, very helpful in offering simple solutions. He's extremely student friendly. I have heard many times when I was a tutor with him, I have seen, in fact, I used to observe how he was discussing with the students, and he never had a problem. I have witnessed. He finds that he was at fault at one point of time during the argument. He very, very simply acknowledges and tells that the student that you are right, because he is so knowledgeable. There was no problem for him to accept that he made a mistake and therefore the student was right, and the student should know that the mistake was not by the student but by himself. So he encourages his students in all possible manners. I should mention in this context, I should mention his role in this Ask a Question, which all of us know. This is a program which started, I think, when Professor Shiprasad was here, and it was handed over to Professor Umar Shankar when Professor Shiprasad retired. He has taken it so nicely, and every week he had to arrange a lecturer. He used to go around, and he was finding it difficult sometimes, and then he himself used to do it. I remember a couple of times I told him that let's cancel this week because you are not getting anybody. But his answer, I mean, really it was amazing. He told that this is a very good initiative. I don't want to kill it. Whatever possible way, I will take it. And if nobody is willing, I will go. Even if one student is benefited in some remote corner of this large country, I'll be happy. So that is the man. I mean, really, really, I admire you, Umar. And in the department, when it was a physical seminar or now in the webinar series, I think he's one person who is always there. And his presence in all seminars, I could tell. It doesn't matter which field the speaker was from. His attachment to the department is beyond description. I strongly feel that people like him make a department a successful department. And having said this, I feel little sad or a little bothered that in 5-6 years he will be retiring. Frankly speaking, I will find it difficult to think about the department after his retirement. He's such a person whose presence is so felt. I can't think about a department after his retirement. This is something which I am telling from my heart. I wish him all the best for his health and his career. And I am sure that he continues to inspire a large number of students in coming years. Thank you again. All the best, Umar.
Yeah, thank you, Suresh. And well, when one has to be the member of the department and sort of contribute to its overall well-being, and that's what I have done in the 25 years I have been in the department, and I hope to do so for the remaining part of my career when I'll be in the department. Thank you.
Thank you.
Thank you, Suresh. I would request Deputy Director, again, Professor Suresh, to talk about on this event.
Devi.
Yeah.
May I request the host to mute everyone except, optionally you can leave me unmuted.
Yeah.
I'm getting some extraneous noise.
So maybe everybody can show, means video can be on, but mute can be muted. That's the idea.
Okay, can I go ahead?
Yes, please.
Professor Umar Shankar, Professor Ramadevi and Suresh, external collaborators of Professor Umar Shankar who have kindly joined us today, faculty and students of Professor Umar Shankar and of the physics department, and other delegates. A very warm welcome on behalf of the Institute to all of you to this one-day web conference being organized to celebrate Professor Umar Shankar's 60th birthday. While it is the normal practice on one's birthday to wish many happy returns of the day, in view of the circumstances we are in, I hesitate to use that expression. Let me just wish Professor Umar Shankar a very happy birthday and a long, healthy, and productive life ahead. For a person engaged in the pursuit of science, there is no more appropriate way of celebrating the birthday than like this, by gathering his close collaborators, students, and admirers together and deliberating on scientific matters close to his heart. I therefore congratulate the organizers for putting together this event. This is all the more creditable given the constraints placed on us by the pandemic, because of which we are unable to have a physical meeting. However, the season has been seeing many such activities in the video conferencing mode, as our community thumbs its nose at the novel coronavirus and says, you may succeed in restricting our physical movements, but we shall remain mentally active. Professor Umar Shankar has been a distinguished member of the Institute faculty for 25 years, as was pointed out by Professor K.G. Suresh just now. While I am not competent to comment on his teaching or on his research, I have known him as a person for a good part of his association with this institute. Apart from carrying out teaching and research with distinction, which I believe he has done, he has also contributed richly in various ways to the institute, among them as head of the physics department for a period. I've always found him easy to talk to, a man well organized in his mind, and one with a great temperament. And I was happy to learn from Professor K.G. Suresh's remarks that others have also found him to be this nature. So, it is clear that he was not putting on a special face for my sake. And that is the kind of person he is in general. I take this opportunity to thank him on behalf of the Institute for all his contributions and hope for many more, scientifically and otherwise, in the years to come. I hope you're all taking adequate precautions and staying safe during these dangerous days. It has not been easy dealing with the pandemic, whether on an individual level, an institutional level, or a community level. And while there are drug and vaccine candidates that we keep hearing about, it is a fair assumption that we are in this situation for the long haul. We in the Institute are trying our best to carry on with academic work as best as we can, and hope to announce some decisions soon on how we plan to deal with the teaching and research in the coming months. I realize that the work of most research students has suffered, but I do hope you have found ways to keep yourselves engaged with your subject as well as you can. Maybe even explore territories a little outside your immediate interest. We hope for better days to return, but at the same time prepare for a persistence of this threat for months to come. With those few words, let me close once again by extending my very best wishes to Professor Umar Shankar on his 60th birthday, and by wishing you all a very stimulating days discussions ahead. Thank you.
Thank you, Professor Suresh. Rama? Soumya?
Yeah.
I forgot to mention one point, actually Professor Suresh mentioned, so I thought I should add it. So if it is permitted, I will just add that.
Yeah, go ahead.
Yeah, so I forgot, I written down, but I forgot to mention this. Professor Umar Shankar was head for about 4 months, and the way he was controlling the department faculty meeting. Okay, so he's an extremely gentle, polite person, but when it comes to taking decisions through a DFM, as you know, DFMs are usually very chaotic, cross talks and all these things. He used to put up agenda item, and he used to call individually and ask for their opinion. No cross talk, nothing was tolerated. And later, when I became the head, I was exactly opposite. And some of my young colleagues told me that you should learn from Prof. Umar Shankar. I really, so when it comes to taking decisions, he's extremely meticulous. This is very clear example of this. I thought I should mention this. Thank you.
Yeah, thanks, Professor Suresh, Deputy Director, and also HOD for adding few more about Professor Umar Shankar. Let me request a senior colleague of mine, Professor Yajnik, who knows him many more years than all of us, to talk few words about on this event. Yeah. Yajnik is here.
Yeah,
Others can,
Urjit, you have to unmute
it.
yourself.
Just 1 minute before we go on. Let me thank Professor A.K. Suresh for taking time out to join this meeting, and also I thank him for the kind words. And whenever I went to him with the request, either as faculty or during the brief tenure when I officiated as the head, he's been most helpful in addressing the problems that I mentioned to him. And I always had a very enjoyable interaction with him, and I thank him for joining us today.
Like you, Professor Suresh, A.K. Suresh used to be our regular, attending almost all the seminars. Especially, I should thank taking this opportunity whenever we had a DDLS, whenever we had the Institute Colloquium from our department. Professor Suresh always made it a point to attend. And if there was any difficulty because of scheduled meetings, he used to even send me a mail. So thank you, Professor Suresh, because you are also coming out of the directorship. So I thought I should take this opportunity to thank you on behalf of the department. Thank you.
Thank you. Thank you.
Okay, so I'm audible?
Yes.
Yeah, so I'll share screen. Can you see this screen? Yes. Is it visible?
Yes.
Yes, the screen is visible.
Okay, so these are my few slides. Happy birthday to Umar Shankar. And hopefully we will have some occasions a little later where we will make up for the absence of actual presence and celebration with some real pizza and other things. But let me take this opportunity to just put together some memories from our time together in the Institute. Since there will be a lot of speakers, collaborators and so on, I will not speak too much about physics or other things, but about the institutional, professional things that we did together. So we have been partners in several creative endeavors, and I will just try to go over a few of them for shortage of time. As I remember, the first thing we ended up doing together was we were both in the same Circ school in IISc Bangalore in 1998. But then there were these other activities, and for want of time, let me just go on to just, I think our major contribution to physics in India was probably this Chennai web of year 2000. And then we had our own web in IIT Bombay. So the Web 6 in the year 2000 was an interesting one because that was the web where the high energy physics community of India took on to discuss in a very serious manner the idea of putting up a neutrino detector within India. There was a lot of encouragement from Professor Rajsekharan for a long time to all of us. And I think this was the critical juncture where it all came together, And as you can see, both Umar Shankar and me were present there. I ended up also being coordinator of the discussion meetings. And as is well known to everyone here, Umar has subsequently really driven the theoretical effort which helped to shape the goals and directions of the detector along with all the collaborators in the country. So this was a very, this was a event that was a turning point for all of us in the Indian community, and assuming that this is going forward, probably for the international science. The next thing here in the year 2002, and you might say that this was the beginning of the sequence of events that we are gathered for today. In the year 2002, Uma nudged me to hold me this conference on what we called asymptotic domains of theoretical physics. That was because the person in whose honor we were trying to hold it refused to have anything to do with it and would not permit us to get his name into the event in any way possible. So you can see this was a preliminary page I had made. There is a painting of the Powai Lake, also given to us by one of our alumni. And the event was actually the celebration of the 60th birthday of Professor S.H. Patil, who had anchored and developed the particle physics effort in the early 70s in IIT Bombay. You can see various people here. I'm sorry, I will not have time to introduce all of them. But I just want to reassure you that the gentleman in white mustache is not me. At that time, I had a black mustache, and you can probably locate me. I just want to remember here Professor Joglekar, who is no longer with us, who is standing in the middle front. Many of you who have seen him in IIT Kanpur will recognize him, probably one of our most distinguished alumnus. And then in year 2004, we were charged by the HEP community of India to hold the workshop on high energy physics phenomenology, one of our most famous and internationally celebrated workshops. Umar did a lot of the legwork and a lot of the academic work and putting out the proceedings. And you will recognize several names here, and some of you have joined us here today. And I want to thank you for the same. And these are some photographs from that event of 2004. We had a Elephanta excursion. Shrubhabati is going to speak to us soon. And she is also in this photograph below, but there is also somebody here, a young postdoc at that time. The face is turned, but I think the audience can make out who that is. This is the web of...
Wow, I really look different in those days.
So, these were the events that we were doing, and then I'm just jumping ahead because there were in between years when I was doing other things, contributing to main building and so on. But this was the second of the events that Uma actually shouldered, and we had a nice gathering. We now have new members together with us in our group. There is also Abhijit Gade in the background, who by that time had joined TIFR. And then in 2018, Umar shouldered the responsibility of holding the very first workshop along with Vikram, our ICTP IITB joint workshop, which generously funded by our own institute through a Center for Advanced Study, and also, of course, funded by ICTP. And this was a major event. I could not gather any more pictures of this, and also I think I've taken a lot of your time. But I just wanted to highlight these major high points of our journey together at IIT Bombay. So wish you a very happy birthday, Uma, and wish you many, many more years of searching for neutrinos and beauty. Thank you.
Thank you, Jit, for this.
Thank you, Urjit. Yeah, we had a lot of good times talking physics and also organizing these physics activities.
Your voice is breaking.
No sound.
I circulated a message on WhatsApp a couple of months ago. That was the Cirque School in PRL in 91, where at least that was the first time I went to a Cirque School as a faculty, and you were also there at that time.
Thank
And
you.
we can sort of pride ourselves that we taught the likes of Rajesh Kopakumar and other stalwarts of the country.
That is right.
Who were students in those days.
Of course, I should tell the audience that I knew Kajori before I knew Shankar. So welcome, Kajori. It's good to see you also. Okay, please take over.
Yeah, so let's now request the moderators to, if are there any other faculty who are online who want to talk few words, you can raise your hands and then we could take it over from there. I can't see other faculty members online.
No, there are many faculty members here.
Okay.
Professor Jagtap is here.
They want to
Professor
talk,
Singh
or-
is here. Professor Mahajan is here. Professor Mugad, I think everybody is here.
Professor Vikram wants to say something, so I think
Yeah.
I will unmute.
Yeah, can you, Professor Vikram, can you talk?
Yeah, hi, can everyone hear me?
Yeah, can we see you also?
Yeah. Hi.
Yeah.
So I just wanted to say I was a student, many of you know, with I did my dual degree project with Umar Shankar. I was in the electrical engineering department at that time, and he agreed to supervise me with someone with no experience, and I worked on INO. And I mean, I think it's not even a moderate statement to say that he really started me on my journey towards research in physics by encouraging me from the very beginning. And he was a terrific mentor. I mean, he was always available to discuss things and very patient in explaining very basic things, and not just focused on a particular project, but just to ensure overall development as a physicist. So I think that really shows his attitude towards students, and this is not just my experience; it's the experience of many of my fellow students at the time. As a colleague, he's been the same. I mean, absolutely invaluable in his advice, and he played no small part in my decision to come to IIT Bombay. It was significantly influenced by him. And so I want to thank him for that and wish him a very happy 60th birthday and many more productive years to come.
But Rama, Professor Shivakumar was waiting. Professor Shivakumar from CSE.
Yeah, but he left, I think. He said he will initially say happy birthday and he'll leave because there is a meeting. That's what he said.
I see. Okay.
Yeah. So he said in the beginning, that's why. Yeah.
Yeah. Thank you, Vikram. The one small story about Vikram's project with me. Actually, Vikram had 3 advisors for his project, Professor Shavgaonkar from the Electrical Engineering Department, and me, and also Shashi Dugad, with whom he did a fair amount of INO related work. But when it was time for Vikram to present his final project report, it so happened none of the advisors was present. We sort of left him alone to face the examiner, who I believe is Amol Digay, who is also present here. But looks like Vikram could handle that by himself. So he came through with flying colors. Yeah.
So Ramadevi, with your permission, can I leave?
Yeah, sure. Thank you so much for taking your time and coming over and, in the inaugural session. Thanks a lot. Yeah. Okay, any other faculty member who wants to speak can raise your hand. Amol wants to talk? You want to say something about Vikram's?
No.
Okay, sure.
But I remember I was the examiner of Vikram, and
Okay.
I hope I didn't give too hard a time. He is still friendly with me. So.
Okay. I don't see any other faculty member raising hands or something. So maybe we can close the session and start our seminars.
Maybe on a lighter note, I'd like to just share a small incident that I remember from when I was a student. I discovered that Umar had a secret Toblerone drawer in the bottom of his, because he was looking for a pen, and then somewhere in the bottom, there were Toblerone stashed over there.
Wow. So did you get to eat it? No.
I was hoping to ask, but I had other things on my mind at the point.
Good.
And especially
Okay.
Uma's memory and his data collection about the department is amazing.
Wow.
He knows which batch graduated when, who are the members of that. I mean, absolutely. In fact, even recently, he told me about the birthday of one of our colleagues who retired. He's so, I mean, up to date, and he remembers everything. His memory is absolutely wonderful.
May I say something? Just a small something?
Sure. Yeah. So can you show your face?
Yes,
You
sure.
can?
So
Yeah.
since Suresh pointed out about Uma's memory and Vikram pointed out about the Toblerone in the drawer, let me now point out Uma's
Can't
table,
hear anything.
office table. Can you hear me?
Yeah, I can hear.
We
I
can.
don't know.
Yeah.
Yes.
So everybody has seen Umashankar's table in his office, and it's a kind of massive thing. There are too many things on it. But I have always been impressed how Umashankar never loses a single piece of paper. He always knows where each important or unimportant document is there on his table, and he immediately finds it. So it's probably also something related to his memory. And on another thing is that Suresh, our HOD, he has pointed out various qualities of Umashankar. So I don't have to repeat all those things. All of us know about those qualities. He is the most helping person. And whenever you have any difficulty, any kind of problem, professional thing, something related to the department, your teaching, or even your research, you have some kind of personal problem with some collaborators or somebody, you can always go and talk to him, and he is sure to give you his best advice. So he is very dependable, and the advice that he will give is just from his heart. So I have no doubt on that. Okay, so that's all I had to say.
Thank you, Asmita. Anyone else? Anyone else who's raised a hand or something, or shall we proceed with Raj Gandhi's talk now?
No, there is a
Gandhi.
raised hand. Sumiran has raised his hand.
Okay, Sumiran?
Yeah, so because people were relating these lighter incidents, I also wanted to relate one. So my perspective is, of course, now we are colleagues and we have had many nice conversations about physics and all in the tea room. But I was also his undergraduate student back in 2002 or 2003. And what I really remember fascinating, we were actually fans of Uma's teaching even before this particular incident happened. But maybe, I don't know if he remembers or not. So he was teaching us, I think, continuum mechanics. And so he was teaching us about rotations and, the various moment of inertia tensors and all those kinds of things. And one day he wanted to do a demo with a gyroscope. And so he brought a gyroscope. It was a small toy. And at the beginning of the class, before getting into the lecture, he wanted to do this demo. And we are all looking forward to it because we are already very impressed and fans of Uma, and then this is going to be awesome. And then he starts to pull the string and the gyroscope just falls. I guess he introduced it as a very stable object. And he's like, okay, in his very Uma-esque style, he just continues. And then he does it again. It again falls over. And then just keeps happening 3-4 times. And we are like, okay, the anticlimax has already happened. And then he just goes on as nothing happened, as Suresh said, that, you know, okay, I can't do it. Probably I'm just not good at it. Let's move on. And that was very fascinating for us to see that this guy who tried his best to do it, and then he was just trying to impart some physics knowledge to us, and he brought this and tried his best. And another point I would like to say, as a from a teaching point of view, is that, I mean, there were few other courses, but in Uma's course, I personally got to see how physics can really be challenging, because his course was at a very high level, but also very rewarding. So I thank Uma for that, and I still enjoy our physics conversations even now. Thank you.
Yeah, thank you, Sumiran.
Yeah, so
Yeah, no,
I think
ma'am, actually Sai Binjan Mampathi wants to talk.
Okay. Yeah, Sai, you can speak now.
Hey, thank you very much. So, hi Uma, I just wanted to wish you a very happy birthday. I just wanted to add, you know, in a lighter note, one dimension of of Uma that I have thoroughly enjoyed over the last 3-4 years that I've been at IIT Bombay. So, you know, of course, in the tea room when we have conversations, it's sometimes academic, sometimes not academic. And in the kind of non-academic category as well, Uma is, of course, as many people have pointed out, a repository of all things academic. But also in the non-academic category, I want to point out that Uma has a deep love for classical music and is a repository of everything that is both Telugu and Tamil, which is something that both he and I share in terms of our upbringing and our background. So I definitely have enjoyed conversations from ranging from Telugu movies to pickles to kind of you know conversations about Tamil literature and so on and so forth with Uma. And so, you know, happy birthday, Uma. I hope to have many more of these conversations in academics and outside them as well. And you know, I hope you have a great day.
I don't forget, he is the most prompt person in bringing sweets whenever he goes out of Bombay.
Yes, of course. I you know, I stand corrected. Yes, that is.
Yeah, thank you, Sai. But I doubt if I ever discuss Tamil literature with you.
Good point. Telugu mostly, yes. You know, I'm not good at
because
it.
I don't know anything about Tamil literature.
Tamil movies every once in a while.
Definitely.
Yes.
I'm a big MGR fan.
Yes, exactly.
It's just that it's unfortunate that we cannot get sweets from you today, but we'll wait for it. Okay, anyone else who wanted to?
Amol, this just shows how precise Uma is about distinguishing between literature versus movies and Tamil versus Telugu.
Happy birthday, Uma.
Yeah, Banu, PP Singh is here. Yeah.
Yeah, wish you many, many happy returns of the day. And
can you see your audio video?
Sir Singh has just come out of his quarantine place, by the way.
Oh.
Not yet. One more day to go.
Okay.
Can we see your video? Quarantine? Yes, we want to see you. Yeah. Okay.
Okay. Have a wonderful meeting today. And I hope everyone will enjoy learning more about neutrino physics.
Yeah. Thank you, BP.
Thank you.
Hi, Uma. Tommy here.
Hi, Tommy.
Hi. So happy birthday. And anyway, everybody has said everything about Uma, so I am not saying anything. But I know him right from my student days in TIFR. And there, Kajal is just standing behind him. And we were colleagues actually in TIFR. So all the best. Okay. And even when I joined IIT Bombay, we started so many things like JEE correction was the first one, and he was some sort of a guru for us how to correct and things like that. Anyway, we miss all that corrections and things like that. Even later, jam correction. Whenever we needed a correction, Umar Shankar will be there, and typically Umar Shankar I am also there, right? So
along with that, there are a lot of munchies also.
Yeah, all the best. Okay.
Yeah. Thank you.
Yeah. So I think we are running out of time, and I think Raj's talk should start now. Anybody else is there? We could move it to the interaction session between 4 and 5. All the other faculty members can come over between 4 and 5, and we have this participants, collaborators, and colleagues to talk more. Okay. So we will move on now. I invite Professor Gandhi, Raj Gandhi, to give us a seminar. I hope Raj is here.
Yeah, he's there.
Yeah.
So were you able to get the share screen info, or Shutosh, you were able to help him out? Hello?
Yeah, so yesterday we managed to.
Okay. So can Raj try it out to share the screen? Maybe you should just talk for a few minutes and then you can share your screen maybe. Raj Gandhi?
Okay, so is my screen visible?
Yeah, we were able to see you, but screen we have to see, but you can talk and then you can put on your seminar screen.
Just okay, so I take it you can't see my screen yet. Although I have hit the share screen.
So, did you open the file? File is open?
Yeah, it's on the screen.
Okay. Maybe you can close it again and then start and then open it and then do sharing screen. Let's see.
Oh, okay. Just a second. Okay, it says screen sharing has failed to start. Please try again later.
Okay, so what I can do is that I can share from my screen, and then whenever you ask me to change the slide, I will.
Yeah, that is better.
Yeah. Okay.
You can just email your file to Ashutosh.
It's already done.
I did that. Yeah.
Okay.
So
okay,
he has it.
Okay. Excellent.
Okay. So I guess all of you can see the file, or
I'm just trying to open.
Okay.
Yes. Yes, now we can see
We
that.
can see it.
Okay. Yeah, now it's visible.
Okay.
It's in fact Raj's on screen.
Yeah, I think screen sharing started to work. Yeah.
Yes, go ahead, please.
Okay. So it's a great pleasure. It's also a privilege to give this talk today. Uma is much more than a colleague. We have written many papers together, but he is also a very dear friend, and I think perhaps the most valuable quality that he has in my from my point of view is his straightforwardness, his honesty, and somehow just a basic goodness that I think I value a lot. And I hope that we continue to write papers together and, of course, continue our friendship. I have many good memories of interactions with him. I think the best memories I have are when about 2 years ago, he and Surya and I shared a house in Fermilab. So we talked a lot, we cooked together, we took walks together in Fermilab, and I got to learn how much of the history of Indian science Umar knows, and I learned a lot of that from him. Many things that I did not know, not just Indian science. I mean, he told me about many other things related to his time with Paul Langakar and other very interesting details about the history of our field. I still remember these long walks on the Fermi Lab in Fermi Lab and I carry very fond memories of our time together at that time. So let me start. I'm going to give you some idea of one piece of work that we have done together. We actually shared along with other colleagues like Shubhavati and Poonam and so on. We shared a very exciting time when we tried to understand what the physics capabilities of INO were. And this work is part of that. I think, interesting physics that we learned about and tried to uncover with respect to INO. I think Shubhavati will also talk about some of that. I'm going to talk about where we try to understand whether INO could tell us something about CPT violation. Now, this is something that more or less is obvious when you have a detector with charge discrimination. And INO was probably the first large detector proposal that could discriminate between lepton charges, particularly in this case, muon and anti-muon charges. So we tried to see what its capabilities were for trying to put bounds on CPT violation in particular. Okay, so this is the precise paper just as a reference. It was published in 2004, so already the work is 16 years old, but I think the basic ideas, which is what I will focus on in my short talk, the basic ideas are still relevant today. So as we know, these discrete symmetries of charge, conjugation, parity, time reversal, and their product, the CPT transformation, is held together by the CPT theorem. And the CPT theorem tells us that the terms in the Lagrangian, when you have Hermitian Lagrangian with local underlying local field theory and commutation relations which obey the spin statistics theorem, then CPT invariance is one of the consequences of that. So because the foundational assumptions on which it rests are so integral to our idea of quantum field theory. And the fact that the CPT theorem arises as a consequence of these assumptions, like spin statistics and local field theories and so on, because these are so fundamentally ingrained in our idea of what a quantum field theory should look like, any violation of CPT would imply that one of these or more than one of these assumptions is not valid. And that would really force us to rethink in a very foundational way our concept of particle physics. And one of the important consequences that has come forth only in recent years, maybe I think somewhere around 2000, that if you have CPT violation, then you have some form of Lorentz violation. And I will talk a little bit more about that. So my emphasis will, of course, be on neutrinos and how they can probe CPT violation. So here's a term that you can add to your effective standard model Lagrangian, which violates CPT. So you add it as a phenomenological small term and then try to see what are the bounds you can put on this additional parameter B mu that I have here. And as a measure of CPT violation. So first of all, it's important to say a little bit about what conditions, under what conditions does some term like this added to the standard model Lagrangian, how does it violate CPT and Lorentz invariance? It violates it under certain conditions. So we have, let me say a little bit about what those conditions are. So assuming that the standard model is a very effective, a very successful, effective theory, and that there's another more fundamental, complete theory that underlies this effective theory and is responsible for the success of this model. And if you assume that these are, that theory is CPT and Poincare invariant, then in certain examples of these so-called more fundamental theories, CPT and Lorentz invariants are spontaneously broken. So they are good symmetries of the theory as such, but there is spontaneous breaking involved. And probably the most well-known example is string theory. So it was shown that in a specific way by Kostelecki and Samuel and Potting in the 90s roughly, or late 80s, that such breaking can be, spontaneous breaking can be expected in string theories. So what we're trying to do is take that as an example of an underlying fundamental theory. How does a term like this violate CPT? See, the B mu quantities, if you have a Hermitian theory with spontaneous symmetry breaking, these B mu's are expected to be real quantities. And what they are some combination, because there is a phenomenological term that incorporates all the physics in that, the CPT breaking physics in the B mu's. These are combinations, some combination of coupling constants and expectation values related to the spontaneous breaking in the underlying theory, and some other coefficients that you all lump together in this. So what it does is that in the effective theory, this B mu, which looks like a 4-vector, is like a background field in this effective Lagrangian. So a background field, when you do a CPT transformation, is supposed to stay the same. So it does not change when you do a CPT transformation on this term that I'm showing here in the top line. Now, this looks like a 4-vector. It is a 4-vector. And I would just want to contrast it with a vector field, for instance, where you have the electromagnetic current coupled to A mu. the photon field. And under CPT, both of them get a minus sign. And so the product, A mu, J mu, remains invariant under CPT. Here the current changes, the fermionic neutrino current will change under CPT, but B mu does not change on account of its behavior as a background field coming from the underlying theory. So you break CPT in that way by adding this term. This term also will violate at least partially Lorentz symmetry. So here you have to make some distinction between observer Lorentz transformations where you make coordinate changes and particle Lorentz transformations where you do boosts on particles and local fields, but you don't do them on background fields. Uniform background fields will remain the same under such kinds of particle localized fields. So when you do coordinate changes, the B mu behaves like a 4 vector and it transforms as a 4 vector. But when you do a particle type of Lorentz transformation where these local fields, neutrinos, photons, so on, they transform under the Lorentz transformation, but B mu, the background field, does not. And so again, you have this kind of behavior. This behavior of the B mu is like 4 scalar quantities under Lorentz, particle Lorentz transformations. And again, then you will get a breaking of this Lorentz symmetry because it doesn't transform as a 4 vector, although it looks like a 4 vector in this. So those are the conditions under which you will expect that this term will start making contributions. In particular, this term will contribute to neutrino oscillations. So the neutrino energy gets an added term here. This m square over 2p is already there in the standard model neutrino sector. Then I add b, which is actually b0, the 0th component of that 4 vector. And let's recall that oscillation probabilities, which is what detectors measure, and INO in particular, will measure survival probabilities. But in general, if you have the P alpha beta, the transition from flavor alpha to flavor beta for the neutrino, not being equal to P alpha bar beta bar, then you have CP violation. If you have P alpha beta not equal to P beta alpha, then you that would signal T violation. And if you have P alpha beta not equal to P beta bar alpha bar, then you have CPT violation. Also, you have CPT violation if the survival probabilities of neutrinos and antineutrinos are not the same. And INO was an ideal detector because it could measure muon survival very well. It could see muons very well. It can see muons very well. Okay, so then you look for the difference between the P alpha alpha and the P alpha bar, and that difference depends on B, delta B, being dependent on the added term B that I just talked about. And you apply it to INO, and basically we just calculated the ratio of muon survival events to anti-muon survival events, because the detector could tell us when we were seeing muon neutrino versus a muon antineutrino based on its detection in the magnetic field of a muon versus an antimuon. Okay, so these are values of delta B. The red shows what you would have if there were no such CPT violation. And you can see this wiggly red line, and it's more or less flat at 2.5. These are event rates, so cross sections are only one part of the event rate. But roughly the cross section for neutrinos versus antineutrinos has this ratio, somewhere between 2 and 3. And this line reflects that in the absence of any CPT violation. Once you introduce CPT violation, these values that we've chosen for delta B are reflective of the best bounds roughly that were around at that time on this parameter. So you can see there's a large oscillatory variation from these sign terms versus length of this event rate. And it's large enough, you can see the ratio between these two event rates going down to 1 and then jumping up to 4. So it's something that would be very detectable in INO. And if you lower delta B to get a better bound, then this gets a little bit damped, but it's still observable for these values. And you can see that this is a good detector. So atmospheric neutrinos have the advantage that you have this large length, range of lengths. And so you could have seen this beautiful pattern emerge if there was CPT violation. Here's another plot that plots the same ratio versus L by E. And again, you see some kind of variation and oscillatory pattern, which you can, it's very observable because it's very large. Of course, if I want to improve the bound even more and I start taking smaller values, here's delta B equal to 10 to the minus 23, then you're getting close to within errors and you wouldn't be able to maybe tell the difference. But as long as you are in the 10 to the minus 22 range, you are in a position to improve, or were in a position at that time to improve the bounds on CPT violation. So this is what we did. We explored the CPT capabilities of the INO detector. And I think it was the first time that atmospheric neutrinos were being used for a charge discriminating detector. In fact, I think that prior to INO, there was a monolith detector which was not built. And then INO, which was similar in design. So these were detectors that could do this physics, and we showed that this was observable. Now this is work done with Anindya Datta and with Poonam Mehta, and as I said, it was done in 2003. And it's one of the nice pieces of physics that came out of our efforts to understand INO. Okay, so I'll stop here, and I want to wish Uma, who's, as I said, a great collaborator, wonderful friend, and I, from all I hear, he's a very good teacher. He's a very inspiring mentor, and I hope he continues that way for many, many years to come. And I hope that we do more work together. Okay, thank you. Thank you.
Yeah, thank you, Raj. And I should also mention that this is the first piece of work I have done with Raj Gandhi, and which of course later led to many more papers. And as he mentioned at the very beginning, the nearly 2 weeks he hosted me at Fermilab in the summer of 2017, and it so happened he hosted Surya also. And yeah, the cooking sessions, walking sessions, chat sessions, they were really enjoyable, and I certainly remember them very fondly.
Thank you, Raj. Wonderful.
Yeah.
Thank you, sir. It was a very nice talk. And
Pleasure was mine to do this at on Uma's birthday.
so we
I'm
can.
thankful for the opportunity.
Yeah, sir, thank you, sir. And sir, please be in the interaction session also from 4 to 5. So there also, if you want to say something, some non-physics stuff, you can talk about.
Okay.
Yeah.
Yeah.
So
So
shall we go to
Ashutosh
the,
can take over. Yeah.
so shall we go to the next talk? Yeah. Okay. So may I now request Professor Shubhavati to talk about the Earth matter effects and neutrino mass hierarchy.
Yeah, I will share the screen. Okay.
Yeah.
So I.
So, sir, you have to stop sharing the screen, I think.
I have to share the screen, right?
Yes, you have to share the screen.
Yeah, let me open it. Just 1 second. Okay. So, just a second. Huh?
Okay, so
Yeah, I will share.
yes, now it is visible.
Okay.
We didn't see you.
Just a second. So my internet today is not so good. So, but how do I change the video? Here I am.
Hi.
Okay, hi. So, okay, shall I start?
Yeah.
Okay, so it's really nice that you people are organizing this meeting, and especially at this time. And I am really very happy to be for this opportunity and to be here with all of you and share our work which we did together with Uma and maybe a few light moments. So I met Uma first in 1992. That was this SCRC school that Ujit mentioned, and this was the first. The Uma was the tutor for the particle physics and the standard model course, and this was in the first week. And this is the first time, at least, I came for such a meeting in the high energy physics community after joining for my PhD. And we were a little unsure, and I think all the teachers were very kind and friendly, and Uma was leading in that, and we were really very comfortable. And of course he was a very good teacher, and it was, the tutorial sessions were really nice. And just after that school, it was in 92 November, December, January, I think. And then after that, we heard after some months that Uma and Kajuridi are getting married, and they were the most popular characters, two of the most popular characters in that school. And so I think we were quite happy and excited about it. So after that, I met Uma in various conferences and meetings. Most notable is the Chennai Web, where I went with my daughter, and there also, like, we had a lot of interaction, but our main interaction started in 2003 after I joined HRI. When we started working on, and then we did a series of works, as Raj mentioned. And actually, Raj and Uma were doing some study, and it was very kind of them to also include me. And I will mainly talk about that work. So let me start with that. And I and Uma, we have many papers together. I searched in the
Ma'am, Ma'am, can you please make it full screen?
Yeah. Okay. Okay, so when I was switching the video, I did that. Okay. So if I gave the search that of two of our names, and this is what Spires showed us, but we were working, as you see, very closely from a lot of work from 2003 to then I think about 2008 or 9. So the main thing that we worked on was the neutrino mass hierarchy determination from using art matter effect and atmospheric neutrinos. And the neutrino mass ordering is that if neutrinos have mass, of course, everyone knows, just to set the stage, then the mass eigenstates are not the same as flavor states, but these are mixed states. And there can be two possible arrangements of the three mass states, which are, you know, the nu3 can be above nu2 and nu1 pair, or nu3 can be below nu2 and nu1 pair. Between 2 and 1, the hierarchy was fixed, the ordering was fixed from the solar matter effect. Apart from these three states, we have the three mixing angles, theta 1, 2, theta 2, 3, and theta 1, 3, and one complex CP phase, which characterize the three generation neutrino mixing. So this is delta m squared solar, which is delta m squared 2, 1, m2 square minus m1 square, and this is delta m squared ATM, which is m3 square minus m1 square. So in vacuum, the neutrino oscillation arises because of the neutrino mass and mixing, and after neutrinos propagate a distance L, one can calculate the oscillation probability, which is given by this expression, P alpha beta is equal to delta alpha beta minus 2 terms. Now, this is a general expression. If we go to a simple case of two flavors, then what we see is that there is one mixing angle, and thus conversion probability of the neutrinos oscillation probability depends on two parameters, which is sine square 2 theta, the mixing angle, and sine square delta m square L by 4e. So the intrinsic neutrino parameter here is the mass square difference. And the also it depends on the length the neutrinos traveled and the energy. So from this two generation expression, what we can see is that this expression is not sensitive to the sign of delta m squared because it comes as sine squared. It is also not sensitive to which octant theta lies because there is a sine square 2 theta. It also not sensitive to the absolute masses because it depends on the mass square difference. And when we go to anti-neutrino, then the U is replaced by U star. Of course, 2 generation, it's real, but for 3 generation, that makes a difference. Now, when we go to 3 generation, then there can be, even in vacuum, there can be some hierarchy sensitivity, the mass ordering sensitivity, which is the reactor experiments are right now, Juno type of reactor experiments are aiming to probe that. However, in vacuum in general, the hierarchy sensitivity is not always like really so good. It needs special distances and you know, like the reactor experiment is planning. So also the neutrinos interact with the matter when they pass through the sun or the earth. And what we studied is the matter effect of the neutrino propagation when they are passing through the earth. So in a very nutshell, what happens is in matter, because of the interaction, there is a potential which is added to the Hamiltonian, and the eigenstates in matter are different, mass eigenstates are different than the vacuum mass eigenstates. And the mixing angle in matter is now have to be defined with respect to the matter eigenstates. So that also changes in matter. So what happens in matter is that only the electron type neutrinos undergo charge current interaction, which gives rise to an effective potential √2 GFNE. And then when we solve the propagation equation, we diagonalize this mixing matrix in this Hamiltonian, and then for 2 generation, the effective mixing angle in matter is given by this expression, which depends on the mass square difference and the mixing angle, and the potential, which depends on the electron density and the energy. So what one should note here is that when this delta m square cos 2 theta is equal to 2 √2 GF NEE, the potential times the energy, then this theta m can become pi by 4, even though the theta can be very small in vacuum. And this is the famous Mikheyev-Smirnov-Wolfenstein resonance phenomena. And this is the mass square difference in matter. This is for 2 generations. And for antineutrinos, there will be a plus sign. So resonance will occur when delta m square less than 0. So this is how the basic idea, the matter effect is sensitive to the ordering of mass eigenstates, because it is different for neutrinos and antineutrinos. And as Raj mentioned, that if the detectors have charge sensitivity, then this resonance feature can be probed very well in such detectors. Now, as we know that there are 3 generations of neutrinos, so we have to solve the 3-flavor propagation equation. And this is what we did. And in 3-flavor, we will, if we express in terms of mass square differences, then we have 2 independent mass square differences, delta m squared 2,1 and delta m squared 3,1. And U is the mixing matrix, the 3-generation UPMNS matrix, and A is the potential √2 GFNE, which I have written in the previous page. Because of 1 by 2E, this becomes 2 √2 GFNE times E. Now, for what we did was we solved this. This equation is difficult to solve analytically. So to have an analytic understanding, what we did was people do in different limits. The limit which we studied was the 1 mass scale dominance limit. That is possible because delta m squared 2,1 is from solar neutrino and CAMLand. It is, the value of this is 8 into 10 to the minus 5 eV square in that ballpark, and delta m squared 3,1 is 2.5 into 10 to the minus 3 eV square. So delta m squared 2,1 is much less than delta m squared 3,1. So one can assume delta m squared 2,1 0, and then one can try to solve this analytically. And we can see that there is only 1 mass scale, delta m squared 3,1. So this is called the 1 mass scale dominance limit. And from this expression, you can see that this delta m squared 3,1 is the 1,3 sector. So the 2-flavor resonance that I discussed here will occur here because of this delta m squared 3,1 in the 1,3 sector. And what is the expression for the mixing angle now? The mixing angle, the tan 2 theta 1,3 in matter, will be given exactly the same expression, but there will be a cos 2 theta, it will be in terms of cos 2 theta 1,3 and sin 2 theta 1,3 now. And we know from the oscillation experiments, actually when we did the work, theta 1,3, value of theta 1,3 as 0 was also allowed. Then of course the matter effect would not take place. So we need a non-zero theta 1,3 for matter effect. But so what happened was but if the theta 1,3 was known to be small, and even if theta 1,3 is small, because of the MSW resonance, the theta 1,3 can get magnified in matter. So from here, the resonance condition can be worked out, as I said earlier, that delta m squared 3,1 cos 2 theta 1,3 equal to 2 √2 GFNE. So we can take a mod and then have for both neutrinos or antineutrinos, and one can calculate the resonance energy depending on what your mass square difference is. And we were dealing with the resonance in the delta m square ATM or delta m square 3,1, which is 2 into 10 to the minus 3. And what one can calculate is that given the earth density profile, that what is the length and the density at for different length and density, what is the resonance energy. So we can see that, you know, if the resonance energy is like 7.5 GeV or 6.6 GeV, then it is around 7,000 and 10,000 kilometer. For resonance around 1,000 kilometer, we need a much higher energy, around 10 GeV. So now the question that we asked was whether matter effect is maximum at the resonance. We saw that the mixing angle is maximal at the resonance, but is the matter effect maximal? Now, for that, what we examined was the conversion probability of nu mu to nu e in matter. And what it depends on is the mixing angle in matter, sine square 2 theta 1,3 in matter, this sine square delta 3,1 m L by E, which is similar to the sine square delta m square L by E term that I showed in the 2 generation. But the three generation effect comes also that there is another mixing angle, sine squared theta 2, 3, which will come here. Now near E, when we have the resonance, then sine squared 2 theta 1, 3 m is 1. However, this phase also has to be maximal for getting the maximum conversion. And sine squared theta 2, 3, at that time, even now maximal mixing was allowed, and that is the maximal value that it can take. So if sine squared theta 2, 3 is 0.5 and this is 1, then this conversion probability 0.5. So in matter, maximum we can have half the neutrinos converting. So we put this condition, sine squared delta 3 1 m, which is, this should be delta 3 1 m L by E is equal to 1. And then what we get is that if we put this, then we get the condition for the maximum matter effect where both these are solved simultaneously, and we get an expression for the length of the density, product of length and density. Now this equation was solved graphically to find the value of for different sine square 2 theta 1 3, that where the matter effect is maximum. And what we find is that if p is equal to 0 and sine square 2 theta 1 3.1, then the maximum matter effect comes at L is equal to 10,000 kilometer. If we go to higher values of p, then we need even higher distance. So for p equal to 0, we need about 10,000, and here we have this p nu mu nu e, which is about 0.5, as we can see, for 10,000 kilometer. So this black is the vacuum oscillation probability, and this blue is the probability when the neutrinos encounter resonance, delta m squared 3 1 greater than 0, because we are considering the neutrinos. And when neutrinos encounter the resonance, for the antineutrinos, because they don't encounter the resonance, this red is the probability. And you can see that there is a very large amount of hierarchy sensitivity at this large distance. So this was the work which we did in this paper. And this paper, and actually this is the second paper. I will talk about the first paper later. And this paper, we understood in great detail the physics of the conversion of the neutrinos while they are passing through the earth, where the matter effect is maximum, where the the interrelation between all the probabilities. And then we did some study on the hierarchy sensitivity, but later on we did a much more detailed study. So I will show the results from that. In my opinion, the main impact of this paper was in understanding the physics in great detail. We also did some discussion on degeneracies, which maybe some of the later speakers will talk about, but so I am not going to discuss that. So, so this is the matter effect in the nu mu nu e probability. Now, as I said, that there are other probabilities. So we have the nu mu, which is the survival probability. So if I have a 3 flavor, then the nu mu can convert to nu e or nu tau, and it can, and a part of it will survive as nu mu. So we examined the interrelation of all these 3 probabilities. Now the expression of nu mu is a bit complicated than p mu e, but we studied that, and what we found analytically was that the condition for maximum matter effect, like this was, we were generating the plots numerically, and then that was helping us in understanding the analytic points. And what we realized is that here the maximum matter effect occurs when the vacuum peak. So in this plot, I show the 7,000 kilometer, the probability p mu mu at 7,000 kilometer. And this black is sine square 2 theta 130, which is for the vacuum case. And we see that the maximum matter effect occurs when the vacuum peak agrees with the resonance. So the energy at which the peak in the vacuum oscillation probability occurs coincides with the resonance energy. And by solving that, we got the L, the length where the matter effect is maximum in the survival probability channel is 7,000 kilometer. So this is the plot which shows that there is a fall in the probability at the at 7,000 kilometer in the survival probability. So there was a rise in the conversion probability in nu mu nu e, and there is a fall in the survival probability nu mu nu mu. Mind you that the total of the probabilities should be 1. So that is expected that if there is a rise in one and the fall in other. However, we found a interesting result at 9,700 kilometer. I think we plotted close to 10,000 kilometer, but later on the 9,700 kilometer became a special baseline. So I am showing you the plot for 9,700 kilometer baseline. Here you can see that there is a fall at the peak with the matter effect. However, there is a significant rise at the deep also. So the way this, the problem was developed was Pamita and Poonam were running these codes and they found this result. And this was somewhat unexpected. And then Raj called me in his office and then we started discussing these results. And I think Raj and Uma, Pamita and Poonam, they were already working on that. And then I started the discussion and it was very kind of them that they also included me in this interesting work. So what happened for this 9,700 kilometer, in order to understand that, what we did was we studied the, somehow we realized that we have to see the nu mu nu tau conversion probability. And why that is interesting is because, if we consider 2 generation, then there is no matter effect in the nu mu nu tau channel. And that is because only the electron neutrinos undergo the charge current interaction and as well as the neutral current interaction. But the nu mu and nu tau both undergo only neutral current interaction, which is the same. And for the matter effect to make a difference in the neutrino oscillation probabilities, what we need is that this potential should be different between the different species, so that causes induce a effective mass square difference. But because the nu mu and nu tau interact in the same manner in matter, there is no matter effect in the 2 generation nu mu nu tau propagation in the neutrinos. So for instance, if we consider that time the super Kamiokande results, then vacuum oscillation of nu mu nu tau was giving a good fit to the data. So it was very, very interesting that when we come to 9,700 kilometer, we see that there is a matter effect here, as because sine square 2 theta 1 3 is in the mu tau channel. For sine square 2 theta 1 3 0, it is the vacuum probability, and with matter there is a dip in the probability. And this dip in the probability was showing as a rise in the p mu mu survival probability, which I showed in the previous plot. And so it is not surprising that they occur, the maximum matter effect occurs for the same condition which I said for p mu mu, which is when the resonance energy coincides with the vacuum peak, which is being shown here. And again, we worked out the condition for maximum matter effect. And what we show was that, and by solving this equation, we got L as 9,700 kilometer. And then we found out the change in the mu tau probability, which is the matter minus vacuum, and we got this nice expression. And I remember that Uma was in HRI, and he actually obtained this expression when we were all working together. And this showed about 70% matter effect, which is also for a sine square 2 theta 1 3.2, which is also shown in these plots. And I think this expression helped us. This paper was published in PRL, and this kind of analytic expressions, mind it that we generated all these plots by solving our numerical code. Pamita and Poonam generated that. And however, these analytic expressions helped us in getting this paper published in PRL. And that was our first paper published in PRL. And just to tell you the physics in this, so what happens was that, when I take delta 2 1 is 0, then here it shows the mass states and the different matter components. So when I have A is 0 and delta 2 1 as 0, then you can see that this is nu mu and nu tau, and this 2 state does not have any nu e, and the 1 state does not have much a proportion of nu mu and nu tau. But when we have the matter effect at resonance, we can see that all the states have significant component of nu mu and nu tau. And this is why the matter effect occurs in the nu mu nu tau conversion probability. So this is the comparison at 9,700 kilometer and 7,000 kilometer. So this is what I said, that no matter effect in two flavor nu mu nu tau oscillation, since both interact via neutral current. At 9,700 kilometer, we get significant matter effect in p mu tau. And this is a, see, 7,000 kilometer, if you consider p mu tau, there is a mild effect, but at 9,700 kilometer, because we hit the resonance, there is a large effect of this. And what happens is that this is a genuine 3 flavor effect. In 2 flavor, we don't get this. And so this is the baseline covered by atmospheric neutrino. So I will take a digression that, people talk about sweets and Uma. I remember that after this paper was published in PRL, I was visiting IIT Mumbai, and then Uma got some sweets from Kami Sweets, this famous orange burfi. And we all had these sweets. Uma gave the whole department the sweets, because this was our first PRL paper, Uma's first PRL, my first PRL, our group's first PRL paper. And I was so like these orange burfis that whenever I go to Mumbai and I get a chance, I always bring those back. That was the first time I had those orange burfis in Kami Sweets. And I hope after the lockdown goes and Ahmedabad and Mumbai becomes better, I will have another opportunity to visit visit IIT Mumbai and Mumbai again and have all these. During this course of these works, I visited IIT Mumbai many times, and it was really nice having all these discussions and physics and non-physics. So I will come to the physics. Now, as I said here, these are the baselines I talked about, 7,000 kilometer, 9,700 kilometer. These are, although there were proposals, but these are difficult to achieve, and one needs much more power in accelerators. So what happens was that but atmospheric neutrinos pass through these distances, and we studied this for various atmospheric detectors with an emphasis on INO, but we also compared with the hyperkamiokande detector, which is a water Cherenkov detector, and we also did a study for a liquid argon detector. Dune is now planned to be a liquid argon detector. So the basic features is this magnetized iron detector, which is a prototype is INO, which is they are sensitive to muons and they have charge discrimination. We have the water Cherenkov detectors. They are like the super kamiokande, and the planned is the hyper kamiokande detector. They have no charge ID. However, they are sensitive to both electron and muon events. And liquid argon detector is a time projection chamber. They are sensitive to both electron and muon events. And there were some papers where they discussed that whether there can be charge ID for both muon and electron events. And if it is so, then it could be the ultimate detector, because as we discussed, Raj also said, I also said that the charge ID is very important for to tap the atmospheric neutrino resonance or the CPT violating effects. So I just show one slide on our work, which is the hierarchies, comparison of hierarchy sensitivity in different detectors. So we did a chi-square analysis, and for INO, because there is charge sensitivity, we added the muon and the anti-muon chi-square separately. For hyper K, because there is no charge sensitivity, we took the muon and anti-muon as same, and we had the chi-square, which is muon plus anti-muon. However, because hyper K has sensitivity to electrons, we added the electron events with this. And for the liquid argon, the muon charge sensitivity we took sensitivity in the range 5 to 10 GeV, because this was some experimental paper which we found that who is doing this. And then we got these results. The results, like, we got, this was 1 megaton year INO, this was 1.8 megaton year hyper K, and this was 1 megaton year liquid argon. So what we saw was that, for what sine square theta 1 3 value, that time sine square theta 1 3 was not known. So we plotted and show what kind of hierarchy sensitivity we obtain. And what we were, this is little that, we saw that 3 sigma sensitivity we obtained for 1 megaton year for sine square 2 theta 1 3 less than point. For 0.1 we got more than 3 sigma for INO, and we got less than 3 sigma for hyper K. But for liquid argon we got almost we got more than 4 sigma. So later on, we worked on this liquid argon, this paper, and because this was the ultimate neutrino detector, this paper was also published in PRL. In this, we also studied the octane sensitivity for the in the liquid argon paper. And during course of these papers, especially this PRL paper, I was in already in PRL, and Uma used to come to Ahmedabad, and Uma's sister was staying in was Uma's brother-in-law was my colleague, and Uma used to stay in the same building as mine, and Uma will come to my house, and we will be sitting with the paper, and we will be meticulously making the corrections to the paper and discussing the physics points. And the famous dialogue in this will be, people who know us know that I will be saying something very fast, and then Uma will say, wait, Subhabati. And then he will explain very meticulously and precisely what we should write. And then we will write that. And I think in all these, during all these things, we became he was first my teacher, then from collaborator, we became good friends. And this is the good thing in high energy physics, or I think in the community, that there is no kind of hierarchy, and the only hierarchy that we discussed was the neutrino mass hierarchy. And I felt that we are really good friends, and we had many overlaps. I remember in CERN I was visiting, and Uma and Kajuridi were also visiting. We were all staying in the CERN hostel, and they took care of me. They will be cooking and we will be eating together, and we had really nice times there. And this is another photo that this is in 2018 when we went to ICTP. Those were the nice times where you could travel. And I and Uma went to Ljubljana, and these are photos from the Ljubljana trip where we shared very nice views and scenery. And is what I want to end my slide with, that this was what I find in the internet, that ask a question, and for Uma I say that ask any question and you will get an answer. So that's Uma for us. And with this I will thank you. Happy birthday, Uma, and thanks a lot for your collaboration, from which I learned a lot.
Yeah, thank you, Srubhavati, for that detailed talk and all the nice things you said. And certainly our collaboration is one of the highlights of my research. And yeah, both in my visits to Allahabad, to Ahmedabad, and of course that visit in summer of 2018 to ICTP and Ljubljana, they were very memorable. And thank you for the collaboration and for the many memorable discussions we have had.
Yeah, I think we need to get that orange burfis. I don't remember having it.
Yeah.
Well, it's 15 years ago.
By the way, he came when his paper count was 50. I don't know. That was about a year back?
No,
or?
no, in February
Uh-huh.
this year.
So once he comes home with a box full of sweets, I said, what is it for? He says, it's for the department. He says, my paper count is 50. And,
but Kajuridi, you can make rasgulla, so you can't complain.
I don't make rasgulla.
You were making once, I remember.
No, that was when we were in Geneva. But otherwise, he had to get to buy things, and wherever he goes, he will bring sweets there.
Yeah, thank you, madam, for talking in so much detail about your work done with sir. And I hope you will again be part of, I mean, you will be attending the whole thing, but especially from 4 to 5, you will get like more opportunity to talk about sir. Shall we take a short tea break? 10 minutes?
Yeah, okay.
Okay.
Yeah, so yeah, the tea will not be served outside, so we have to go to our kitchen and make tea.
Yeah.
And come back in 10 minutes.
Ashutosh, I am in my office, so I need to make tea in my office.
Okay, fine. Okay.
So this is what is called ET break.
So these tea breaks used to be integral part of our discussion, Uma, if you remember.
So Ashutosh, I'll be talking after tea break, right?
Yes. Just after 10 minutes, we'll be coming back in 10 minutes, and then you can start. I will just okay.
Okay.
Hello, Sanjeev. How are you?
Yeah, Shutosh. After a long time.
No, this is Ushak.
Hmm?
This is Ushak.
Oh, this is Ushak. Okay, I thought Ashutosh. Okay. Let me see. Okay. How are you, Ushak? You are in
Yeah, I'm
Johannesburg?
good. Yeah, I'm in Johannesburg.
Good, good. Where is Shuprab? Shuprab,
Suprab is
Brazil.
in Brazil.
Suprab is probably sleeping. He is in
Oh,
Yeah, it's night for him.
he's not going to disturb his sleep.
it's it's 2 a.m. for him.
And he has a small baby,
Yeah.
so he needs to sleep.
Yeah.
Yeah, he said he will join in the afternoon session.
In the afternoon. Hi Shushan.
Hi.
Extreme apology. थोड़ा चुप बैठा हूँ मैं.
No.
Trying to find out bread and butter for my group. So
Sure.
I'll get back to you, man. Don't worry.
Sure.
I could not respond.
Hi, Sushant.
Hi.
So how was your trip back?
A little chaotic because
Sushant, you are in Bombay.
yeah, I'm at my parents' place right now.
Oh, good.
Yeah.
Are you in quarantine? Self-quarantine?
Hello.
So I was in quarantine in a hotel for 1 week, and
Can you
now
hear
I
me?
have to be in home quarantine for 1 week.
Oh, okay.
Hotel quarantine was told you from the airport?
Yeah, directly from the airport, they gave us some choices of
Hello.
hotels, and yeah.
So how much did they take for the hotel quarantine?
How much is the?
Did they
How
charge
much
you
did they
money
take?
for the hotel quarantine?
So they had a lot of options, ranging all the way from mid-range hotels to 5-star. I chose something which cost me around 3,000 per night, and it was 7 nights.
And they provided you the food, or did you
Yeah.
have to buy the food
No,
separately?
everything was included. They would come and put the food outside the door. You pick it up from the door. You leave the plate outside the door. You don't step out of the room at all.
And this place is close to Andheri or closer to your home?
The quarantine place?
Yeah.
That was in Delhi because my flight landed in Delhi.
Okay.
Oh, then again you have to come back to Bombay from Delhi. Oh, it was a hectic day.
Yeah.
So Sushant, why did you come back during this pandemic?
At some point, I have to join my next job, which is in August. So
okay, that's why.
Yeah.
It was a bit scary, right?
Yes, Korea was relatively safe.
Yeah, but coming to India, traveling to India.
Sure, that too.
So my internet is very unstable because of heavy rain here last night. So Ashutosh, if you can't hear me, just chat or something. Okay. Yeah. And Sushant, I was telling, then I got interrupted that, I need to respond to you. So, just bear with me.
No,
There
sure,
are
I understand. It's a difficult time for everyone.
very difficult time. But I will get back to you.
Sure.
For sure.
Casual chat. So, Sushant, when exactly did you come to India?
Last Sunday, so 7th of June. 7th to 14th, I was in Delhi, and then 14th, I came to Bombay.
So Sushant, when you came from Delhi to Bombay, then they told you that you have to home quarantine?
Yeah.
Okay, so here nothing, Gujarat is bindas. Like no quarantine.
Right.
If you are asymptomatic, I shifted to
quarantine.
No, something similar happened in Bombay also. A faculty from TIFR, he was in, I think in Germany in mid-March. And when he returned to Bombay...
Works with Umar Shankar.
Yeah, so to share my... Right, so... Can you see my screen somehow?
Maybe
No,
there is
not
some
yet.
No,
delay.
we can't see your screen, although you are visible.
Yeah,
Now,
now the screen is.
now it's okay.
Okay, so let me go to full screen mode and then I can.
It's already full screen.
Is it so? No. Let me do that. Yeah. Yeah. So I hope I'm audible, right?
Yes, yes.
Yeah. So Ashutosh, just my internet is not working. So if I got stuck, let me know. Okay.
Fine.
Okay. So first of all, I would like to really thank my friends Sushant, Ritanjali, and Ashutosh, and Professor Ramadevi as well. All other colleagues. They took this, attempt. They made this attempt to celebrate Professor Umar Shankar's 60th birthday. So I'll be in a very light mood today, discussing physics. But I would like to tell that my first interaction with Professor Umar Shankar was in 2005, another disaster period in Bombay, heavy rain, August 2005. It was a heavy rain there, and there was a neutrino satellite meeting. And that was my first kind of quote and unquote international gathering I attended as a PhD student. And I was asked by Professor Naba Mandal to give a talk on beta beam. And I was working on beta beam. So that was my first interaction, face-to-face interaction with Professor Umar Shankar in 2005. But as you know, I just, I was born at that time, basically, in the community. So I didn't have courage to talk to him. But I knew that, he is a very good teacher. I used to follow his lectures, xeroxing things and all like that. So, I used to take tea and listening to him when he was talking during the satellite meeting. But I didn't have courage to talk to him because you see a newcomer, and but I gave a talk in front of him on beta beam. And later, when I was working with ARC in HRI with Shondadi Shubhavati, I had many discussions with Professor Umar Shankar, but we never collaborated face to face. But definitely regarding long baseline physics, his paper were the papers on Minos, on T2K, Nova, on in general art matter effect, the paper that Shubhavati discussed today. Those were the papers which were lying on my desk to learn about matter effect, long baseline physics, three flavor effect. I must admit, these are the days when you admit things. So this is the way I started. And then another interaction, he was my thesis referee. I remember. So Professor Umar Shankar didn't know that Calcutta University defending a thesis is not like institutes or like IITs. So when I was in US, I got a report from Professor Umar Shankar, and these were very minor comments. But for that, I need to go back to India, make corrections, bind another 6 copies of thesis, sent to him, and then later on, when he realized that Sanjeev, it was too much for you, so I could have just avoid that. But he was my thesis referee. So now, the work that I am going to discuss today, we did together in 2012 and 2013. And that was a very important phase. That was a very important phase in my life, in my career. And at this point, I would like to thank my intimate friends, Sushant and Suprav. Not only I learned from Professor Umar Shankar, the physics of long baseline, but from my friends Sushant and Suprav. Okay, what I know today, mostly because of the discussion from my friends, because they were so open, they were so close, I could just reach to them, ask questions. So really, I enjoyed working with Professor Umar Shankar, and that time Sushant and Suprav were his students. And now they are the budding physicists, in long baseline or neutrino area. So I really enjoyed that phase, and I'm just going to share few of the things which we learned during our work, and still those are valid today. Okay, they are still relevant, and if somebody wants, they can still work on these issues. So you see that I thought that I should put my title 3 flavor effects in long baseline experiment. So I will not take much time for this slide. Okay, let me see how can I. So things are coming on my way. Okay, is there a way to just remove the faces? These are they are covering my slide. Okay, okay, yeah. So this slide has been already discussed by Shubhavati in detail. So, but still, I just want to tell that when we talk about three flavor effects, before the discovery of diabe theta 1,3 in 2012, we all know that it was quite possible to explain the existing data.
Your slide has not changed for us.
So this is first slide, three flavor.
No, we cannot see. We only see the title slide right now.
Introduction. Yeah,
I think you have gone to the next slide, but we cannot see that.
Right now?
No.
Oh, okay.
Yes.
Yeah.
Now it's fine.
Oh, yeah. So, yeah, I'm telling you this is internet problem, but okay. So I'm in my first slide. Okay. This slide has been already discussed by Shubhavati in great detail. But I just want to emphasize that before 2012, because our work was in 2012 and 13, before the diabe discovery, it was quite possible to explain all the data in we hit the bullseye at the right time, just after the discovery of diabe. I hope I'm audible. We got connected and we started talking about that what could be its implication and what is the role that this theta 1,3 is going to play for future measurements. And that's why, our discussion started. And I visited IIT Bombay for my job interview, I still remember. And that time I was discussing with Sushant and Shuprav that, can we work on T2K Nova, see the implication of large theta 1,3, because there was already some hint from T2K, okay, that theta 1,3 is going to be large, close to 10 degree or so. So let me move to my second slide. I hope my second slide is visible to all of you. This is matter effect. This has been also discussed by Shubhavati in great detail. So neutrino and an anti-neutrino transition probability, even if your CP phase is 0. So matter causes fake asymmetry in your three flavor scenario, even if your CP phase is, yeah.
Sanjeev, can you please switch to video, because I think there is some time lag. So maybe if you switch off your video, then I think.
Okay. Let me see. Yeah, I'm very sorry. This is happening from yesterday.
Yeah,
so,
now your slide has changed. Yeah.
Yeah. Okay. How can I switch off my video? Let me see.
There is a left side.
Yeah. I knew it is not coming. Let me see.
Escape then.
The second icon from the left side.
Yeah, stop video. Now it is my video is not there.
Yeah. Yes. Yeah.
Okay. If my slides are visible still.
Yes, your slides are
visible. Yes.
Okay.
This is present status of oscillation.
No. So I am in the matter effect part. So as I was telling, thanks Ashutosh reminding me that I am not visible, or my slides are not moving. So as I was telling that, I'm just mentioning the discussions that we used to have during our work with Professor Umar Shankar and Sushant and Shuprav, that, how can we, get information about the actual CP phase suppressing this fake asymmetry, and what is the role of theta 2,3, theta 1,3, and this delta CP can play in that direction, and also the hierarchy in the neutrino mass pattern. So these were the issues that, even if CP phase is 0, there can be fake asymmetry. And what can be the maximal matter effect we can get from baselines like more than 1,000 kilometer or below 1,000 kilometer, which is the baseline we need so that we can tell about hierarchy or CP violation, suppressing this fake asymmetry. So these were the issues we were discussing. And so let me move on. And this is just to set the stage that now we have roughly this picture that theta 23 is the hint is that theta 23 may not be maximal. We have established theta 13, so no issues with that. Delta CP we are learning from T2K and NOVA, and we know that its value at 90 degree has been ruled out at quite a high confidence level, but still we have a long journey to go. So now I am on my slide number 5. So mostly in our work with Professor Umar Shankar, we were trying to address these three major issues in light of large theta 13. Okay, that what information can we have on the neutrino mass ordering when T2K and NOVA will start taking data, and if they will not be able to tell us the entire story, can future experiment tell us the whole story? So the first issue was neutrino mass ordering, and the second issue was also because by that time from MINOS data there are also some hint that theta 23 may not be maximal. So we were discussing very closely. In fact, in our second work with Supram, this work I enjoyed the most, I must say. We started discussing that let us explore this issue of octant in 3-flavor framework, and we understood that we need to measure theta 23 very precisely. We need to establish that it is deviated from 45, and then the issue of octant will come, that whether it is below 45 or above 45. And then there was this third question, that whether we have CP violation in neutrino sector like quark sector. So these were the three issues we addressed in our work. And now let me go to my 6th slide, and just I want to motivate that why 3-flavor and how 3-flavor affects these measurements. So this is the well-known nu mu to nu e transition probability. If you expand the probability expression in alpha, as Shubhavati was mentioning, that when you have one mass scale dominance, this alpha is 0 basically. But now alpha is around 3%, and from Diabe we know that sine 2 theta 13 is around 0.3. So you can see the leading term in this nu mu to nu e expression is around 10% or so, sine square 2 theta 13. So this slide tells you that you can only see nu mu to nu e transition at atmospheric mass scale if theta 13 is non-zero. So if you see any nu mu to nu e transition working at atmospheric mass scale, then this will tell you that theta 13 is also non-zero in reality. And you can see from this slide that you need theta 13 to be non-zero so that you have finite nu mu to nu e transition. But at the same time, you can see if you want to measure the octant of theta 23, you have to rely on this channel because it comes with sine square theta 23, not unlike nu mu to nu mu, which is dominated by sine square 2 theta 23. So you need to rely on this channel, the leading term, especially this theta 23, which gives you the information on octant. But as you see, you have one equation, but you have too many unsolved issues, too many unknowns. So there will be degeneracies. And that was one of the most important things that we elaborated on in our work, that how this issue unknown delta CP, how this issue of neutrino mass ordering, because you can see this A hat and delta we don't know the sign of delta M31 square. So your delta can be positive or negative. And also this A hat can also be positive and negative for a given polarity depending on the mass ordering. So once you don't know the sign of delta or A hat, you don't know delta Cp, how they can influence the measurement of octant of θ23. So in fact, if I remember, we were the first to address this trio, hierarchy, θ23, delta Cp degeneracy, this trio in a unified framework of three flavor oscillation. Okay, in our work with Suprav and Professor Umar Shankar. And also you can see if you want to measure delta Cp, or if you want to say something about Cp violation, that your Cp phase is 0, no, not 0 or pi, then also you need to bother about octant, what is the value of θ23, you need to bother about hierarchy. So all these issues are related to each other, but most important, these effects are not big. These are at most 5 to 10% effect. So these are subleading, and these are three flavor effects, because if θ13 is non-zero, then only these features come into the picture. And we were lucky that Diabe told us that time that indeed θ13 is 10 degree or so. So you are happily work in three flavor framework and try to address these issues. So that was the platform, okay, of our work. Now, I'm on my 7th slide. So, sir, I'm very happy to tell you that most of our work got highly cited, you know, in neutrino literature. So the first work in the left that we did with Sushant and Suprav, now it has around 70 citations. And the right, you know, another paper with Suprav and Professor Umar Shankar, now it has more than 70 citations. Okay. So let me just tell you briefly what was special in left-hand side, this paper. Okay, in 2012 Neutrino conference, Nova collaboration came up with some new idea that how they want to optimize their event selection, because at that time we knew that θ13 is large. So after the θ13 discovery, in that conference, Nova presented new analysis optimizing their event selection. And we just hit upon that. I think we were the first to apply those features in GLOBE's framework. And I remember those, you know, long nights working with Suprav and also Sushant, okay, that how to implement those features one after another. And we implemented those in GLB files. And I'm happy to say that still the entire community, most of the community is using that GLB file, okay, to correctly describe Nova. So that's why we call this in paper new Nova after θ13. So we optimize Nova and T2K to get the best out of for these three issues in the left paper. And at that time, there was some discussion that in the Nova baseline, can we put some other detector by Jenny Thomas and company? So we also discussed that in this paper. And in the right paper, I think after the discovery of θ13, this was the first paper on octant, okay, discussing the nitty-gritty of issues related to octant in light of large θ13. So let me proceed and show you some results before I wrap up. So this is a very busy slide, but let me just explain few things which I learned. You know, I was making these plots for last, like that time, 5, 6, 7 years. But I didn't have that eye to look upon at the degeneracies. And it was Professor Umar Shankar, because, you know, sometime I was in hurry to tell my things. But then as usual, he will say, Sanjeev, slow, stop. You need to learn this. You need to listen to this. You need to understand this. So, you know, this is the time that, you know, I should, you know, share. So I still remember that he used to tell us to stare at one plot for longer time and come up with these minute details, which I can say that now I understand happily, okay, because of him, you know. So in this plot, you can see we just plotted the probability, simple probability for assuming various neutrino mass pattern like normal ordering or inverted ordering. and these bands are due to unknown delta Cp. I learned in this work, when I was working with Sushant and Suprab, that the values of Cp phases for which in T2K experiment, the band of NH and IH gets overlapped, those phases can be different for nova. Okay, if you see the lower left plot. So you see there is an overlap for NH and IH due to the unknown Cp phases. And if you see the value of Cp phases which overlaps there, they are not exactly the same in case of nova because of the energy and the baseline of nova and T2K are different. So you need complementary information. But I still remember that I learned and we went into the code, saw the output file and literally saw that the Cp phases which are overlapping for T2K and nova, they are different. So if we combine, we gain. And in the right, we saw that when you have more matter, you have more discrimination between the normal and inverted ordering. If you have more and more matter, say 2300, on which Professor Umar Shankar and his students work on magic baseline, dimagic baseline, close to bimagic, you know, you have a large separation between NH and IH. Okay, so this was just to motivate, you know. And in my next slide, slide number 9, I hope that my slides are getting changed. This was, I feel, very good because something totally new I learned with this work with Suprab and Professor Umar Shankar, that when you want to measure the octant, means you want to measure on which octant theta 1, 2, 3 belongs, whether it is below 45 or above 45, information from neutrino and antineutrino are mandatory. And that was the message for the first time we showcased in this paper. And I just want to elaborate on that. If you see the left panel, the simple probability plot again, here we have plotted the band for the unknown Cp, but there are two bands, one for lower octant value, we took say theta 2, 3, 40 degree, and one is higher octant value, say 50 degree. And you see that there is an overlap, means there are some unfavorable values of Cp phases for which you can't discriminate between lower and higher octant. But when we saw that what are those values, we saw that, you know, the critical values are for higher octant and plus 90 degree values and the lower octant and minus 90 degree values. They were giving us the trouble. But then when we went to the anti-neutrino, the right hand plot, you see those two unfavorable combinations were the favorable combinations for anti-neutrino. Okay, so at least I learned for the first time from this work that how crucial can be the anti-neutrino run, the data, to resolve the octant ambiguity. Earlier, I had the impression that you need neutrino, anti-neutrino for Cp measurements, but it is needed for octant. I learned from this, thanks to the work that we did, you know, with Professor Umar Shankar. So, just some results. Slide number 10. These are the plots from the paper that we wrote with Sushant and Suprab. And I can tell you that these sensitivity results of T2K nova on mass hierarchy or Cp violation are still valid. You know, nothing has changed. They are just reaching there, okay, slowly. And you see, they have this one after another, the new results. And if they will accumulate really the data, they will give you something like that. No exception, okay? So we could successfully demonstrate what we are going to expect from T2K and nova in this work. And you can see that, you know, we wrote new nova, as I explained, that we indeed included new features of nova first time in this 2012 paper. And we showed that this is the capability of T2K and nova. And indeed, I can still defend these slides now in 2020. Okay, so next slide, slide number 11. This is a very slide which is very close to my heart, these two plots. We learned from these plots that at that time, T2K collaboration was thinking to have only the neutrino data to devote entire exposure for the neutrino run of 5 years. But then we realized, if you see in this plot, if you see the solid blue line, you can see that, this is the capability of discovering octant. And then we realized that if we make this exposure half and half, based on our probability understanding, if we take half and half exposure in neutrino and antineutrino for T2K, this can make sure that you have quite a good octant discovery combining nova and T2K. And you can see this plot here. You can clearly see that if you have T2K and nova together and T2K half neutrino, half antineutrino, you do better. Okay, you do better. And you claim the discovery above 2 sigma confidence level. Okay, so the important message was that T2K must run in both neutrino and antineutrino mode. And indeed, this is what we are seeing now. The T2K have gathered neutrino information and as well as antineutrino information. So I will not be exaggerating if I say that somewhere this work also worked as a motivation for the community that we need antineutrino data, not only for CP but for octant also. Okay, and these are some results. I don't want to elaborate in this light mood meeting. This is the capability of resolving octant in my slide number 12, on my slide number 12. And then we wrote another paper. So, sir, you can see we have now 40 citations on this paper that we wrote with Suprab on basically at that time LBNE and LBNO. Now we have Dune. Okay, so we discussed that how Dune is going to explore 3 flavor effects and could address this issue of mass hierarchy, CP and octant. And on my slide number 14, I remember, I think I made Suprab to make this plot maybe more than 100 times. Ye acha nahi hai, wo acha nahi hai, ye nahi hai, wo nahi hai. But, like my buddies, they are so good. They are always making those changes, making happy. And finally, we landed up with nice, beautiful bi-event plot, showing the importance of Dune, showing the importance of wideband beam feature of Dune. This bi-event plot says everything that what Dune can do. But at that time, we took less exposure for Dune. What we can do in an incremental approach. This was the philosophy we had in our mind in this Dune work. And on my slide number 15, you see this was the results we showed in our paper for mass hierarchy. And we showed that LBNE and LBNO, they don't need high exposure for mass hierarchy because their baseline is large. But we showed that if LBNE needs to work with one module, just to highlight, we showed for the first time that if LBNE has to survive with only 10 kiloton, then T2K and nova will be very handy for them. And if you add information from T2K and nova, you get 3 sigma mass hierarchy for all values of CP. That was an important message we conveyed in that paper, that you need to see what this T2K nova is going to tell us if you want to explore something with LBNE, aka Dune, with a less exposure. So that was one of the major highlights of this work. And slide number 16, there were some octant results. We showed that LBNE and LBNO can have 3 to 4 sigma octant discovery, so don't worry. But again, we emphasized that you need both neutrino and antineutrino run if you want a delta CP free measurement for octant. Okay, and I'm on my last slide, slide number 17. And in this slide also we showed that if LBNE needs to start with a single module of say 10 kiloton, then measurement from T2K and nova, you can see in this table, will be extremely useful for them to claim some discovery at more than 3 sigma confidence level for half of the value of CP phases. So I just tried to highlight some of the things that we conveyed through this work. And I want to just tell one thing, that 2012 was very important because I left my postdoc due to some family crisis and I had to take a job, and I landed up in IOP, just finishing very quickly my postdoc. But when you have a new job, you have a pressure, you have to build your group, you have to do so many administration, but you want to make sure your publication is going on. And that was a very critical phase of my career, where I find my friends Sushant, Shupra, and Professor Umar Shankar, that in those 2 years, I wrote these 3 papers, which I feel very good till today. And these papers helped me a lot to establish my feet in the community, to tell what I want to tell. And these papers gave me the platform to learn the basics. It is just not running codes and getting some plots, but there is some interesting physics is there. I had a hunch about that, but the clarity was not there, I must say. But working with these 3 guys, I could get the clarity. And it helped me to establish, in these initial days of IOP, when you have to keep doing physics apart from other things. And I just want to finish with one story, that in one of the NASI meeting, and I was asked to present in 15 minutes your highlights of research, and it was in Allahabad. And in the committee, there are 8 people, and Professor S.K. Joshi was there, Shushanto Dattagupta, H.S. Mani, there are big people were there. So they first asked me everything from quantum mechanics to thermodynamics to everything. But at the end, Professor S.K. Joshi, he left us just last month. He was the chairman of the committee. He asked me, look, man, I think I saw that you have worked with IIT Bombay people. So they are very, I have high admiration for them. So can you tell us, what you have done with those people? It was like a full toss for me, I just straight hit, because this is your forte. So, and they're asking you about that. It was a full toss for me, and I just bang on. I discussed, I convinced them that we could find something interesting for neutrino roadmap in these 3 words. So I would like to just say thank you, sir, for guiding me throughout. You are guiding me still, but somehow, we have not been able to work together in recent years. But I hope, we will be able to get that opportunity again. But we are in constant touch for INO, other physics, and any time I have difficulty, I approach you and you answered my queries, and you helped me to get through that. So many thanks. And I wish you happy health, good health, happy mood, happy food, and happy physics for the times to come. Thank you.
Yeah. Thank you, Sanjeev. And I'm also happy that you referred about Professor S.K. Joshi. He was a frequent visitor to IIT Bombay. And in fact, I've attended 2-3 talks by him. And it feels good to actually hear one of his talks.
Yes, sir. Yes. He was our governing council chairman. So I had that privilege to hear him. Yes. Yes.
Okay, thank you, Sanjeev, for such a nice talk and elaborating all the important results in neutrino sector that you, along with Umar Shankar and other people, have done. And
just Ashutosh, 1 minute. मैं शाम को तो बोलूँगा. सर के साथ खाने जाने में बहुत मजा है. He will plan everything. If you go to have food with him, he will not let you to speak. He will plan everything and you just eat and enjoy. So you don't need to open the menu and tell, okay, I want to eat this. So this is the best.
That is the biggest one we are missing now.
That is the biggest thing we are missing. Yes. कभी आएंगे बॉम्बे सर, एक साथ खाने जाएंगे.
Please do come.
Yes, sir. Yes. By the way, I would like to also thank Kajori Di. I know her for a long time, and she is also inspiring us all the time, basically.
Oh.
So, I think, you allowed Professor Umar Shankar to stay with us in the night, 11 baje, 12 baje, chalo physics karte hain. So, credit goes to you. I never talked about you. So thank you, Kajoridi.
Understanding it is both ways.
Yes. No, but I can only see one way, no, because I didn't work with you there in detail. So, but anyway, thanks a lot. And we'll meet sometime.
Okay, Sanjeev. Thank you very much.
Thank you. Yeah.
So I would now request Ushak to talk about his work with sir. Ushak, are you around?
Hi, am I audible?
Yeah.
Okay. So I am sharing my screen. Just give me a minute. Is my screen visible?
Yeah.
Okay. Yeah, is it visible?
Yes.
Yeah. Hello. Happy birthday, sir. But unfortunately, I have not prepared a slide explaining all our works, all our previous works, because I came to know about it just day before yesterday evening. So I had only one day to make the slide. So what I did was that I had made slides on our last work. So which is basically matter versus vacuum oscillations in this long distance accelerator neutrino experiment. And we did this work in this January and we put it up in archive, and this is in communications with PRD right now. So this is the screenshot of the first page of the paper, and we have done it with another PhD student of him, Suman Bharti, and I think he got PhD only this year, yeah, or last year, and I have forgotten.
About a year ago.
About a year ago, okay, yeah. So I am not going to explain the mixing matrix and the unknowns, because it has already been discussed extensively by Sanjeev and Subhaboti. So I am trying to tell about why it is very important to distinguish between matter effect and vacuum oscillation in the long distance experiment. So when the neutrinos, has already been explained by Sanjeev and Subhaboti, that when the neutrinos propagate through Earth, they undergo forward scattering, and that can modify the neutrino oscillation probabilities. And these matter effects are sensitive to the sign of delta 31, whether delta 31 is positive or negative. And this observation can lead to the discovery of the sign, as been already explained in the previous talk. So when the baseline is less than 1000 kilometers, then the muon neutrino survival probability, the change in muon neutrino survival probability due to matter effect is negligible. But for atmospheric neutrino, there will be a significant changes in survival probability. However, the super-Kamiokande experiment can make a very small distinction between the vacuum oscillation and the oscillation due to matter effect at present. So in this long baseline experiment, the electron neutrino appearance probability is sensitive to matter effect, but they are equally sensitive to the CP violating phase delta CP. So if we have a set of data, there are three possibilities. One is we can have a solution with matter effect and normal hierarchy and a particular delta CP. So say delta CP1. Another possibility is we can have vacuum oscillation and another delta CP, which we call delta CP2. And the third possibility is matter effect with inverted hierarchy and delta CP3, which is a different delta CP. So one of the most important goal of this long baseline experiment is to establish the CP violation in the neutrino sector. So therefore, it's important that we distinguish between the vacuum oscillations and the matter effects. Otherwise, we may get the value of the delta CP wrong. So I think it has already also been discussed, the Kituke Nova experiment. So basically T2K is in Japan. The source is at Tokai at the JPEG accelerator, and the detector is 295 kilometers away. And the mass of the detector is 22.5 kiloton, which is a water for detector. So T2K started taking data in 2009 first, and then they published their results consecutively in 2013, 2015, 2017, and last year they have published their latest result with these POTs I have mentioned. And then Nova is in Fermilab, and the baseline is 810 kilometer, and the detector is 14 kiloton TASD detector. And so Nova started taking data in 2014, and then they published their result in 2017, 2018, and the latest result came in June 2019, so about a year ago. And so this is the oscillation probability, and it has also been discussed already. So this oscillation probability, as we can see, they are dependent. So this is the oscillation probability for muon neutrino to electron neutrino, and we can also find out the oscillation probability for the antineutrinos by replacing by changing the sign of delta Cp and A hat, or delta Cp and A. And this oscillation probability is they are dependent on, we can see that they are dependent on the mass hierarchy, on delta Cp and the octant of theta 2 3. Now the change introduced in this oscillation probability due to matter effect is around 9% for T2K and around 25% for Nova. Now this change is equal in magnitude by the change induced by choosing a different value but allowed value of delta Cp and theta 2 3. So basically the change induced by the matter effect, it can get easily cancelled by choosing a wrong value of delta Cp or theta 2 3. And that's why it's very important. So basically we can get a almost degenerate solution by vacuum oscillation, but of different value of delta Cp and theta 2 3. And that is why it is very non-trivial to differentiate between the matter effect and the vacuum oscillation in this experiment Nova and T2K. So what we did is that we used the GLOBE software to calculate the theoretical event rate, and we calculated the theoretical event rate for three-flavor neutrino oscillation scenario. So we parameterized the matter term by a fact as Q multiplied by A, where A is our standard Wolfenstein matter term and Q is another multiplicative factor. So basically we are allowing the matter effect to be non-standard as well. And when Q is 1, it signifies the standard matter effect, and when Q is 0, it signifies the vacuum oscillation. And we have kept this delta 21 and theta 1 to fixed as the best fit values and allowed all other oscillation parameters in the 3 sigma range, and we varied Q from 0 to 2. And then we calculated chi-square between the theoretical and experimental event by this Poissonian chi-square formula, where this I stands for the bin for which the experimental event rates are non-zero, and J stands for the bin for which the experimental event rates are 0. And this chi-square C, it is from the systematic uncertainty, and we consider 10% overall systematic uncertainty for both of the experiments. So then we calculate the total chi-square by adding up chi-square from all different modes, channels, and experiments, and then we found out the minimum chi-square and subtracted it from all the chi-square values and got our delta chi-square. So this is the first result that we got. This is after analyzing the latest data of T2K and Nova, and we saw that the minimum chi-square was 173.2, which occurred at Q equals to 0.6 and normal hierarchy. Now at Q equals to 1, which is essentially the standard matter effect, the chi-square value is essentially same. And at this Q value for the standard matter effect, IH is ruled out at 2 sigma confidence level. Now for Q equals to 0, which is essentially the vacuum oscillation, the chi-square value is 173.7. So basically, the latest data cannot distinguish between matter effect and vacuum oscillation, and in fact, vacuum oscillation gives as good fit to the data as the matter effect. So then we looked for the expectation from the future run of T2K and Nova, and we considered 5 years of neutrino and 5 years of anti-neutrino run in both Nova and T2K. And we found out that a 3 sigma confidence level establishment of matter effect is not possible by even after 5 years of neutrino and anti-neutrino run from Nova and T2K. And to do this experiment, we simulated the future experimental data using globes, and we used standard matter effect when we simulated the experimental event rate. So then we looked for the expectation from Dune, and we found out that after 1 year neutrino run in Dune, a 3 sigma establishment of matter effect is possible if normal hierarchy is the true hierarchy, but vacuum oscillations can be ruled out only at 2 sigma if inverted hierarchy is the true hierarchy. So then we did some other simulations and found out that if we add Nova and T2K 5 years of neutrino and 5 years of anti-neutrino run with this 1 year run of Dune, then the results get improved very slightly, and we cannot reach a 3 sigma establishment of matter effect even when IH is true. So we found out that to establish a 3 sigma establishment of matter effect, we need 5 years of neutrino and anti-neutrino run from Dune. I have not shown that result here. So what I have shown is that if we want to rule out vacuum oscillations at 5 sigma confidence level, then we need to combine both Nova, T2K, not both, all 3 of Nova, T2K and Dune with 5 years of neutrino and 5 years of anti-neutrino run. And as we can see that the strength of the matter effect can also be established with extremely good precision after this combined analysis. So this is the conclusion that I have already explained. So we have found out that this present data cannot rule out the vacuum oscillation, and the vacuum oscillation give as good fit to the data as the standard matter effect. Then we found out that the future 5 years of neutrino and anti-neutrino run of Nova and T2K cannot rule out the vacuum oscillations as 3 sigma. And then we found out that after 1 year of neutrino run in Dune, we can rule out vacuum oscillations at 3 sigma only if normal hierarchy is the true hierarchy. And to get a 5 sigma exclusion of vacuum oscillation, we need the combination of Nova, T2K and Dune with 5 years of neutrino and 5 years of anti-neutrino run. Yeah, thank you and happy birthday, sir.
Thank you, Shak.
Yeah, and so what I want to say is that whenever I face any problem in physics or in life, the first person I call to is Professor Umar Shankar, and I really miss his sense of humor. Means his anecdotes about physics, his stories. I remember we invited him to our place for dinner one night, and he said that he does not like the new guest house of TIFR only because they do not make good aloo paratha. And yeah, so I really miss his stories about the physics. I remember he told me a story that there was some conference and somebody said that today's data is tomorrow's calibration, and Feynman stood up and said that, and day after tomorrow's background. And he has all these kind of stories always with him about how the physics develop, about how the particle physics develop. So thank you. But the sad thing is that day before yesterday when Gitanjali called me, she asked me if we have a photograph together, and I found out that in last 10 years we did not take a single photograph together. So next time we are going to meet, we have to take a photograph together.
Sure.
Yeah, that is something I don't know how you people missed.
Yeah, I don't know. Apparently only Suman considered that he should take a photograph with him.
By the way, there is an addendum to the story that you just said about somebody saying yesterday's discovery is today's calibration. I made this statement while giving a talk, and that audience, in the audience there were in the audience there were 3 people who got their PhDs from University of Chicago, and they all sort of later caught me and chastised me. What do you mean somebody? It is for me. So, I mean,
But when you told me the story in your
But they like this.
when you told me the story in your INO classes, you mentioned somebody. You did not tell us for me.
So the last 1/3 portion is told by collective when LHC was being studied.
And I am sorry, probably I will not be able to present in the second half of this meeting because I have an appointment with my eye specialist. So if I miss that session, so please pardon me. But we will talk later.
Yeah.
Okay, Ushak, thank you very much. And now we will move on to the last talk of the morning session by Sushant.
Yes. So hello, everyone. I hope you can hear me.
Yeah. Go on.
Right. So the tentative title that I gave for the talk was Future Prospects with Neutrino Oscillations. Turns out that's a lie. I will only be talking about some aspects, in particular mass hierarchy and CP violation discovery. And the work that has been done over the last few years. And in particular, I will stress on some work that I did with Professor Umar Shankar a few years ago. Before I start, maybe a short anecdote. There was, so once during our coursework, Professor Rustagi, who was teaching us atomic and molecular physics, had taught us perturbation theory. And Professor Umar Shankar, who was teaching us quantum mechanics, was waiting outside the class because his was the next lecture. And he comes in and he tells Professor Rustagi, okay, you have already taught them everything. Now, what am I supposed to do? And I bring this up because I guess I should say the same thing to Sanjeev right now. Because there is some overlap between what he discussed and what I discussed. Anyway, so moving on, I'm hoping you can see my shared screen, right?
Yeah, I think you have to make it full screen.
Yeah, I'll just do that. Is this better?
Yes.
Okay, great. So, well, this has been discussed extensively before. The only thing that I will remind you over here is that there are 6 parameters that we are interested in measuring. There are 3 mixing angles, 2 mass square differences, and 1 CP phase. And the story, I'm going to start around 10 years ago, which was around the time that I started my PhD, so around 2008, 2009. And of course, it seems like a long time ago, but it looks like neither of us looks very different today. So there is some time translation invariance over here. Then if we look at very well measured, the solar parameters. We were just beginning to get some hints about the value of theta 1,3 and then eventually from the reactor neutrino experiments. But the main unknowns were still the neutrino mass hierarchy, which is whether it's normal or inverted, the octant of theta 2,3, whether theta 2,3 is less than 45 degrees, so in the lower octant, or greater than 45 degrees or in the higher octant. And the value of delta CP back then was totally unknown. We had absolutely no idea what this phase was. And the way to measure these unknowns would be with this nu mu to nu v oscillation probability, which is measured by various experience. This oscillation probability in one of the various mixing factors. And the relevant terms are sensitivity to the mass hierarchy, the octant of theta 2,3 and delta CP comes from. In particular, you can see that so delta CP dependence comes from the second term, and the mass hierarchy sensitivity appears in this A hat, which contains the Wolfenstein matter potential. So various experiments like
just 1 minute. Your voice is actually getting garbled, so maybe turn the video off.
Okay.
But you are sharing.
No.
It's okay.
Personal.
Sharing is different. Yeah. Okay. Can you maybe turn the video off so that?
Yeah.
Yeah.
Only your videos. The sharing screen should be there.
Yeah, I'm going back to it. Okay, hopefully this works better.
No, they
Does it? Can you hear me clearly, or is it still garbled?
It's fine.
No, it's better now.
Okay. So the main problem in measuring these unknown parameters is what we call the problem of degeneracies, which is that you can have various combinations of the unknown oscillation parameters giving you the same probability. So here on this slide, you can see the nu mu to nu v oscillation probability for the NOVA experiment and for a specific energy close to the oscillation peak as a function of the CP violating phase, and for various different combinations of the mass hierarchy and the octant of θ23. And the left panel being for neutrinos and the right panel being for antineutrinos. And you can see that if an experiment measures a certain value of the probability, more often than not, it is possible for various different combinations of these parameters to give you that same value. And this is what really spoils our ability to measure these parameters. Now, in the work that we did back in 2011, 2012, one of the things that we noticed was that if you consider the normal hierarchy and a value of delta Cp close to minus 90 degrees versus or you take in there's no degeneracy. And the reason
your voice is breaking.
Still? Oh.
Yeah. Okay, you continue.
Okay. Okay.
Just repeat. What did you say? Like 1 minute before. So
okay,
that would be.
Okay. So if you have the normal hierarchy and a value of delta Cp close to minus 90 degrees, then as you can see in this figure, the probability is quite high, and it is usually not possible to mistake it for some other combination of parameters. And the same fact holds if you have the inverted hierarchy and a value of delta Cp close to plus 90 degrees. And the reason for this fact can be understood based on this formula that I had shown earlier. So when you're close to the oscillation maximum, so where delta is close to pi over 2, then delta Cp will increase the probability, and when delta Cp is close to minus 90 degrees, that increases the probability. And if it's the normal hierarchy, so A has a positive sign, that also increases the probability, which is why you end up with getting these favorable combinations of the oscillation parameters. The other hand, unfavorable combination, it is possible to make the normal hierarchy with unfavorable combinations. And so when you look at the sensitivity of the experiments NOVA and T2K as a function of delta Cp, you can find that the sensitivity is usually quite high in the favorable part of the parameter space and quite low in the unfavorable parts. And we showed that if you take a combination of NOVA and T2K, then there is a synergy between them, which improves the sensitivity even in this unfavorable part. What is interesting in this is also that these favorable and unfavorable combinations are the same for both neutrinos and for antineutrinos. And this is in contrast to, say, for the octant sensitivity, which Sanjeev discussed earlier, where the favorable, unfavorable combinations are opposite for the two polarities. So over there, you can break the degeneracy by just switching the polarity of the neutrinos. Over here, it is not quite so straightforward. This paper was very well received, again, as Sanjeev pointed out, and it has a large number of citations. Also, with regards to CP violation, the same thing holds. If nature has chosen a favorable combination of parameters, then it is possible to determine delta CP or to discover CP violation as long as it is close to the maximal value. However, if it's an unfavorable combination, then some more strategies will have to be evolved. For example, adding information from T2K in this case, or eventually even from atmospheric neutrinos. So that was back in 2011 to 2013. That's when we were working on those papers. Over the last few years, T2K and NOVA have been taking data. And what we had discussed in those papers actually was borne out by the data itself, because just within a few years of running, T2K was able to give hints for the mass hierarchy and for delta CP. And the reason for that was that nature had chosen a favorable combination of the parameter values, as far as we know at the moment, of course. So that is what came out from the first set of T2K data, favoring normal hierarchy and favoring a value of delta CP close to minus 90 degrees. And then, of course, eventually, if you want to get better sensitivity, then the thing to do would be to use atmospheric neutrinos. And the reason for that is that atmospheric neutrino experiments are typically insensitive to delta CP. And also they have more matter effects, which help to break the degeneracy. And various studies, including involving ICAL, which Professor Umar Shankar has worked extensively on in the past. And also in this work that we did with this hypothetical liquid argon detector, which has been magnetized, we showed that you can have very good sensitivity to the mass hierarchy. Likewise, you can also improve the CP violation sensitivity if you include information from atmospheric neutrinos. As you can see that the parameter space, the allowed parameter space shrinks considerably, and it is possible to pinpoint the correct value of delta CP to reasonable accuracy. So to give you a physics summary, there are parameter degeneracies which make it difficult for us to measure the oscillation parameters. But if you take a synergistic combination of various experiments, it is possible to lift these degeneracies. We, in our papers, of course, to get to be able to measure these parameters conclusively, you will need further data from long baseline experiments like DUNE, T2HK, etc. So to end, I would like to wish Professor Umar Shankar happy birthday once again. I think he's the best advisor that I could have asked for. It was great working with him, learning from him. One of the things that he always stressed a lot was the unity of all of physics. So we often think of ourselves as theoretical physicists, but he always emphasized that I had to understand the theoretical aspects and the experimental aspects in order to be a good physicist. And that's one of the lessons that I keep with me all the time. I'm also very amazed with the width of his knowledge. I remember there were times when he explained concepts of particle physics to me using analogies from chemistry even. And we've had discussions on all types of topics. He once tried to teach me rules of baseball, which never quite worked out. So overall, it has been wonderful working with you, and I hope to collaborate with you again in future. Thank you.
Thank you, Sushant. And I hope at least your time in Korea maybe made you appreciate baseball a little more.
Not really.
Yes, and yeah, I mean, actually here I should, since Sanjeev, I hope he's present, I should mention one small thing. The first piece of research that I did with Sushant and also a classmate of Sushant called Ravi Shankar Singh, who stayed as a project associate with me for a year. That work actually is an outgrowth of my reading Sanjeev's thesis as the thesis examiner. And some comment Sanjeev made or some study Sanjeev did as part of that beta beam study, that made me wonder about some other possibilities. And I mentioned that to Sushant and Ravi Shankar Singh, and they worked on it. And in fact, it was they who produced the solution. And our work was further taken further by Srubhavati and Amol as by magic baseline.
In fact, Uma, if I can make a comment here, that when our paper was accepted in PRL, the referee wrote to us that we must refer to your paper in the abstract itself. So we put your paper reference in the abstract, and usually we never put the paper in the reference in the abstract, but the referee told us to put your paper reference in the abstract.
And I want to say something since Sushant mentioned that, about the baseball. So Professor Umar Shankar, not only about baseball, probably he has knowledge about almost everything under the earth. I remember he gave me a 1 hour lecture on why Hunchback of Notre Dame is not a very good book. And I was reading Hunchback of Notre Dame in my office, and he saw that I was reading it, and he gave me a lecture that why it is not a good book. And after that, I never dared to read that book again. So I never took up Hunchback of Notre Dame again after that.
He is typically called among his friends as moving encyclopedia.
Yeah, he is like that, and he tried to make me understand the difference between rugby and American football once. Which, okay, I also did not understand the difference that much. But in South Africa, it helped a lot because in South Africa they play rugby, and there are few Americans who like American football, and when they say that rugby is like American football, I make them understand no, it's not the same actually. There may be some difference.
I have to apologize that I have another online meeting in the afternoon, so I will not be there for this meeting.
Okay, yeah. Thank you for joining us and actually organizing this session, and for the talk that you have given, summarizing the work very nicely, both the work you have done in IIT Bombay as well as the work you have done in PRL.
Yeah, so by this we conclude the morning session, and the next session will start at 3 o'clock. So I request all of you to rejoin us at 3 o'clock.
Yeah, wish we had lunch together, real lunch. Hope we will have some
and
time soon.
actually, I mean, congratulations in organizing the session.
Yeah, it's
managed very well. We are only some half an
in
hour.
night time.
Yeah, we have sort of run over only half an hour.
So we gave that buffer of half an hour, both in the morning and evening, so that we don't need to really pressurize everybody
एक्चुअली सर ने बोला था कि ऊपर 340 के पहले शायद अवेलेबल नहीं हुई और शायद तो उन्होंने बोला था कि उसको क्लियर करेंगे ठीक है उसको हम ठीक है काम कर सकते हैं पर्सन स्टार्ट होगा तो 5 पूरे में 10 मिनट में शायद पिछले बस धीरे धीरे होने और फिर सुबह को उसको थोड़ा हो जाएगा उसके मैं एक चीज पूछना कि सुबह को मैसेज कर दूंगा कि कंटिन्यू कर लो ठीक है ना आप मुझको मेरे टॉक के 10 बाद ना मुझे मैसेज कर देना प्लीज नॉट अवेलेबल तो मैं सुबह को जिस समय स्टार्ट होगा मैं इस समय तो फिर आई जाएगी 340 वाला है तो बात करें तो आपका हो गया अच्छा 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 हाँ हाँ अच्छा कब कौन सा पेपर इस बार कितना पेपर है अच्छा मैंने देखा नहीं अच्छा 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 ओके और कैसे हो किसी के साथ इन्वेस्टमेंट इसमें क्वेश्चन अच्छा नहीं नहीं क्वेश्चन 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 अच्छा अच्छा शायद सबका हो रहा है शायद जो कंफर्म है उसका हो हाँ अच्छा ठीक है मैं ऐसा अच्छा ठीक है स्टार्ट हो गया डिटेल में बात
Hi, Ashutosh.
Hi, sir.
Good job.
Thank you.
Doing well.
Now you're going to talk, right, Ashutosh?
Huh?
Yes,
Now you.
let's talk.
Yeah,
Who is coordinating? Who is sort of
Ritanjali is there or no?
Yeah, Ritanjali is there. So I will start this session, and then I will be there. I will be moderating, and Ritanjali is also there.
No, you're giving your talk, so we
Well,
thought somebody
conflict
else.
of interest, Ashutosh. You cannot be coordinating.
Okay.
You cannot stop. Then who will stop you?
So Ritanjali will handle it for some time.
Okay.
Yes.
And then
Yes.
interaction session you can take over.
Yes. Yes.
Okay. Yes. Yes, ma'am. I can.
Yeah, let Ritanjali share this session.
So good, Urjit. You actually pulled out a lot of pictures.
Yeah, I managed to put together the big points, high points of our.
Yeah, you should have also said about that Shobna Narsimhan. I thought
A lot of things were there to tell, and a lot of other pictures could have been pulled out. But actually, this anyway. Let's not start this right now. Yeah.
Yeah.
No, because I'm stuck at home. I couldn't go to office and all that. I couldn't get some of the pictures and.
Sure.
By the way, Uma, Rama, I started the live stream. Yeah.
Okay, sorry.
Yeah.
Oh, I see. Sorry.
No worries.
You can trim this part. Okay.
So there are only 13 participants now. So Do you
Sir
think
is
we
there?
should stop?
Because see, the interaction session today will be longer. So maybe we should, if Sir is there, then maybe we can start. Because anyway, see, neutrino people, because neutrino is light, so you have to have large number of people. Now physics is heavy, so few people can manage.
Yeah, but Kajuri is come.
I'm just waiting. Yeah, just
okay. The screen is on.
Screen is on. Once they are there, you can start actually.
Yeah.
Amol should also be coming.
I think Amol, he has some, I think tutorial today in TFR. There is some program going on, Vigyan Vidushi. So he said that he will be coming around 3:30.
Okay. So your talk is first and then what we have?
Suman will.
Okay.
And after Suman, we have Supra, but I think maybe he is aware, na, Ritanjali?
Actually, he did not pick my phone, but I have seen him here. So, Suprabh, are you available?
Hi, yes. I just, yeah.
Okay, yeah. Then I
Can
should
you
speak fast.
properly?
So, Suprabh is third, then Amol sir, and then the interaction session.
Yeah. So this interaction, this only like the way in which we decided, or some other participant will also be coming?
Jai More you have included, no?
Yes, her name is there.
Jai was logged in the morning.
Yeah. She said she will be present. And Anuradha Mishra will also be there. Anyway, I think whatever list you have, if you have included these people, whatever order you want to follow, just follow that.
Yes.
Towards the end, maybe faculty, and I requested Shivkumar again to be present. If he comes, we can ask him to talk few minutes. They were all, I think, undergraduate classmates.
Oh, you informed Anjan also, that's nice.
Yeah. Kumar Rao is not able to come, no?
I saw him logged in morning.
Okay.
Yes, sir is here.
Okay.
Yeah. So, shall we plan to start?
Yeah. So we can all unmute and then you can, Ritanjali can moderate.
Yeah. Okay. Yeah, so I take this opportunity to say happy birthday to Umar sir, one of my and lot of people's favorites, sir, teacher, guide, supervisor and all. Let us start our next session, which is about B physics. I would like to request Professor Dr. Ashutosh Alok to start his talk. Yes.
Okay, yeah, thank you.
So just before you start, I want to mention that Kumar in the morning also said happy birthday from the YouTube to Umar, and also right now he messaged to us that I'm viewing on YouTube, not using Zoom.
Oh, okay. Good.
Okay. Fine. Okay, so can you see my slide on the full screen mode?
Yes.
Yeah.
Okay, yeah, thank you. Okay, so I will start this session by talking about this B to S L plus L minus decays. So this talk is not a very technical talk. So this is a talk where I will share the story of my first work with Umar Shankar. And the reason for doing this is the approach that we started in the context of B to S L plus L minus decays is something very popular nowadays. And anyone who is working in B physics, in particular, probing physics beyond a standard model, they are now this particular approach is very common. So I will try to share the story and try to share the whole situation which was there in 2005 when we started actually doing this work. So I will first start with giving a brief overview of the kind of work I did with Umar Shankar. So as of now, I have 17 papers with him, and which can broadly be divided into 4 different modules. So I have 6 papers in B2S mu plus mu minus sector and 4 papers. So B2S mu plus mu minus sector means that now people are talking about this RK star anomaly, and this B2C tau nu is where we talk about RD star anomaly. We also did a thorough analysis of few new physics models, the 3 papers related to that. And one module is completely different from flavor physics. It is a kind of interface between quantum information and particle physics. So some of the key concepts in quantum information, such as non-locality, entanglement, we have studied that in the context of particle physics. So this is a kind of a brief summary of my work with Umar Shankar. So before going to all the story mode, because this is something called B2S L plus L minus, the term I have used. So let me first explain what is this. So here B stands for bottom quark, and S stands for S quark and strange quark, and L stands for charged lepton. So it's basically B2S L plus L minus. So this particular decay mode, this is a flavor changing neutral current. This will not occur at the tree level in the standard model. So it will occur only at the loop level. So these are the typical diagram that we have in standard model for this particular decay mode. So from here, one can see that this is a suppressed mode. So it is like an optimal mode to look for physics beyond the standard mode. So now I'll start with the climax, not from the beginning. The climax is that now anyone working in B physics, any young student working in B physics is, this is a very hot topic, because there are, large number of measurements. Like this same quark level transition gives rise to various decay modes, such as B going to K mu plus mu minus, B going to K star mu plus mu minus, BS to 5 mu plus mu minus. And there are large number of measurements in this particular sector which do not agree with the predictions of the standard model. They are not statistically significant to claim a discovery of new physics, but still we can say that at least we started getting something, some kind of evidence of new physics. That is why for last 4 or 5 years, this has been a topic of great interest in B physics. But now I will go back in the beginning in 2004, where actually I started working in B physics. It was decided, and it was during the web which was organized in IIT Mumbai, and that was a very good experience for me. And that time there was this working group, and I asked sir that which working group I should go, because initially I started working in neutrinos. And then he said, it's a good question, you should go in B physics group. So stall started in January 2004. And so what was the situation at that time? So in flavor physics, the standard model was the big boss. Like there was, barring few measurements in B physics, almost everything was consistent with the standard model. And people were mainly doing calculations like improving the precision in the standard model. And so that was the, the kind of environment we were in 2004 as far as B physics is concerned. So we started the revolt, that is to look for new physics. And the mode that we selected was BS2 mu plus mu minus. This is one of the decay mode which is induced by the quark level transition B2S mu plus mu minus. And what was our motivation? The first thing, as you might have seen in the previous the standard model diagram, it occurs at the loop level. So this is highly suppressed, the entire B2S mu plus mu minus. You have additional advantage for BS2 mu plus mu minus because of the helicity suppression. So typically the branching ratio that you will get in B2S mu plus mu minus sector is of the order of 10 to the power minus 6 or minus 7. But in the standard model, the branching ratio of BS2 mu plus mu minus is 10 to the power minus 9. So it is small and further suppressed as compared to other decay mode. And it is not that small that it cannot be absorbed at all. Right, it's not like mu going to E gamma, with standard model branching ratio is like of the order of 10 to the power minus 40 that you can't observe, you can't go up to that level. So, and from the theoretical point of view, the hadronic uncertainties, they are under control, because there is the main source of that is the decay constant that can be determined fairly accurately. So at that time, it was considered to be one of the cleanest rare B meson decays. And obviously it is highly suppressed. So it will be sensitive to new physics. So this diagram is in the present context where people are talking about the leptoquark and Z prime. That time people were mainly talking about the extended Higgs sector, like we're talking about models like supersymmetry 2 Higgs doublet model. So all these things motivated us to, in B2S mu plus mu minus sector, we concentrated on BS2 mu plus mu minus as our first work. Now, the approach that we used, now I will come to the approach, that the approach that we used was a model independent approach. So that time, this approach in the context of BS2 mu plus mu minus was not very famous. People were basically working out things in specific new physics models. So just to give you what is the meaning of all this kind of approach? Suppose we go to a restaurant and want to have a breakfast, and we say, okay, I want to have uttapam. So uttapam can be considered as a simplified model, and the raw ingredient from which I can make all this is something which is the model independent approach. But when you say uttapam, you have in mind that you will get something additional like chutney and sambar and all these things. And that explicitly you don't say. That is your actual breakfast. So the model independent approach is something which gives you the raw ingredients from where you can do your cooking. And the Z prime and leptoquark that we are talking nowadays, they are the simplified models. But the UV complete model, the real model, will have some additional stuff. So this approach, in short, it serves as a guideline for constructing models. So our selling point at that time was that, fine, if assume that there is new physics in BS2 mu plus mu minus, is it possible for us to uniquely identify the Lorentz structure of new physics? This is what our basic idea was. And in 2005, the upper bound on the branching ratio of BS2 mu plus mu minus was 10 to the power minus 5. We started with that upper bound. So basically, people were mainly using this to put constraints on the various parameter space, in particular in supersymmetric models. So our approach was different. Our approach was that we will work in a model independent way and try to figure out, is it a way out so that I can say that this is the Lorentz structure of new physics, just like the things were done for the case of beta decay. So what we did is that we considered all possible new physics that can contribute to BS2 mu plus mu minus, vector, axial vector, scalar, pseudo scalar, tensors, and then we obtained the branching ratio of BS2 mu plus mu minus. And what was important that enabled us to uniquely identify the Lorentz structure, at that time the LHCb sensitivity for the branching ratio of BS2 mu plus mu minus was 10 to the power minus 8. So, which was an order of magnitude above the standard model prediction. Like Roger Forty was giving a talk in the web, and actually that triggered us to look for this particular decay mode. So it means that if you observe this particular decay mode is observed at LHCb, then there has to be new physics. Now the point is it a way I can uniquely identify this? So using whatever measurements were available at that time, we obtained constraints on the new physics coupling, and we found that if there has to be an order of magnitude enhancement in the branching ratio of BS2 mu plus mu minus, it can only be due to scalar pseudo-scalar interaction. So the observation of this decay mode at the LHCb will not only confirm the presence of new physics, but will also confirm the type of new physics. Now, this work got published in Physics Letter B, and the comment that we got from the referee was that, okay, yeah, we know that, yeah, scalar, pseudo-scalar are important, but this kind of a statement is something which I like and which is very important, that a clear-cut distinction that you guys have done is really nice, and it will have some impact. This is what the referee said, and it was accepted without any revision. So I would like to share one incident after this. So once we put this paper on archive, then I was also nervous because that was my first paper. Usually you say people will come and that, okay, I have done this work before, and sir was also a little bit nervous. Then let's see what kind of response we will get. So the next day I received 3 or 4 emails, and these were from big shots in the people, and most of these emails were not for citations, but they appreciated our work. I don't remember other name, but one name was Paul Langecker, and I forwarded all this email to sir. And for those of you who don't know, Paul Langecker is the supervisor of Umar Shankar. So he came to my office and he was happy and also excited. And he said that nice to see his email after a long time. But I'm a little bit unhappy that he wrote to you, not to me. So that was the funny incident I remember for this work. And the story continues that we extended this approach to BS to mu plus mu minus gamma. So this work I did during my PhD, and most likely by the end of this year, LSCB is going to provide some strong bound on this particular decay mode. After completing my PhD, I went to TFR, and there I worked mainly with Amol. And there, like Sir Amol and myself, we extended this approach to B2K mu plus mu minus. And there also we got a clear-cut result that the forward-backward asymmetry of muons in B2K mu plus mu minus is very small in the standard model. So we found that in order to observe this, it has to be of the level of 3 to 4% in the experiment, and that is possible only if you have tensor operators. So if today this is the forward-backward asymmetry in B2K mu plus mu minus, we measure it up to a level of 3 to 4%, it has to be due to tensor operators. So after, and we did some other works also, basically is a kind of interface between BS2 mu plus mu minus and B2K mu plus mu minus, and it's all during TFR following the same approach. And by that time, this approach started attracting people in the community. Like you could see that more works along this direction started to emerge in our field, and especially in BTS mu plus mu minus. In 2010, during my second postdoc at University of Montreal, Amol and other collaborators, we wrote a paper where we extended the whole idea that we developed during my PhD to be to K star mu plus mu minus. Umar Shankar was part of this project initially, but later on he opted out. So we found that if in future, if you find any large deviation in B2K K star mu plus mu minus, then the only new physics that can provide such a large enhancement, the new physics has to be in the form of vector axial vector operators. In 2013, the LHCb reported the first anomalous measurement, and in this particular decay mode. And after that, several groups across the globe, they jumped into doing a model independent analysis, global fit, and they found that there are a large number of solutions, and 3 to 4 solutions, which can explain all these measurements. And it turned out that all these solutions were in the form of vector axial vector operators, confirming our results. So the approach that we advertised in the context of B2S mu plus mu minus in 2005 is now something which is very common. You can't avoid this if you are working in semi-leptonic B decays. But the time when we started was not very popular, and I feel, and sir had this intuition, first of all, for this particular decay mode, because sometimes my friends in working in B physics, most of them, they were working on B2K pi and others, non-leptonic decay modes. They used to ask that why because you try to work something else. Why you work only in B2S mu plus mu minus. But we had this kind of intuition that if there is some new physics at the level of, say, if you want to see that at the level of B quarks, then because of the fact that you have like leptons here, this is a more cleaner process, and that is the reason why we never stopped working on this. And lastly, it paid off, and today we feel very happy that we were like one of the groups in the community who started this kind of work. So, and after very recently, last 3 to 4 years, we extended this whole analysis in another sector, that is B2C tau nu, where also we have some anomalous measurements. So for that, Suman will talk in detail about those work. Thank you, sir, for everything. So additional non-physics thing, I will talk in the interaction session.
Yeah, thank you, Astosh. Yes, that was in some sense, we took a chance. And as you correctly said, it was Roger Forty's talk, which sort of made us think along these lines. And we took you can say, a somewhat non-fashionable topic 15, 16 years ago, but yes, we managed to do something exciting about it. Yeah, thank you.
Thank you, sir.
Thank you, Asutosh ji. The presentation actually said you are the student of Umar, sir. I can understand he must have taught you how to make everyone excited about your work. So this reflected that. Thank you. The second talk in this session, in the afternoon session, is by Suman. So if Suman, you can share the slides.
Yeah. Yeah. Hello. Yeah. Can you hear me? Hello.
Yes. Yes. If we can see you also.
No, actually, the thing is that the bandwidth is very low here, and I can't do video, and I'm running out of my mobile data, so I
Okay.
don't
Okay.
know whether I could do a video call or not. So
Fine. You can switch off your video.
yeah, but
Okay
yeah,
then.
okay.
Yeah. But share the screen. Yeah.
Yeah, of course.
Okay.
1 minute, just. Yeah. Okay. Yeah. Okay. So can you see the slides?
We are
Hello?
seeing the folder.
The folders, not the slides.
Oh, okay.
You have to open it. You have to open the file.
1 minute, just. Yeah.
Yes. It's some.
Okay. So can you see the screen?
Yeah. By any chance, if you can make it a slideshow or something.
Yeah. Now it is okay.
Okay,
can we
you
see
proceed.
you? Can we see you briefly, and then you can switch off your video?
Yeah. Okay. 1 minute. Yeah.
So I think you have to cross these two side things, slides and properties. There are small cross coming there.
Yeah. Yeah. So now you can see this full screen.
Yes.
Yes.
Very good.
Okay. Yeah. So thank you, and it's my pleasure to discuss about our works with Sir at this meeting, which is dedicated to Sir's birthday. So I met him during my MSc first year. That was in 2013 July, and I remember he took electronics course, and then I joined for my MSc project, and after that I continued my PhD from 2015. And it's my great opportunity to discuss the work which I have done in last 4 or 5 years with him. So all these works are related to this B2C tau new transitions, and so these are the 4 publications that we have done together. And but somehow these all these publications are related to each other, and all these publications are actually based on these RD star measurements. So we all know that we have the complete picture of the standard model today. So the particle spectrum of the standard model is shown in the left figure. So we have 3 generations of fermions, and then of course 4 types of gauge bosons which are responsible for the 3 fundamental forces, and the finally discovered Higgs boson, which was discovered in 2012. And the right figure actually depicts the allowed interaction between the standard model particles. From the standard model, we know that all these interactions are actually gauge interactions, and these gauge interactions are actually flavor independent. That means the identical for 3 generations of quark flavors. So this is the idea of lepton flavor universality. Now let's move to the decay mode for B meson. So these 2 interesting observables, RD and RD star. So these are the flavor ratios. So RD is defined as the ratio of branching fraction of B to D tau nu to the branching fraction of B to D L nu, where L can be electron or muon. And the RD star is defined in the similar fashion as RD, but here instead of a D, we have a D star in the final state. And these decays are mediated by this charged current transition B to C L nu. And this quark level transition is mediated by this in the standard model it occurs in the free level, and it is mediated by the W boson. So what is the global picture of these anomalies? So there is a series of measurement of these RD and RD star. So first, this was measured by Babar at 2012, and then these ratios are measured by Bell and LHCb. And recently in 2019, Bell has reported new measurement on these ratios. So the new measurement in the figure that has been shown by this green ellipse, and which is very close to the standard model. The standard model is identified with that cross sign, but the global average of the current measurements stands here. I mean, the red ellipse is the global measurement current. So the standard model prediction is around 3 sigma away from the current global averages. But so what we can learn from these measurements? So we can learn that the lepton flavor universality is violated here between the tau and the lighter leptons. So what do anomalies tell us? So the anomalies tell us that the RD star, for this RD star, indicate that the mechanism of this B to C tau nu process is not identical to that of B to C electron or muon channel. So these anomalies could be a hint of some kind of new physics, but this new physics could be either in the muon or electron channel or in the tau channel. But then we show explicitly in this paper that then the possibility of new physics in electron or muon channel is highly disfavored by the other measurements in this sector. So let's assume that there is a possibility of new physics in B to C tau nu transition. So apart from this RD star, there is another ratio which is measured by LHCb, that is the RJEP psi. But the mesonic transition is different here. The mesonic transition is from BC to ZEP psi, and the measurement is statistically, I mean, the statistical error in the measurement is quite large, but the measurement is 1.7 sigma higher than the SM prediction. And apart from these 3 flavor ratios, we have 2 measurement in the angular observable of B to D tau nu. One is tau polarization, which is measured by Bell in 2016, and it is also the statistical uncertainty is quite high, but it is consistent with the SM prediction. And apart from that, very recently in 2019, Bell collaboration has reported their first measurement on longitudinal polarization fraction of D star meson. So the definition for for the definition of this quantity is defined here, and the measured value is 1.6 sigma higher than the SM prediction. So what we have done, we have tried to explain these measurements using an effective field theory approach, and we set our new physics scale at 1 TeV and define the effective Hamiltonian. So the effective Hamiltonian contains 2 parts. So one is the standard model, which is represented by this OVL operator, which is the standard structure V minus A times V minus A. And the second part is the new physics contribution. So where Ci is the Wilson coefficients and Oi are the new physics operator. So there could be three ways to connect these four fermions. So I have brought three figures for the four fermion interactions. So these three figures actually can give rise three different sets of new physics operators. So first one is OI. So these operators are actually standard and quite widely used in literature. And these types of operator can give rise to models like W prime or charged Higgs. And the second two types of operators, Y prime and Y double prime, can give rise to models like leptoquark. And I have written down the all possible, so these three sets of operators here, where you can see, so I'm not going into any details, but I want to talk that the last two sets, the primed and double primed operators, actually can be written in terms of the first set of operators using Fiers identity. Now what I have done, what we have done, now we take all the data in this sector and define our chi-square as a function of these new physics Wilson coefficients. And we take these five measurements in our fit. And we also include the correlations between these observables from the theory and experiments. And we minimize this chi-square in three different ways. So we perform three different fits, one operator at a time, two similar operator at a time, and two dissimilar operator at a time. And in addition, there is a strong constraint from purely leptonic decay of BC meson. Especially this decay is quite sensitive to the pseudoscalar new physics. And the standard model prediction for this branching fraction is 2%. And particularly lab data imposes an upper bound on this branching fraction, which is 10%. So we consider this constraint to calculate our new physics Wilson coefficients. So how do we select our solutions? So we choose those in new physics Wilson coefficients as the best fit values, which falls in chi-square minimum less than equals to 5, and keep only those new physics solutions which predicts this branching fraction less than 10% and discard all others. So these are the two tables. So the solutions allowed before this new Bell measurement and after the Bell measurements. So before Bell measurements, there are four new physics solutions. You can see from the left table. So there are three single operator solutions and one double operator solution. Now, the present allowed solution, there is only one operator solution and three double operator solutions. So by comparing these two tables, we notice that the tensor solution, the second solution from the left table, the second solution and the third solutions are actually ruled out. And the fourth solution has become the OVL solution because of the smaller CVR value. So what happened? I mean, what are the impact of these new measurements? So in earlier in 2016, actually we identified that this tensor solution is very sensitive to the longitudinal polarization fraction of D star meson. So from the plot, you can see this quantity actually predicts very different for the tensor solution from the other solutions and the SM. So for the tensor solution, this quantity predicts 0.14, whereas the other solutions and the SM, this FLD star predicts 0.46. So the data, which is very nearly to the standard model, now ruled out this the possibility of this operator as a solution at the level of 5 sigma. And the OSL double prime solution is ruled out because of the reduction in the discrepancy. And the only allowed one operator solution is the OVL solution. You can see the CVL1, and the value is now reduced by 1/3. So previously it was 1.15, and now it has become 0.10. Now, after identifying the solutions, the question is how to distinguish these 4 solutions. So one method is to calculate, to analyze the angular observables which are not yet measured. So we consider 3 angular observables: the tau polarization fraction in B2D tau nu, the forward backward asymmetry in B2D tau nu, and the forward backward asymmetry in B2D star tau nu, and another observable which is the branching fraction of BC2 tau nu. And we calculate their average values for those 4 solutions, and try to distinguish those 4 different solutions. Now from the table we see that the p tau d, the first and the third observable, p tau d and AFB d star, have very poor discriminating capability. So we talk only about this forward backward asymmetry in B to D and the branching fraction of BC2 tau nu. So here I list the predictions for these 2 observable for the 4 new physics solutions. So in left I have plot this AFBD as a function of Q square, and in the table you can see the average values. So for the 4th solution, the AFBD is actually quite different. Even it is there is a sign flip. From the figure, it is also evident that the average value for this quantity is negative for the 4th solution. So establishing this quantity to be negative will distinguish the 4th solution from the other 3. Whereas to distinguish the first 3 solutions, we have to rely on the branching fraction of BC2 tau nu. And if you look at that square, I mean, if you look at that rectangle, I have boxed 3 values for the 3 different new physics solutions for branching fraction of BC2 tau nu. One is 2.5, the second one is 0.8, and the third one is 4. So one can distinguish these 3 solutions using this branching fraction if it is measured with a precision of 1%. Yeah, so let's come to the summary. So the discrepancies in RD star has been reduced from 4 to 3 sigma now, and the measured value of this FLD star actually strongly discriminates against the tensor new physics solutions, and this is now ruled out at the level of 5 sigma. And the present data in this sector in B2C tau nu actually implies that there are 4 new physics solutions with different Lorentz structure, and that can be distinguished using two observables in this sector. One is the forward backward asymmetry in B2D tau nu, and the second one is the branching ratio of BC2 tau nu. But to measure these quantities, we have to, the reconstruction of this tau lepton is necessary. But it is quite difficult because of the missing energy, because we have neutrinos in the final state. But the LHCb upgrade 2 has a plan to do this. So this is the end of my talk, and thank you, sir, and wish you a very happy birthday. And I wish you a very healthy and productive years ahead.
Yeah. Thank you, Suman. And it's been a pleasure working with you. And I'm also very happy that we picked up on this problem at the correct time, and we were able to make a good contribution to it. The photo on the left is from the time of Suman's PhD.
Defense. Yeah.
Professor Rukmini
And the second one is that convocation.
Yeah. This is the chairman of the session. He is from biology department.
Okay, thank you, Suman, for the nice talk. Is Amol sir present?
Yes,
yes, sir is. Yeah.
I thought Supra was talking, no? Huh?
Yeah. Oh, okay. Yes.
Supra is there still.
Yes. Actually, we are okay. Still, we have time. So the next talk in the afternoon session is by Supra. So Supra, if you can share your screen.
So can you see the slides?
Yes, I can see. We can see the slides.
Okay, so hello everyone, and hello sir. So
Yeah,
it's
hi, Prof. Yeah, good to see you.
yeah,
I hope you are doing well. You
yeah.
and
Yeah, it is. This is Asmita, ma'am. So I already feeling hot seeing all you guys wearing pullovers.
Oh, yeah. It's not that cold actually. So it's like something between 15 to 20 degrees here. I'm in
Nandini is also
Brazil,
wearing a thick
southern
sweater.
hemisphere. So yeah.
Okay,
So
sir.
wish you a very happy birthday, sir.
yeah, thank you.
And thanks to the organizers of this event, Ashutosh, Ramam ma'am, and Ritanjali for organizing this. So, so my interaction with Umar sir actually started during the MSc years, where he took the classical mechanics course and the quantum mechanics 2 course. And the classical mechanics course is probably one of my favorite courses ever. So that was, and then I did my master project with him, which was on matter effects. So matter effects in the neutron oscillation experiments, which essentially continued into the PhD project. So my PhD time in IIT Bombay was from 2009 until 2013. And yeah, so I'm going to talk about neutrino oscillation studies at the long baseline experiments. And so, sorry, is the slide changing?
Yes.
Okay, so my PhD thesis essentially consisted of these 4 papers. Which I wrote with Uma and Sushant and Sanjeev. And all these papers have done quite well, and today they have a good number of citations. So yeah, so I chose to talk about the very first paper. Actually, I believe Sushant and Sanjeev have in some way addressed the other papers. So I chose to talk about the very first paper. And actually, I'm not going to talk much in detail about it, but I just wanted to cover some physics points that we understood in that paper for the first time for ourselves. So yeah, so this was around 2011, and I think the first set of data from the T2K experiment had come, which were showing a hint for electron events coming from muon flavored neutrinos. So after that, we essentially started this work, and this was my first work. So yeah, so I'll essentially talk about how we try to understand the mass hierarchy and delta CP degeneracy. So I mean, this neutrino talk is quite late in the day, and there have been enough talk, so I think these slides are redundant now. But anyway, so our main focus will be on my main focus for this talk will be on understanding the mass hierarchy and delta CP degeneracy. And as most of you know, that the neutrino oscillations are sensitive to 6, in the standard situation, they are sensitive to 6 oscillation parameters, 3 of which are mixing angles, and there are 2 mass square differences, and there is a Dirac CP phase, which accounts for the difference between the behavior of neutrinos and antineutrinos. So
Yeah. Second session. It's going.
So before this, we had the results from the disappearance experiments, which essentially means that you have the neutrinos of a given flavor, and then in the detector, you try to see the same flavor and see whether there has been a depletion in the fluxes or not. So that's the disappearance measurement. And from that, we had the idea of what the delta m squared 2.1 is, what sine squared theta 1.2 is. And we also knew the
the absolute value of the mass square difference delta 3.1. But the next set of, and these were the experiments which are sort of easier to perform because they had very good statistics and you didn't need to go for very long baseline experiments. But then the next set of measurements, such as the hierarchy and the delta CP, could only be made through this measurement, which is by observing the events induced due to nu mu to nu e oscillation channel. So what it essentially means is that you have a source of neutrinos where nu mu's are being produced, and then they are made to travel. I mean, they just travel through a certain distance, and then in the detector you're trying to look if there are unexplained electron events or not. So this is the expression for the P nu E, and you can see that to the first order, it's so this is a perturbative expansion in the theta 1,3, which is one of the small parameters of the oscillations, and alpha, which is the ratio of where is alpha? So alpha is the ratio of the delta m squared 2.1 and delta m squared 3.1, and it's roughly equal to 1/30. So the P mu E oscillation probability can be expanded in this form, and you can see that. So this is in the presence of matter. So here A hat is the matter term, which is given by this expression, which is the Wolfenstein matter term divided by the delta m squared 3.1. And the matter term is actually dependent on the density of the Earth through which the neutrinos is passing and the energy of the neutrinos. So more energetic the neutrinos are, more the matter term would be. And the delta hat here is given by this term, which is delta 3.1 L over 4E. And in the long baseline experiments, L and E are chosen such that they give you an oscillation maxima. So this E here directly in some, so the E where the oscillation maxima is also decides what the optimal baseline should be. The dependence in delta CP comes in this term where you have this cosine of delta hat plus delta CP, and this is essentially an interference term, and the disappearance measurements do not have a delta CP dependence, at least not via the sign of delta CP. So for measuring delta CP, we certainly need to go to this appearance channel. Okay, so as I said, so P mu depends on theta 1,3 hierarchy and delta CP in addition to the other well-determined parameters. And so if one makes the measurement of P mu E, then there would be degenerate solutions because we do not know, at least at that time, we were not very sure of the theta 1,3 and we do not know hierarchy and delta CP. So then we cannot have a precise measurement of any one of the oscillation parameters. So in this work, we had set the value of theta 2,3 equal to 45 degree, but we had some understanding of the theta 1,3 mixing angle and that and that the Dirac experiment would be able to measure it very precisely. So we sort of shrunk the bigger degeneracy picture where you have a degeneracy between theta 1,3 hierarchy and delta CP to only hierarchy and delta CP. And this is something this is a physics point that we focused on in this experiment, in this paper. And next I'll just try to briefly cover up what our understanding of that was. So in this plot, we are showing you the neutrino and the antineutrino probabilities. So the neutrino probability is on the left and the antineutrino probabilities are on the right. And this is for a value of theta 1,3 such that sine square 2 theta 1,3 is 0.1 and the baseline is 800 kilometers roughly, which is the NOVA baseline. So here you can see that, so depending on whether the hierarchy is normal or inverted, you can have a separation in the probability bands. So this this band, this blue band or the red band here corresponds to a variation in the delta Cp, which is varied between minus 180 degrees to 180 degrees. So depending on, so if I go back to the probability expression, depending on what the sign of delta m square 31 is, you could have a different behavior, you could have a different value of this p mu e. Yeah, and the matter term A is also dependent on the whether it's neutrinos or antineutrinos, and if such happens that the interplay of these factors, the matter term and the delta m square, the value of delta m square 31, actually lead to a difference in the probabilities for the normal and the inverted orderings. So on the left side, you can see the neutrino case, and on the left right-hand side, you have the antineutrinos. In the case of neutrinos, the normal hierarchy is amplified and the inverted hierarchy is suppressed. And in the case of antineutrinos, the inverted hierarchy is amplified and the normal hierarchy is suppressed. What we observed was that there were certain combinations of the hierarchy and delta Cp which sort of lied at the peripheries of these bands. So here, for example, you have normal hierarchy and delta Cp of minus 90 degree, which is this dashed line, which is at the very top. So, for example, if this happened to be the true scenario where you have delta Cp of minus 90, then for an experiment such as NOVA, it would be very easy to tell this particular value apart from this whole red band, which is the opposite hierarchy. So this led us to a definition of the favorable and unfavorable values of hierarchy and delta Cp. And those were normal hierarchy and delta Cp of minus 90. So this was a favorable combination, and likewise inverted hierarchy and delta Cp of plus 90 would be a favorable combination because this is the probability which is farthest from the blue band. And it turns out that because of, it turns out that this is also the same favorable combination in antineutrinos as well. So neutrino and antineutrino data together could not resolve this degeneracy. This is something that I just said. And so this is a brief about what the values of the baselines are. So NOVA is an 810 kilometer baseline, T2K is a 295 kilometer baseline. The beam in NOVA peaks at 2 GeV, while the one in T2K peaks at 0.6 GeV. So this is a reason why the matter effects in the two experiments would be different, and which would actually, as we'll see, that this leads to the resolution, or this leads to a complementarity between the two experiments in determining the hierarchy, especially for the bad combinations of the hierarchy and delta Cp. So here we show the hierarchy exclusion principle, hierarchy exclusion ability of NOVA only for the NOVA experiment. And what we see that there is a half plane of delta Cp true in which the sensitivities are very good. And there's the other half plane in which the sensitivity is not good. Likewise, we see similar behavior for the inverted hierarchy case. So everything which is on the right hand side of these lines are something that you can, so for these values of delta Cp and theta 13, one could tell apart one hierarchy, the true hierarchy, from the other for NOVA. So at this point, we took a very broad range of this sine square to theta 13, but today we know that the value of theta 13 is actually somewhere around 0.08. So this x-axis after like these many years is essentially condensed into this one vertical line. So if one now adds the data from T2K, we see that for the values of delta Cp which were unfavorable, the values of the combination of delta Cp and hierarchy which were unfavorable, we have some increase in the sensitivity. And the reason for this thing was actually explained in this paper by Olga Mena and S. Park, which I briefly mentioned before, is that the degeneracy pattern actually is dependent on the value of the energy or the baseline. So the degenerate solutions for NOVA is different from the degenerate solutions for T2K, and hence when one combines the data from these two experiments, one is able to resolve this degeneracy better. So here, for example, in the left panel, you can see, so here we have the combined results from NOVA and T2K, and we took a theta 13 sine square 2 theta 13 value of 0.1 and delta CP value of 90 degree. And this is the same for both these plots on the left hand side and the right hand side. And the left hand side plot is only for NOVA and the right hand side is for T2K. So the blue line here corresponds to the case where the true hierarchy is normal, and then you're trying to fit it assuming that the test is also normal, and you get this blue line. And the red line corresponds to when the actual true hierarchy is normal and you're trying to fit it assuming the inverted case. And you can see that there is a clear degeneracy here where you get very small values of chi-squares. So then once you try to minimize over this x-axis, you essentially get a chi-square of 0. But when you add the T2K data, you see that T2K helps add these values of the delta, these unfavorable values of the delta CP, or the degenerate values of the delta CP, essentially because the pattern of degeneracy is different for T2K. So that was our main result in this paper, where we tried to show that how there is a complementarity between the two experiments, NOVA and T2K. And this was a really important work for me, because understanding this degeneracy thing was essentially in some ways the foundation of what the works that we later did. And this was also the time that I was trying to learn Globes, the software which I've used extensively. And then I mean, for that I thank Umar that we decided that we should try to understand that. And yeah, okay, so this slide I just wanted to show because now over the last several years we have the measurements from NOVA and T2K, and which they give us some hints about the hierarchy and delta CP. So while they both tell us that the hierarchy is probably normal, so there are good enough hints for that, they are not actually converging on the value of the CP phase. So NOVA, for example, is giving a CP conserving value, and T2K is giving a CP violating value. So I just thought that it's something worth thinking about, and maybe in the next week, Neutrino conference, probably we'll hear more about the results from these two experiments. So thank you, and yeah.
Yeah, thank you, Suprab. Yeah. And again, we started working on the problem at the right time, and it was, I mean, the discussions we have had, Sushant, you and I, and later, of course, Sanjeev also joined us in that work. And it sort of really helped in clarifying the picture for us, and we were able to convey that in our papers.
Yeah, thank you, Suprab. I hope you could join us further. I understand that this is an odd time for you, but there is an intersession.
Now it's fine. It's almost 7:30, I think. So it's okay.
Okay, nice.
Thank you.
Yeah. So with that, we are coming to the last talk in this section. Professor Amol Dige will talk now. Yes, sir. You can start sharing your screen. Suprab, you have to stop. Yeah.
Sorry, yeah. Did it stop?
Okay. Can everyone see the slide?
Yeah.
Okay. Yeah. Okay, so happy birthday to Umar Shankar, and my talk is going to be about 5 favorite flavors.
He's fond of ice creams.
One marketing friend once told me that you should first decide on the title and then give a talk. So I try to think of a good and interesting title first and then try to give the talk. So anyway, it is not very difficult to figure out what the 5 favorite flavors are, because they happen to be those flavors of the standard model which have common interest for both Umar, Shankar and I. Okay, so indeed the 5 flavors that you see here are the B quark, the S quark, and the 3 neutrinos. So both of us have worked on decays of B and K mesons, decays of B2S quark, and on 3 neutrino mixing. So that sort of makes it a common interest to us. Given that we have so many common interests, and given that we are almost next door neighbors and talk for many days, many times, when I yesterday tried to go and look at what papers we have in common, I was surprised to see that we basically have about, I think, 5 papers in common plus 5 proceedings. And then I was wondering, and then I realized that the discussions that I have had with Umar Shankar haven't been mainly for writing papers. They have been mainly for understanding physics topics and getting insights. So in that sense, I think it is having him around for discussions in physics has always been great over the last almost 20 years. My first paper happens to be with Umar Shankar, happens to be the one that Urjit showed today morning. This was the discussion on INO that happened in PEP in Chennai. And this was when I did not have a job yet in India, but I participated in. And in fact, we have discussed a lot along these topics over the last almost close to 2 decades. But the actual collaborator paper-wise that we had actually was when Ashutosh Alok, who had just finished his PhD with Umar Shankar, also joined as a postdoc in TIFR. So we focused on the problem of B to S mu decays, about which Ashutosh also talked quite a bit sometime earlier. So these decays are good probes for physics beyond a standard model. And the reason is because there are multiple channels from which you can get a lot of information about this particular quark level decay mode. So for example, you have BS2 mu plus mu minus, BS2 mu mu gamma, BD to XX inclusive mode, XS mu mu, BD to K mu mu, BD to K star mu mu. In all of this, there are various observables, decay rates, branching ratios, power backward asymmetries, CP Faraday asymmetries. These are what are called as longitudinal polarization fractions. Then this famous thing called P5 prime, one of the angular observables. Now, of course, all of this is quite a mess. So what you need is insights which are needed to connect the right kind of observables. So you cannot just have 36 observables and you try to make a fit. Physics-wise, it's important to understand what causes what. And I think that insight is what at least I got when I discussed this problem with Umar Shankar. Already we have talked about that these are the modes that currently also happen to be at the forefront. Even now, anomalies in P5 prime, RK, RK star are going strong, and some of the formalism time still continues being used. So what was the formalism? I think, although Ashutosh has mentioned it, I'll mention it very briefly. So we use the approach of effective field theory. So you write down effective operators without really caring about what is new physics at a high scale. So the standard model, for example, if you write down effective Hamiltonian, you get terms that have 6 operators of the standard kind. But in addition, you have the operator called Q7, which has coefficient C7, C9, and C10. Okay? So C9 and C10 are the operators that are combinations of vector and axial vector currents in the standard model. The question now is, when you have new physics that can affect this, it can come from literally anything. Therefore, the time is to look at everything that's possible and what is possible. Okay? What we look at are different Lorentz structures of new physics. So for example, you can have a scalar, pseudo-scalar Lorentz structure. And if you see here, that basically means that the coupling between B and A square has no vector here. This is just a scalar or pseudo-scalar. Then you can have vector or axial vector coupling, where now you can see here a gamma mu appears, which accounts for V or A coupling. The gamma phi, of course, is given by the PL or PR that is present. There could be tensor operators, and in that case, you get a sigma mu here, and these three can be the different classes of couplings that you would have. The insight that we got led us to a few results that can be stated only in single lines. So, for example, the state at that point was that Bs to mu nu just had upper limits on it. Okay? So it was some upper limits were put by experiments, but what that did is that actually put a lot of constraints on these new physics parameters that we have. What we did is we tried to use those constraints and predict what would be effect on observables in BD going to K mu mu, which has the same clock level process. So what we found is if new physics is scalar or pseudoscalar in nature, then the branching ratio of K mu mu cannot deviate much from the standard model. The forward-backward asymmetry A of B will also be restricted to be very small, of the order of 1% or less. But this observable called as lepton polarization asymmetry ALP could be large, unrestricted, almost up to 100%. We also found that if the new physics is only vector or accelerated in nature, then A of B cannot be enhanced. However, if it has tensor operators, then it can become 15, 20, 30%. These works were done around the time 2008 to 2010, all of them with Ashutosh and Umar. I must add that we went further than this and wrote two rather comprehensive papers which dealt with all these 5 decay modes and all these 5 observables. Although this thing was based on the papers that we wrote earlier, but at that point of time, Umar Shankar said that most of this work has been done by my student, which is Ashutosh Ano, and therefore I do not want to have my names on these comprehensive papers, although initial ideas came from me. I don't know if Ashutosh knows of this or not, but so these two papers later on got almost 100 citations or more each. Umar Shankar by himself had said that no, although initially I started, this work was done by my student, and therefore he should get all it. So that's one good quality of an advisor. Umar Shankar's repertoire, of course, is very broad, and I try to summarize that in the next 3 slides. In Koch level physics, he has built left-right symmetric models and looked at constraints from colliders. This was, I think, the work with Paul Langacker, supervisor. I must tell a story about Langacker at this point of time. He taught us during a TASI school. We were 50 of us, and we asked him about what will happen to us in future. And he said that if 5 of us go to become faculty members, he will feel that we have done a great job. So he was a bit straightforward and scary. I don't have much experience with him, but of course, now that I know he has given us a student like Umar Shankar, which is perhaps more than or equivalent to his great physics contributions. Later on, Umar Shankar also worked on the implications of BD-BD bar mixing to predict that the top quark really should exist and it should have certain mass. In later times, in the quark sector, he has worked on models with extra vector-like associated quarks, again with some of his students. He has worked on predictions for possible enhancement of BS2 mu nu. I think Ashutosh was a part of some of these papers. And I think with Suman, he has been working on resolving anomalies on RD and RD star using B2C tau nu. In neutrino phenomenology, which is something on which we heard many talks today, he has lots of contributions to matter effects in atmospheric experiments or long-distance neutrino experiments. He basically knows everything that is to know about experiments coming up and what their feasibility are. He has worked on getting mass models to explain non-zero theta-13 and delta Cp, on neutrino magnetic dipole moment, on the implication of data from LVL experiments and the study of their physics reach, on possible CPT violation, its origin, maybe at the Planck scale, and how it can be observed at a detector like INO, for example. He has worked on leptogenesis and neutrino mass models. I think Narendra was the one who was a collaborator in this. And of course, this story, which he recounted, I think, in the morning, about the 2540 kilometer baseline, which I think Sushant was one of the person. I forget if Suprab also was involved in this. So the idea came from these people about this 2540 kilometers baseline. By magic is just a name that we later came up with and found out something more interesting about it. But the original results were actually present in the papers that were written by Marshall. He has devoted himself a large part of his time in working with simulations of INO and ICANN. And some of the works that he has done there with his students involve the separation of electron neutrino events from nuclear current events in the detector by looking at the hits, searching for sterile neutrinos, exploiting muonless events for mass ordering, use of neural networks to enhance the physics potential of ICANN, then direction of neutrinos, how you can reconstruct that by using muonless events, looking at how you can estimate energies of hadrons, and how you can look at CPT evaluation. So what I have presented in last 3 slides is basically some glimpses of the kind of breadth of Umar Shankar's work. I don't claim that to be exhaustive, so you should excuse me if I have missed anything which is important. This happened to be our latest formal collaboration, which is the INO ICANN white paper that we have written some time back. However, we also have been partners in teaching at some places. So in the SARC school that happened at IIT Bombay, I think 2008, I think it was organized by Rama. We taught the course of flavor physics together. We also did the same thing when in the SARC school in Displani, Goa on flavor physics. And in the INO graduate training program, neutrino physics course is being taught sometimes by me and sometimes by him. I think he has done the job maybe more than twice as many times as I have done and has trained many generations of neutrino physicists people from INO. Before I end, some of the unique Umar things that I have noticed. He's very professional. We have many physics discussions, sometimes some small arguments, but he will always criticize the physics point and not criticize the person. Okay? That's something I am sure all of you would have realized. Second thing I always notice is his precision that he has in speaking and writing. And therefore, his sentences sometimes also happen to be long with the commas at right places, but they have the correct physics sentence. I see some students smiling at this. Third thing I admire is the time management. In the class that he's giving, in the first 1/3, you find maybe he's going too slow. He's just explaining things very slowly. Maybe what can he cover in one hour? But when that 1 hour gets over, you realize that the pace was such that everybody was able to follow what was happening. And in fact, at the end of the 1 year, the content that actually went through the students happens to be much more. That's something that I almost try to imitate. Even outside, I mean, something I admire is very often, I think after traveling to Powai and coming back in the evening in local trains, he would stop and he would go and do his swimming before coming back to Kiev. I don't know, I cannot even go to the seaside by deciding that I'll do that for 15 minutes every evening. But even after his travels, I think he always managed this with regularity. And last thing, which nobody will doubt about, is of course patience. He has immense patience with everybody he's discussing with. And he usually does not get perturbed. I happen to have a secret picture of him in which you will see a person very agitated talking, and you will notice that Umar Shankar is very calm, composed, and basically says, no, be calm. He's a very unperturbed person. So that's this. And that somehow, I think, to me encapsulates what the personality of Umar Shankar is. With that, I again wish him happy birthday and give him this bouquet of 5 minutes. Thank you.
Thank you, Amol. You actually forgot to complain that I sort of stole your postdocs during the period 2008-2010. you had two postdocs, Asutosh and Pomita, but it so happened that I probably they talked to me more during that time than to you.
But you don't realize how much transfer of knowledge took place between you and me through these postdocs during those times. So I have no complaint.
Yeah, thank you, Amol sir. Such a lovely talk, and I think brief and I think everything about Umar sir can be seen in your 13th slide. So yes, let us go to our next session, the interaction session. Now I hand over to Dr. Asutosh Alok to carry out the session. Thank you.
Yeah. So thanks, Ritanjali. So we now move on to the last session. So that is the interaction session. So here, like we will talk about, sir, whatever our experiences are. Most likely it's non-physics thing. I mean, for people who already gave a talk and for people who didn't get an opportunity to talk in the first two sessions, so they can talk whatever they want. So I would first start with the PhD student. So what we have done is that we will start with the first student of Sir Bipin, if he is available, and after that we will follow things in the alphabetical order. So is Bipin around? I don't think Bipin is here.
Bipin sent me a message saying that he probably has some trouble connecting.
Okay, okay.
So he may not be able to join.
Okay, fine.
He sent an email message this morning.
Okay, fine. So now we move on to the next person, that is Ashish. Is he around?
Can you hear me?
Yeah. You can switch on your video.
So I'm seeing you after 4 years.
Yeah.
Yes. Happy birthday! Happy 60th birthday!
Thank you.
Yeah, it's you know, I'm really glad to join in this celebration during these COVID times.
Yeah.
Yeah, it's actually 6 o'clock in the morning here in the US, and I'm in the middle of the whole TASI lectures these days. So I didn't get a chance to prepare a talk before. So I want to share some of my experience when we work together. So I actually know Professor Umar from my BTech project. It's initially from my 1 year long BTech project, and then doing a 1 year long research assistantship afterwards. And back then, the one thing that I remember is the patience that you had with me, explaining all the small details as a final year undergrad student. Back then, I didn't appreciate it that much. Now I realize that it's a very rare quality in academia, and yeah, so I just want to mention that. So once again, yeah, I wish you a happy birthday and, and a good health and prosperity and happiness. Thank you.
Thank you, Abhish. And I follow your work on the archive, and I'm glad to see that you are doing well.
Thank you.
And good luck with your research and with your future life in general.
Thank you.
Good to see Abhish. Have a good.
Hi, Professor Ramadi.
Can you see me? I don't know that I put in the video. Okay.
Yes, I can see you now. Yes.
All the best. We had a teamwork on A4 symmetry with Umar Shankar, which I'll never forget.
That's
and I still feel that he says delta CP still can be, closest to the experiments. You should still get on to it. Okay. See you. Bye. Bye.
Thank you. Bye.
Okay, thank you, Abhish. So now I request Akhil to talk something about sir. Akhil, are you there?
Hi.
Yeah.
Hello.
Yes, you are audible. Yeah, speak.
Okay, so uh, here my internet connection is poor, so I may not able to start my video.
Okay.
So voice message is fine.
Yeah.
Yeah, we can hear you.
Okay. Okay, sir. So good afternoon to all. Wishing you a very happy birthday, sir.
Yeah. Thank you.
Actually, I'm not here to say a few words about sir or experience because you people know him very well. Since I have joined to him in last session, July session, so I didn't have much time to know him personally. But whenever we had discussions about my project or anything related to physics, his explanations were like amazing. Like I mean, nothing could be better than that. The way he explained things, it actually forces me to think more about that topic or to imagine the physics behind it. So his explanations were a kind of motivation for me to move forward in that topic. So here I would like to thanks to all the organizers for this workshop, which actually helped me to know more about him. Also his all the collaborators and past students. So one thing I must say that I am very lucky to have him as my supervisor. So thank you, sir, for considering me as your student. Once again, happy birthday, sir.
Yeah. Thank you, Akhil. I hope you and your family are doing well.
Yeah, sir.
Okay.
All are fine. Okay, thank you, sir.
Yeah. So now it's my turn. And I think it's like 5 minutes to say something about sir. For me, it's like extremely difficult, and even if you give me a day, then also I will find it
There is an echo.
Ashutosh, you turn off your speakers.
Speaker.
You may have YouTube on in addition to this one.
No, just turn the volume button down. Everyone can hear you, but nobody.
YouTube is not on at my end. Okay.
Also, if somebody has their microphone on, it could
Yeah,
actually
I think
echo.
somebody else has their microphone on.
Yeah, please all mute your microphones.
Yeah. So I was saying that usually when we talk about our supervisor's contribution, it's mainly academic, but this is not this is not the situation with me. The other contributions of sir dominates over this academic thing, and I don't look at him as my supervisor, as my PhD supervisor, but he's like my family member. If I have to say in one word that if still today I'm doing physics and leading a normal life, it's all because of him. I had interest in physics from the beginning, but I wanted to do something else in my life. The reason why I came full time in physics is because of it was my father's wish. And but during the first year of my PhD, my father died, and so along with him, all my motivation for doing physics, in fact, everything in life went away because I was completely attached with him. So I thought of leaving IIT Mumbai, and I communicated this to sir. I was not sure what I will do in life, but still I was not feeling comfortable there. But then we had some discussion, and after that I changed my mind. I decided to continue with physics, but still it was a difficult time for me. But I got the mental support from him. He did n number of things for me. I can't list those things. If I can summarize his contribution by saying that I would have gone into mental depression at that time if he was not there. This was the extent he helped me along. It's more than 15 years now, and I don't remember any period of time when he was not in touch with me, not even for a month or two. It's like I feel blessed to have him as my mentor. He keeps track of everything. I mean, even now, like he remembers all my publication. It once happened. One of my paper was unpublished for more than a year. Even I forgot about that. So one day, when he was talking and he asked me about that work, that is there any some problem or not? So during my postdoc at TFR, I remember one incident when I got an opportunity to attend a workshop in CERN. Then he suggested me that, why don't you visit other places and try to advertise your work? He sat along with me, he prepared the entire list. And it so happened that in my 30-day visit, I visited more than 10 to 15 places, 10 to 15 institute. And it was really a thrilling experience for me. There is only one incident I remember when I thought कि आज सर को मेरे यहाँ पे नहीं होना चाहिए, and that was my job talk in TFR, like the postdoc talk in TFR. So I wanted to stay in Mumbai, and I wanted to do postdoc from TFR, so that was very important. So I was a bit nervous. I was more nervous because some of my friends had very nice stories about talk in TFR, so that made me more scared about that. But as soon as I reached TFR, the thought came in my mind, because when I went inside the room, I saw that the auditorium is completely filled. And I thought that that time the kind of work I was doing was not very popular. So why so many people are there? So then I realized that, okay, it's because of sir. That because he stays in TFR, so everyone would be excited to see what kind of student he has. So then I thought कि sir के सामने मेरी बेइज्जती होगी, ठीक नहीं लगेगा. And another thought came in my mind कि if I do not perform well, then it will be somehow the reputation of sir is on stake today. So then I just prayed to God that मेरा talk किसी तरह से अच्छा हो जाए, whether I get this job or not. I mean, that is not important for me. And luckily that talk went well. And I would just like to, conclude by saying that if, someone asks me that, can you tell the three most important people in your life? I will say first is my father, then my mother, then is sir, and then only even my brother or any other family member will find place only after that. And sir, I wish you all the best. And I hope you will continue working with me, and also madam also, that the kind of affection and care that both of you have given me and you will be giving me through my entire life. Thank you, sir, and thank you, madam, for everything.
Thank you.
Yeah, thank you, Asutosh. And also, I mean, you omitted to tell this, but I sort of made sure that your talk in TIFR would go well by having you making you give a practice talk the day before.
You don't disclose this.
And also invited a rather tough examiner who was visiting our department at that time to sort of put you through the ringer, so to speak. So in that sense, you were well prepared to give the talk.
Yeah. Thank you, sir. So
Thank
now I will ask.
Hey, Umar Shankar, who was this secret weapon of yours?
Anant from CTS was visiting the department. So, in fact, it was quite late. Around we had the presentation around 7 p.m.
Anyway, we are very lucky to have people like Ashutosh and all the students around.
Thank you, madam.
We are very lucky.
So,
who is the next one?
Dinesh. Dinesh, are you available?
Yeah.
Maybe you can switch on your video. Or...
Can you hear me?
Yeah.
Yeah, okay. So first I wish a very, very happy birthday to sir. So I feel very proud and very lucky that I got an opportunity to work with you. I'm extremely grateful that you guided me, continuously guided me, and your encouragement throughout my PhD and even till today. It was very pleasant and it was very great time for me discussing physics and learning physics from you. I always left your office with a glimpse of smile on my face, and full of energy after every meeting. Each and every meeting with you gave me a great satisfaction great confidence and encouragement. Sir, you always listened me very carefully and guided me in a perfect way. So that was the great thing for me. And I learned, after every meeting, I learned some alternative ways to do that things that we can do in much better way. You taught me that appropriate solution organize our research finding. Apart from this, I can say
Hello.
spend almost 20 as a regular. Hello,
Yeah.
can you hear?
Yeah.
Yeah. Actually, I spent almost 2.5 years in IITB as a regular student, but then after I joined this University of Rajasthan, so Jaipur. But and after joining this University of Rajasthan, it was a challenging time for me to complete my PhD. But the continuous support and guidance from sir, I was able to complete my PhD, and even after that, sir, by your motivation and by your continuous guidance, I'm quite lucky that I was able to complete 1 year postdoc from NCBJ Warsaw. So thank you very much, sir, for giving me such pleasant and giving me this type of guidance. Thank you, sir, and wish you a very, very happy birthday again, and wish you a healthy life.
Thank you, Dinesh. Yeah, it was very nice. And in fact, I was very happy to have you as a student, and we had some very good discussions. And here, actually, I must acknowledge that, in fact, by the time Dinesh joined me as a PhD student, Astosh has joined IIT Jodhpur, and in fact, Asutosh was in fact more of Dinesh's guide rather than I was, because uh, as far as the details of the calculation are concerned, it was Asutosh who guided Dinesh, and roughly once every week or 10 days we would take stock and see how to proceed further. But Asutosh's role in the guidance of Dinesh is irreplaceable. And in fact, I'm glad that I could persuade IIT Bombay to recognize Asutosh as a co-guide of Dinesh. Thank you, Dinesh.
Yeah, okay, Dinesh, thank you. So now I request Jay to say a few words about sir.
Hello, good afternoon, everyone. Can you hear me? Am I audible?
Yeah, a little bit louder.
Okay. First of all, I would like to thank Professor Ramadevi for inviting me to such a wonderful event. And I would also like to thank all the organizers for this wonderful event. When I came to know about this meeting, I was very excited. I was very happy because I thought that I was sharing same birth month with sir, but just before the lunch break, I came to know that it was not the original birthday. That sir's birthday is in October. But anyway, congratulations to him that he is still less than 60, and 4 more months he will have to turn to 60, and we will again celebrate hopefully. And actually, I have not been his official student yet. I mean, I was never his student as PhD or postdoc to say. But just after my PhD, once I approached him and I wanted to do postdoc in Mumbai itself. And I don't know whether he remember, but we had interaction, and then he very respectfully and politely declined, saying that because I was working in particle physics, I was working in light front QED, and his area of work was neutrino physics. So he said me that there is very less overlap and academic point of view, it may not benefit. But later, when I joined IIT as a postdoc with Professor Asmita Mukherjee, I spent 3 good years doing research with her, and I really enjoyed the kind of capacity of the faculty in IIT in high energy physics. And I would like to thank Journal Club, wherein actually we had some discussion, and like Professor Umar Shankar and Ushak was a student that time, and during the Journal Club discussion, Ushak gave a talk on his topic, and actually I got very much interested, and we started discussing about the topic. And nearly for 1 year, it was just a discussion, just learning and discussion about neutrino physics. And then I really didn't have much guts to approach him again and talk to him. But since as a just as a student, like Ushak was a student, and I was interested in working, we initiated a project. I mean, started working on it, and we are almost in the process of finishing that project. And my dream was to work with him, and I ended up writing a project wherein for the next 3 years he will be my mentor. And I'm feeling so happy that after listening to his PhD students and other students and collaborators, that I really, I don't know how to say that I've got an opportunity to work with him, and for the next 3 years I will gain a lot of experience, lot of knowledge in this work. So I'm really happy that I shifted a little bit gear. Though I'll be working in particle physics, I have a subtopic in my project wherein I will Professor Umar Shankar will be my mentor, and I'm really thankful this time that he like he agreed to be my mentor this time uh, without any loss. And since morning I'm listening to all kinds of adjectives about sir, which are definitely all really I have experienced, which I would like to repeat, and there's no harm in repeating them. I'm really fortunate to have a person who is very much compassionate. uh, uh, I have seen one thing, like when I approached for him for to be my mentor for women scientists, I saw the kind of trust he showed and the kind of respect, and he has been so patient. He is a storyteller. His simplicity, I admire his simplicity a lot. And finally, he has been also a counselor for me. At times, like I have heard from other students, and it's a reality that he is not only a person whom you discuss only physics. It's really good to talk to him on various other topics too, and he can be a real good counselor. And I will be very happy to have gather such wonderful experiences. Maybe in next few years I'll have those memories like the other students have. And finally, I would like to say a wonderful quote for him on his birthday is that having a teacher like him in a life is a confirmation that no matter how difficult life becomes, I will never be in darkness. Thank you, sir, for being a counselor, guide, uh, a real good mentor. And you will be in future. I'm looking forward to have more physics discussions with you, and wish you a very healthy, joyful birthday. Thank you, sir.
Yeah, thank you, Jai. Yeah, the collaboration we started, I'm afraid it is moving rather slowly, but
Yeah.
we will complete it probably, I hope, in a month's time or so. And I'm also looking forward to your joining our department as a, sorry, this is CSIR. You are supported by CSIR or
DST. DST.
DST?
DST.
As a DST.
Scientist.
I believe it's a women science program, no, Zai?
Yeah.
Yes, ma'am. Yes.
Yeah.
So how are you doing otherwise, Zai? You and your family are well?
Yes, ma'am. Yes, we are well.
Okay, good to know.
Thank you.
Yeah.
How
So
are you?
I look forward then.
Yeah, we are here also
working.
well. Yeah.
And yeah, let us hope that you will be able to join the department very soon, and we can resume our discussions.
Sure, sure. Yeah, looking forward to it. One more thing, just last thing. Ushak this morning said that we don't have any photograph with sir, and I was wondering why we are not having. But then I went to web page of physics department and I found a photo wherein we like students and you. I can just share a screen and show you that this is the only photograph in which you will find Ushak, me, you, and other faculty members, few of them, in theoretical high energy physics web page, and this has remained for long. So I just want to say, Ushak, that yeah, you have a photo with sir. It's a long fact. Yeah.
Okay, thank you, Zai. So now I request Ritanjali to say something about sir.
Yeah.
Okay.
Nice. Thank you, Jai.
Yeah. I don't know what to say because the fact that I have never worked with Sir, but yeah, officially I am his student. I joined IIT Bombay in 2008, and in 2009 we went to SERC school in IIT Madras, where Sir was taking particle physics course. And since his first class, all the participants from all the institutes praised Sir so much. They have been telling me that you people are so lucky to have him as your teacher in IIT Bombay. And whatever subject he will teach, definitely people will understand. And starting from the scratch. So I know he's one of the best teacher in that regard. The BTech students in our department, the engineering physics students, starting from Tejal, I have interactions with Tejal and I come to forget the names, but they also said that you are one of the favorite teachers to them. And I'm glad that whatever period that I spent in IIT Bombay, you were there to, I don't know how to back me up. Like all the conference, see, there are, as Asutosh ji said, there is a supervisor who teaches you how to work, and there is a supervisor who teaches you how to learn and act to the obstacles or to the hindrances you find in your life. And I would say the second part I learned it from Umar sir. I used to, because my supervisor was not there in IIT Bombay, so wherever I was supposed to go for conference or to interact with other colleagues or collaborators, I had to I had to go through so many paperwork. And whenever I went to sir to have a sign, he never asked me a question, why you want to go there, or why you are going to conferences, or why you are asking DST money, CSR money. So that is the experience I have. Saying this, I also want to thank everyone, Asmita, Rama Devi, Urjit, Raghav sir is not here. All of you, thank you so much for making my life in IIT Bombay so smooth, even though it was really a big mountain. And I hope we will have some physics interactions in the future. And I really wish you a very happy, you and your family a very healthy time ahead. And I hope you will enjoy your October birthday with all your colleagues and the department. And that would be big celebrations. So yeah, thank you so much, sir. Thank you for everything.
Yeah, thank you, Ritanjali. In fact, I'm glad you mentioned that SCRC school in IIT Madras, because one of the things I noticed there is the way you interacted with all the other students, and in fact, you made how the tutorial sessions more lively. And in fact, I always tell students that, I mean, you should actually be like her, that you should go interact and ask questions. And regarding going to workshops, etc., and I mean, in the academics, that is part of life. So I mean, if you start questioning why people should go to workshops, I mean, might as well give up doing academics. And one small thing I want to mention to the other people gathered here, during her final year, Ritanjali was the TA for the course Professor D. Narasimha of TIFR taught in IIT Bombay, a course on astrophysics. And because he found it difficult to commute, he made it a condition that he will come only on Saturday and take one lecture before lunch and one lecture after lunch. And Ritanjali, as the TA for the course, actually became almost a sort of a second teacher of that course. And the students who did that course, they were very highly appreciative of the efforts she put in. And Professor Narasimha also was very happy. He felt that the course was a success mostly due to the efforts put in by Ritanjali. So we did whatever we could in the department, but Ritanjali sort of learnt all the right lessons, and she has now become a good researcher. Thank you.
Thank you so much, sir.
Yeah, so thanks, Ritanjali. So now I think the last one in the list is Supra, because others are not available. So Supra, are you there?
Yeah.
Yeah. So
okay. So yes, sir. Hello, sir, again. And yeah, so I mean, if when I look back, I just feel that the time that I spent at IIT Bombay, especially the PhD time, it has just been a lot. Like working there has been a lot of fun for me. I felt very free while working, and I felt like I was on a creative high in my own little way. And to be honest, like I was struggling during my MSc with too much. I felt that the load of courses was too much. But then I think I feel that the PhD part was, I somehow find it very easy. Like I think it was easy because Umar sir made it very enjoyable and easy. And I remember that we would have so in the beginning we would have discussions with Sushant, and then later with Sanjeev on Skype, and it would be like 3+ hours, and I don't know. I mean, I didn't realize how time would just pass by. And I remember that there was, I think there was one year when Umar sir was in sabbatical on sabbatical in TIFR. And then that year, Sushant and I used to travel from Powai to TIFR. Like, and this was like in the direction of the rush. So yeah. So, but even like but even then, like we really enjoyed. I look back at it and I really enjoyed that time. And as Ritanji mentioned, like Umar Shankar sir has been very supportive. I think in terms of even attending the conferences, you sort of influenced us to go to conferences. Even I think even in my first year, I attended the schools and everything. And one of my biggest gains that I think is like when you would sit with us, and so when we would be writing a paper, you would actually sit with us, and then it was a very interactive process. And I think in terms of actually writing an article, I owe a lot to you. And I could, at that time, I could see how you think, how you process. Like, once you told me that you should write something, assuming that a first year PhD student should be able to understand it. And I think that was a very important thing that you told me. And yeah, so yeah, I feel very happy. I mean, even now when I receive an email from you, I just feel happy about it. Like, so, and if you allow me, I would like to share some of your funny quotes, or at least the quotes that I find funny. So,
By
I think
all means, we could
so,
all use a laugh now.
yeah. So I think once you told in the QM2 quantum mechanics 2 class that quantum mechanic is actually better than a garage mechanic, right? So
No. Actually, I was quoting somebody that
okay.
a quantum mechanic is no more philosophical than a garage mechanic.
Okay. Yeah, and like even like our MSc.
Suprav, I want to add basically, since you are talking about quotes, I remember it was I think a DAE conference workshop in Shantiniketan, and we were working on this, long baseline physics. I remember 2012-13, and Professor Umar Shankar was supposed to give a review talk on oscillation physics or something, but the title was very cumbersome. So he came and he came to the stage, and then first sentence he told, okay, the organizers have given me the responsibility to talk upon this, but I don't care. I will just talk what I like. So with that much coolness, in half an hour, he just talked what he thought that he should talk without.
I remember that. Yeah.
Yeah, remember. So
yeah.
So
this was in Shantiniketan.
Shantiniketan. So I thought that okay, आमी इतना भी cool हो सकता है. So now it helps me to reduce my blood pressure when you have to give talk on very complicated topics. I just think about Professor Umar that okay, I will just tell what I know with confidence. Rest of the thing people assume. Okay. So carry on, carry on.
And like once you told me something very simple, like always try to satisfy the minimum criteria. That's like, and I don't know, I found it deep and funny at the same time, right? And then once you told that, so research collaboration is actually like a local train. So while you, I mean, you have to let other people come in, but you have to stand your ground so that you're not thrown out of the train. Something on that, something like that. So these things are like you would, I mean, I think you have a very, very good sense of humor. And like some things that my batchmates used to make fun of that when, like, I think just because you had to travel every day from Jaffa to Mumbai, you would be tired and sometimes you doze off in a talk and then you just come up with a very interesting question. And this, like my batchmates, they're trying to figure out how does this happen, right? Yeah. So this journey has been like, the PhD part has been a lot of fun, and I really thank you for that. And I wish you all the best. A very happy birthday and a very, very healthy life ahead.
Yeah. Thank you, Supra.
Yes. Professor Anuradha ma'am and Raghav sir is there, and they want to talk. So, yeah, Anuradha ma'am. Yes.
Hello.
Yeah.
Hi, Raghav.
Hi, Umar. Hi, Kadri. Hi. Happy birthday.
Thank you.
And we wish you many, many happy and healthy birthdays.
Can you imagine that he faked it, the birthday, coming from Umar Shankar? This is only his official birthday. His actual birthday.
And I heard Jai, and I want to tell that I share my birth month with him. So I'm honored.
Like the Queen of England, I have two birthdays, an official one and an actual one.
No, Mendi is that all these days he faked it. Yeah, anyway, go ahead.
There is also one more star birthday. I don't know when it is.
Yeah, that's okay. One has to look up the Panchangam.
So many happy returns of the day. I mean, since we are doing this, we were there in the morning and we tried to wish you, and but somehow it didn't get across. It has been a very nice, I think, 25 years that we have been together. and interacting and this thing. So may the Lord bless you and wishing you many more years of happy and healthy life.
Yeah.
So
Thank you, Raghav, and thank you, Anuradha.
I would like to say a few words. I have known Umar Shankar in many capacities as a husband's colleague first, and then as a colleague from the other institution. Also, we are also related remotely through Kajri. And one of the things which so many people have said here, and I would like to repeat, is that Umar Shankar is definitely one of the finest teachers of our generation. And how do I know? I have chaired 2 SERC schools with him, one in Bangalore, which Urjit mentioned in the morning. And that was the first time I heard him teach, and it was really very, very effective teaching. And then another time when it was a circuit school in IIT Bombay, and there again I was, they invited me, and he gave me one of the finest introductions. I don't know if he remembers, connecting me to my illustrious guide, and then his grand guide, Julian Singer, and I really cherish that introduction very much. Thank you. We have also organized a mini school, I think in 2013 or something, when George Stimman was visiting, and a lot of people were involved in the organizing committee, including Rama and Urjit and Raghav. And I think Umar Shankar was very, very helpful at that time also. He always has the most useful advice to give. And that is because his physics is really very solid. And whenever I have invited him to Bombay University, whether for a syllabus committee meeting or a PhD viva, or sometimes at a day's notice for a Nobel Prize lecture on a recent Nobel Prize, he has always agreed, and students there have also liked this talk very, very, very much. And the last thing that I wish to say today, and thank both Uma and Kajri, is an incident. I don't know if you remember. Long time back, about 17 years back, there was a pass course in Tata Institute, and Raghav was on sabbatical in Germany, and you guys were also in CERN, I think, not in Bombay.
We were not here at the
time. I really wanted to attend that conference, and it was not possible to commute every day from IIT because the kids were really small. So their son and our son are same age. They have played together also number of times. And both of them very generously offered me their flat for the duration of the conference, so that I and kids, all of us, can stay there. And the flat was also impeccably, as you can see from the screen, organized like all his lectures. And we really enjoyed that visit very much. And we are always, I'll always be grateful for that kind gesture. So all the things that we have been hearing about him, about his helpful nature, are actually, we have experienced it firsthand, and we wish that he'll have many more active years, and many students will benefit from his great teaching and research also. Thank you.
Thank you.
Happy birthday.
Happy birthday.
Thank you, Anuradha. In particular,
we are together, right? Same batch,
one small thing I want to say. One particular thing I remember in my interaction with Anuradha is my visit to Bombay University after the Higgs discovery. She asked me to come to the university and give a talk about it. And I mean, that was a memorable experience for me, because there must have been more than 100 people in the auditorium that day. And they were very enthusiastic about that.
And I think you gave it with a chalk and blackboard without any PowerPoint presentation. It was an amazing talk. Yeah.
Thank you for all the kind words.
Yeah, thank you, madam. So now I would request Professor Anjan to say a few words about sir. Professor Anjan, are you around?
No, he
I think he's
does not seem to be logged in.
Yeah. Okay. So may I now request Sandhya ma'am to say a few words about sir?
Hello, Uma. Hi, Kajuridi.
Hello.
I saw your message in the chat box in the morning.
Yeah, I had just woken up and I knew that this workshop has already started. So the first thing I did, I opened the flap of my laptop and I tapped happy birthday.
Nice, nice.
Well, at that time, I did not know that Uma has 2 birthdays, maybe 3.
Yeah.
But fake or official or whatever it is, here there's loads and loads of wishes to you, Uma. In fact, when I got to know that, I mean, there's going to be a celebration on Zoom for Uma's birthday. This was, I think, very recently, maybe it was last week. And Srubhabu Didi actually told me about it. I was very surprised that Uma has turned 60. I mean, it was to me, and that is when I started to start thinking about all the interactions that I've had with Uma over all these years. And I looked up the archive and I was surprised that I don't have a single research article with Uma. So I was like getting ready to talk about our all the physics discussions and all the collaborative work that we've had. And actually, I saw none except all the Dune papers and all the INO papers. There are loads of that on the archive. So I've put that on my bucket list. One research paper with Uma at some point, and then I want to make that a very good one, something that I would be proud about, a nice collaborative effort on Neutrino. And the reason is that as I was going back the memory lane, I realized that I met Uma for the first time way back in 1998 when I was a little PhD student, and I had gone for my first major national, in fact, international workshop, which is web, and it was organized at Math Science. And this
Sandhya, it was 2000. Sandhya, this is Asmita. It was 2000, not 98.
Okay, 2000.
And I shared a room in IMSC guest house, remember?
Yes, I had a room in IMSC guest house. I think I was sharing it with Ashmita.
Yes.
And I was very happy to be there. I was, for the first time in my life, I was meeting all the national physicists, people I had heard about. I had heard their names. And there I saw Uma, the person working exactly in my field, and a very knowledgeable guy, a very cool guy. And I was like, yeah, is person se physics seekhna hai. So that was my first impression of Uma as a physicist, a solid physicist, a physicist from whom you could actually hope to learn basic physics. And it is true that over all these years, I mean, I thought 1998, but 2000 doesn't matter, 2 years. Over these 18, 20 years that I've been in physics, indeed, I've had innumerable, very high quality physics discussions with Uma. Multiple times every year, every time we met at any conference or he visited HRI. And it has always been a pleasure to discuss physics with him. And the crux of the discussions is that when you discuss physics with him, it's always at a very basic level. And you really, concepts get cleared in your own brain as you talk physics with him. So thank you, Uma, for being my colleague for so many years. And I hope that we will continue to discuss physics for many, 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 many more years to come. And even though it's not your original birthday, it's your official birthday, I would like to present this Swedish birthday song for you, if I may. So,
please.
Here it goes. Ya Mohan Leva, Ya Mohan Leva, Ya Mohan Leva uti hundra dior. Ya Vista Haleva, Ya Vista Haleva, Ya Vista Haleva uti hundra dior. So the song says that may you live for hundreds of years, Uma, and may we continue to discuss physics for 100 years.
Yeah, thank you, Sandhya. Actually, you talked about 2000 web, but I remember the 2002 web from HRI, where you, Srubhavati, I, and Abhijit Bandyopadhyay, four of us had a lot of interesting discussions, listed a lot of projects that we should work on. Unfortunately, we then were busy with our separate lives, so that none of those projects we were actually able to work on them. And I don't know whether to be happy or sad about it. During the next 1 year, Manfred Lindner and his students systematically wrote a series of papers precisely on the projects that we discussed in that web. So
Wow.
we should feel happy that yes, we
You were
identified.
on the right track.
Yeah.
You were on the right track.
Yeah.
No, he was always on the right track.
That's true.
Exactly my point. I mean, Uma, we should finally write a series of papers
Yeah.
which would rock the world.
Right. For example, David London, whose name has not been mentioned so far, but whose name has always been at the background throughout today. He is a Guru Bhai of Amol Dige and a postdoctoral mentor to Asutosh, and he is one of the co-authors in this very well received work of Asutosh and Amol on V2S mu plus mu minus. I have known him for a long time, since 1987, and we work on very similar things. But finally, it's only in 2014 that we were co-authors on a paper together. So, well, the day will come.
Yes, Uma. And so wishing you many, many years of healthy and happy life and many, many, many years in physics.
Yeah, thank you.
Happy birthday again.
Thank you.
Okay. Thank you, madam. So I would now request Professor Siva Kumar to say a few words. Professor Siva Kumar?
I think he is not logged in.
Yeah, he is not. Okay. So I will now request Poonam to say a few words about sir.
I'll just unmute. Yeah, can you hear me?
Oh.
Yeah.
Okay.
Hi, Poonam.
Hi, Uma. Wishing you a very, very happy birthday.
Thank
It's
you.
yet to come, but nevertheless, no harm wishing multiple times. And hello, Kajuridi.
Hello.
Nice to see you. Yeah, I think much of about the physics aspects were covered in talks by Raj and Shubhavati in the morning. What I would like to say, just add to that discussion, I really was fortunate enough to actually come across Uma during the very beginning stages of my career. This dates back to something like 2003, which is what was mentioned by Raj around the time we started working on CPT violation, atmospheric neutrinos, goals of INO. We also wrote some unpublished stuff like SOG report and things like that. I had a good fortune of interacting with Uma, and my experience tells me, okay, he's very straightforward and very prompt. If you ask a question, there will be a prompt answer and a very precise answer, which is what was also mentioned in Amol's talk. Precision, that's very, very, and he will always, if you rush to speak something at a stretch, he'll just say, wait, stop, first digest, then speak. So that's the typical person that Uma is. In addition to that, I think I would like to recall one incident which comes to my mind listening to what Ashutosh was saying about his TI for postdoc talk. I had a similar experience. So when I was supposed to, I had applied to TI for a postdoc position, and I was due to give a talk. I land up in TI for guest house or whatever. And Uma, of course, was very busy commuting and dealing with all his responsibilities, but he knew that I am supposed to give a talk next day or something, and I just so he found time to discuss and then made sure that I don't make a mistake. So we actually had a discussion prior to my talk, and he explained some fine details of the plots, revisiting everything nicely, and so that is what is very clearly there in my memory as well. And yeah, I think more or less everybody else has summed up um, all the qualities. But one more thing, I think Uma is a role model for me, and probably for many of the people in who are in teaching jobs in universities, in IITs. More importantly, for those people, because ultimately what happens is that one dissipates. One takes up a priority over teaching or research. Somebody who does very good in research doesn't is not able to cope up with the teaching as well. But to strike a perfect balance, Uma is a very big role model for us, and I think we need more people like him. And I try to have try to keep a balance on both these aspects, as well as the point that also was made by many of his students, that the nurturing element, spending time with students and teaching them the right things so that they get independent, that part also is very, very crucial. So I think this is a point very impressive about Uma. Um, and yeah, I think I would like to end with again wishing you a very, very happy birthday. And of course, with Kajaribi, we have had there's always a very spontaneous, immediate connect. We recently met at CERN and so on and so forth. Went for a walk, and there is a connect.
Already.
Sorry.
More than a year already, I think.
Yeah. I think this was 2 years back or something. 2018 January or something like that. Yeah. So yeah, I look forward to meeting both of you again, probably at JNU or maybe at IIT, and wish you good health and many more productive years ahead.
Yeah.
Thank you.
Thank you, Poonam. Yes, and thank you for all the kind words. Certainly, our collaboration was one of the highlights of my career, and
And
I've
90
had
years.
many enjoyable visits to HRI, and also when you visited Bombay, we had many
Yes.
fruitful discussions. One somewhat tangential thing goes through Poonam. I met her husband, and in fact, uh, during my visits, whenever I met them, I sort of ended up talking about all kinds of tangential things with Saurin, in some partly ignoring Poonam and physics. But of course, the
No, he also enjoyed discussing, talking
physics.
with you.
I hope
Definitely.
you are both doing well.
Yeah, we are doing well. Yeah. Okay.
Okay, thank you, Poonam. So I would now like to invite Narendra. Narendra, are you around? I don't think he's not here. So, Pomita? Pomita, are you around? Okay. So now I would like to invite Jackie. Jackie, are you around?
Hello.
Hello. Yeah, Jackie. So
Hi. You can hear me?
Yeah.
Okay. First, thanks a lot for organizing this meeting. So I am a collaborator of Professor Umar Shankar. So I want to tell you that Professor Umar Shankar has a great impact on my career. So I did my PhD in TIFR in DHEP, and DHEP and DTP are separated by one building. Basically, one building. is the Department of Condensed Matter Physics. So I always had this longing to go to this other side of Korea and do some theory. Somehow I never considered collider physics as a theory. I had this very wrong perception. So yeah, it did not happen. Somehow I could not collaborate during my PhD. But this deficiency was overcome when I met Professor Umar Shankar, and we wrote my first paper with him on the CP violation in B2SLLD case, and that was a turning point for my research career. After that, I have totally shifted to flavor physics, and now I'm happy. So I want to say a few lines about Professor Umar Shankar that I have observed him, and basically these are same. Many people have also observed it. So first of all, his serenity is very impressive. He's very calm, and this quality has also transferred somehow. I have seen in his students, for example, Dinesh and Ashutosh, and whatever he knows very well. His discussions are very precise, honest, and clear. He's very knowledgeable, and usually. When a person is knowledgeable, he becomes scary, but he's not scary. He's very approachable. So once again, I wish him a very happy birthday and a good health always.
Yeah, thank you, Jackie. Actually, our collaboration sort of occurred through intermediaries, so to speak. The number of discussions we have had directly face to face are somewhat limited, but it was, I mean, the papers that we worked on, they turned out to be quite good, and in fact have attracted a lot of attention. And I see from the archive that you are now very active as a member of David London's group, and good luck with your future career, and thank you for joining us.
Thank you very much. Happy birthday again.
Thank you.
Yeah, thank you, Jackie. So I would now like to invite Shubhavati madam. Are you around?
Uh,
I think
so
she's.
I think I have said most of the things, but I wanted to add one thing that when Amol said, I remember I was there in the ACRC school in Gandhinagar, and I was tutor of Uma's course. And usually, so what I saw is that everyone we knew that he is a very good teacher. I have myself, he taught us.
Subhabati, can we see you?
Oh, sure. You can see me. My internet is slightly bad, so hopefully it will not create problem.
Okay.
So then what I found was that, in the ACRC school, Uma exactly knew what problems, what he is going to teach in the next course and the next class, and the problems will be related to that. And, he will have some new problems. And then I and Rishi, we were sharing the flat, and we had to keep up with Uma. And every day, like, we will be working very hard to solve all the problems and be up to date. And so I think it was really nice having this course. I was tutor of a group theory course earlier also, but this course was in IIT Gandhinagar. That's in 2016. It was really a good experience. And one more thing I wanted to add was that when we did the atmospheric neutrino work, then we wrote this pool code, and Uma was very, very involved. And I think that was the first pool code that was written. Sandhya was also parallelly, she wrote one, but our group also wrote that code. And later on, when we did the INO analysis, people did, then this pool method was developed, but our paper was one of the first papers which did this pool analysis for INO. I think I have mentioned all other points, and nothing much to add. And wish you a very happy birthday, Uma, although it's not your real birthday. But again, let me wish you a very happy birthday. And hopefully, we will again restart our collaboration
it was really a collaboration that mattered a lot. So hopefully we can again resume some work together.
Yeah. Yeah. Thank you, Subhabati.
Okay, so I would now like to invite Raj sir. Is he around? No, I don't think he is around. And Amol sir, are you there?
Yes, I'm there.
Yeah.
But
So
I have already have spoken a lot.
Okay.
I just hope he likes ice cream.
So,
If you are next door, you can go and give it to him.
Well, Kajari already certified that I do. I like ice cream.
Amol, you really now have to get some very nice flavored ice cream and press Uma's doorbell.
So I have to, so I have to try
We want
making.
to see the ice cream on screen today.
No,
Before this.
Amal has to give to everybody because he showed it in a public event.
No, it's enough. Kajari goes to your apartment and hands over the ice cream to both of you, and you can show it in front of the camera.
Yeah.
We will be like, "Hame bhi mil gaya."
But you know, I have noticed it now. Of course, rains have started. But this summer, at least in this Nevinagar area, we didn't have any ice cream. In
No,
our
ice cream
in
sale was not that much going Kajuridi. Here
because of
also
COVID.
we didn't have.
No,
Because
because
of COVID.
yeah,
Yes.
exactly.
Because
Because we didn't
Everyone
have,
is afraid. No, everyone is drinking warm water.
Exactly,
Even if it's 45 degree, we are drinking warm water.
We
So-
could restrain for the ice cream for a couple of months. Then on
Exactly.
4th, my daughter's birthday was there, and we broke the chain. Basically, we broke the rule, and we had a bacha party, and we enjoyed ice cream on 4th June after 2.5 months. So
I think having an ice cream is okay, but you should keep sipping that warm water anyway.
So I want to say something. I have been, working on quite a few things with left-right symmetric models, and I knew all along that Umar had worked on those topics a long time ago. And I just recently checked, in fact, just now, about his old paper with Paul Langacker, and it has 383 citations by now. So I must resolve to now at least write one paper with Umar on the left-right symmetric model. Sitting in same department, we have not collaborated on that theme. And I hope that that paper will crash 500. Best to you, Umar.
Some of you probably know George Howe. He once I teased me some time ago that my Guru Bhai, who has written a very well received review along with my advisor, and on the basis he has become a member of Chinese Academy of Sciences. So I should sort of try to become a member of Indian Academy of Sciences based on this paper.
So if I can say one thing, Urjit, here is that, I gave a talk in TIFR on neutrinoless double beta decay in left-right symmetric model. And I think that was my first paper on left-right symmetric model. And okay, we studied a lot of things, but then Shiraj was there in the audience and he was asking a lot of questions. And frankly, I was really happy that Umar was there in the audience, because many of the questions he could answer, and I didn't have to, I didn't even know many of the answers. But Umar, I was really happy that day that Umar was there in the audience in TIFR. So you are right that he is the right person to work on left-right symmetric models.
Yeah, it's a bit off topic, but when I tried to give a talk in TIFR, I could not get through more than half of it, simply because Shiraz kept I think Shiraz has some deep query about what this exact parity symmetry comes
Yes, I know. I know. Like we were taking VL to be 0, and then Uma said that that was the question asked in his Viva. Uma, you said, you remember that can you take VL as 0 and still minimize the potential? Something like that, but it was good because he was there. And it reminds me one more thing which I forgot to tell, which is about this conference and this cool organizer of conference. I remember for Bombay Web, I was the working group coordinator of the Neutrino and Cosmology. I and Raghu and Urjit and Uma were the they were the conveners, and it was like they were really cool. And whenever Uma or Web, there are a lot of excitement sometimes, like who will be the speaker, how many talks, this and that. And I remember that it was handled very coolly. And not only that, due to some interplay of circumstances, both Urjit and Uma, who were conveners, had to give talks also in web. I don't know if you people recall that
Yeah,
both of you gave talks.
yeah, in the very first session, if I remember correctly.
Yes, I recall that. Yes,
Yes,
that was very
that's,
enjoyable web.
Some
and
of
that
us who
was like
figure
already
came.
organizing conference and giving talk in the same conference is not easy. So
It's
that was
extremely
like,
difficult. I cannot imagine doing it.
yeah, that shows the coolness
Very
quotient of both of these people.
That is true.
Okay, so I would now request that some departmental colleagues from IIT Mumbai, so if they want to say something about sir, they can now speak.
Hi, this is Piali. I am a women DST scientist in IIT Bombay working with Urjit. But obviously, you can understand it. Uma is there in the department, so you will automatically get, attracted to his discussing with him. And I must say that actually my relation with IIT Bombay started through Uma, because I remember when this Shourab Roy introduced me to Uma, and I decided to do project in IIT Bombay. It was started with Uma only, but eventually I was also talking to Urjit. And what I want to say is same as others are saying, that he would start from the scratch and he would explain the theory from the scratch and build up the theory, go all the way, and it would be so precise and it would be so slowly with all the nitty-gritties that eventually when you would come out, you would always feel if you could emulate all those type of qualities a good physicist should have. And in all the papers so far I have written with Urjit after joining as a DST scientist, it's invariably that I had to go and discuss with Uma to understand certain things. It may be in group theory, it may be in, I remember in even as simple thing as word identity, or it may be in some basic quantum field theory doubts. And Uma was always there patiently explaining. And also I want to say that today's birthday, somehow I missed it because I didn't, I am actually not able to log into my IIT webmail account. And just yesterday night, I sent some results to Urjit. And then Urjit mentioned that, by the way, tomorrow is Umar Shankar's happy birthday. And this is the kind of curriculum which is going to be followed. And when in the morning, it usually is that I wake up very late in the morning. But today somehow by 9:30 I woke up, and first thing I was checking in my mobile to see if there is any mail. And I see this email and I see it's Uma's birthday. So I sprang up and I wrote to Urjit that send me the URL. But unfortunately, Urjit must have seen the my email much later, and he sent me around 12:30. And by that time, I was busy with preparing lunch and everything for everyone. And then eventually, when I joined at 3 o'clock, I could listen to some of the talks. It was very good. And but then I was just feeling that somehow I always wanted to kind of thanking is not enough. to Uma because it's really very inspiring as a teacher and also as a human being. But somehow it kind of, it just, I got the chance somehow that I could attend this meeting. So Uma, happy birthday to you. And thanks for all the help you have been giving. Unfortunately, we couldn't start on that kind of problem you suggested during this neutrino workshop. But someday maybe I'll try to do on it somewhat. Thank you.
Yeah. Thank you, Piali. And yeah, I understand the kind of pressures under which you are working. And yeah, let us hope that we'll be able to do some work together later on.
Yeah, thank you.
Well, Professor Umar Shankar.
Hello, Professor Jagtap.
Happy birthday. And
Thank you.
I must thank you for all your suggestions when we were teaching the quantum physics and application course together. I still cherish some of the suggestions you gave me. And second one is ask a teacher. I used to be really afraid when you were not around in the department, because when you were not there, Mr. Singh would come and say that Professor Umar Shankar is not there, the show must go on. And then I used to reluctantly sit there. But I did enjoy, and we did one show together. Thank you very much.
Thank you, Professor Jagtap. And yes, teaching the course with you and also handling the ask a question sessions. It was really enjoyable. And we had some very good discussions, especially while teaching the quantum course.
Thank you.
Thank you.
Hi, this is Anirban.
Hi, Anirban.
Hey, happy birthday.
Thank you.
Yeah. So just few words about Uma. So Uma is basically the epitome of calmness, and like few outstanding things about you are that you are never in a hurry, which is I am just the opposite. You always have time wherever you are going. If somebody asks you something, you just quietly pause and starts to answer very patiently, which which is kind of I find it impossible to emulate. And another thing is that in last 15 years, I've never seen you getting angry about anything except once in a committee meeting. I remember some faculty meeting, and it was for a very good reason. I like that. But this and one more thing is that which makes you very special is that you're a very good person, a very, very nice person whom one can always look up to when one needs help. Yeah. So keep it up that way. Happy birthday. Thank you.
Thank you, Anirban.
Hi, Uma. Sadhna here.
Hi, Sadhna.
So wish you a very happy birthday.
Thank you.
Already a lot of colleagues, students, collaborators have spoken about you.
Yeah.
So I had the opportunity to share the course PH 107 at the beginning of my teaching career at IIT Bombay. So, and I remember when we used to discuss about the midsem and endsem questions, what I admired about you a lot is that you always stressed on asking simpler questions. So that, and you would say that if the student does this, that satisfies us. And that was really a good training. And also I had the opportunity to interact with you in various committee meetings, question paper settings, RPC seminars, ask a question. And I remember, and I want to share, everybody in the department knows that you are an expert in remembering past incidents and citing them as examples which were pertinent to the discussions then. So you'd always start with that, if I recollect correctly, but ... and then you would say it would be in great details. So, so I've learned a lot from all your experiences, and I value you as a senior colleague. And everybody knows that you are a very polite, calm, straightforward, and kind person. So whenever I had issues with department or physics in general, I bothered you many times, and you were always responsive and always ready with your suggestions and advice. So I would wish as you are a particle physicist, you know the importance of matter. So, like age is strictly the case of mind over matter. So if you don't mind, it doesn't matter. So I would really like to wish you and Kajari a very healthy and fruitful years, future years, and I wish you all the best for your forthcoming endeavors. Thank you.
Thank you, Sadhana.
Thanks.
So before you finish, I just wanted to mention, Uma, I'm Shomo here. So there are many comments in YouTube. So I cannot read all of them. So many people wish you a very happy birthday. But I want to at least read out one small comment by Dr. Promita Ghoshal. She's saying that she's in YouTube, but she can't speak as she is in other meeting. But she wants to mention that that her father remembers the train trip with you to Ahmedabad in 2008 when you had hours of conversation. So I just wanted to mention that she wrote it here.
I will talk to Pamita later.
Uma.
Hi.
Suresh.
Yeah. Hi.
So I am borrowing your own terminology and asking this question. I am asking a tangential question.
Yeah.
When is a party?
Well, first I should be allowed to come to the department.
Yes.
That only the other Suresh can do. I cannot do.
No, it will be there. It has to be there.
No, he always likes this tangential question. So
Anyone else wants to speak?
So Uma, this is Sai here.
Yeah, hi.
Hi. So I thought that this is the correct opportunity for me to ask you some important gyan, which is another phrase that I have, that has become common in my language that I have kind of picked up from you as well. So what is the longest DFM that you have ever attended or departmental meeting that you've ever attended? I'm interviewing you now. And how did you survive it? So
not during his time. Not during his time.
Besides this one, which counts also as a long departmental meeting. But,
I don't know, maybe 2.5 hours. Okay, the only way to survive is you mentally decouple.
So do you mentally decouple in the first 5 minutes or?
No. I think at least in my case, it happens about half an. I do pay attention in the first half an hour.
You should not ask these secrets publicly.
Okay, I will talk to you in private, Umar. Happy birthday again.
Thank you.
So you and Varmaji joined in the same batch, right?
I mean, we were selected together,
okay.
But Raghav joined
6 months.
6 months earlier. In fact, there is a famous story about his joining IIT Bombay. He joined before he even received the appointment letter.
No, don't tell us that.
Okay, so anyone else who wants to talk?
Hi, Uma.
Hi, Amitabh.
Hi. Many happy returns of the day.
Thank you.
I wish you a very happy birthday. So I had a wonderful, great time during the last 2 years being a co-instructor for the PH 108, and you had been like a true savior whenever like any kind of help were there. And so I am just looking forward to the lockdown to get over, and I hope you will get us those awesome walnut banana cakes from Gaylord. So
yeah,
we can just do it here then. Sit here.
Yeah.
Happy birthday.
Thank you.
Also, Pulla Reddy.
Well, I have to go to Hyderabad, and I think I have been going every 6 months to Hyderabad because I was on a committee of Hyderabad University, but now my 3-year term is over. So I don't know if I will be going to Hyderabad on a regular basis anymore.
Unitarily equivalent mithai will be acceptable, Umar.
Yeah, get into another committee, Uma. In a nice place.
Uma, I have one question.
Yeah.
I know you what answer you will give me, but you may have to give it to everybody since it is going to be a crucial tangential question. Do you still think that you did a wise decision by changing over to physics?
Oh yeah.
Otherwise, you would have been some millionaire now in US. Okay, giving
No.
donations as alumni.
I would be paving the streets.
Eh?
I mean, had I stayed in electrical engineering.
Yeah, that is a question.
No, that's what I'm telling you. I wouldn't have gone anywhere.
I guess Surya is also there. He will listen to you and he'll also add something.
Okay, yeah, good.
Hello. Joined.
Hello, Uma.
Hi, Archana.
Hello. Wish you very happy birthday.
Thank you.
Happy birthday, Uma.
Thank you.
Yes, so I just want to give you a message. If I remember it right, you taught our batch. That was your first.
That's the first batch I taught in IIT
Exactly.
Bombay.
Yes, so there is a message from the entire batch that they really enjoyed your very meticulous teaching and especially your board work. So yeah, many of us drew inspiration from that and we will all remember that. So I'm representing them. And of course, as a colleague, I really enjoy interaction with you.
Yeah, thank you. And please also thank your classmates on my behalf.
Sure.
So can you remember all the names?
Of course, I think he does. He does.
If not all, I can remember, I don't know. At least. I can probably remember 6 or 7.
Yes, I think because once I remember we had a discussion in the tea room. And you did
definitely Sahana, right?
Recall many of
Sahana
them.
is 1 year junior to her.
No. I was senior to Sahana.
Yeah.
And he taught us mathematical physics course.
No, Pradeep Karan did EP, whereas Sahana did.
Yeah, but he was in EP. He taught the MSc batch in '95, right?
Yeah, January, the spring '95.
That's right. Yeah, that's right.
That was the
I
first time
want
he was teaching.
Yeah.
Well, okay.
Yeah, and it was really, I mean, we all really enjoyed that course. In fact, I might have his notes also.
Was it starting at 8:30 in the morning?
One lecture,
Okay,
Friday.
that I don't remember.
No, I remember. Friday, see, it was January. Friday's lecture was 8:30 and I was not sure about my commuting and I used to leave at 6:30 and in January at 6:30 it was still pitch dark.
Yeah. Okay.
Yeah, I understand. Uma, I just want to add one thing. I've interacted with you only for the last 3 years. Anytime I've interacted with you in many of the RPC committees, and I always thought that you were sleeping, but then you suddenly get up and ask a question. So can you explain how do you do this? Actually, most of the questions are very pertinent.
It's all the ask a question experience, Umar.
Maybe, I don't know. I'm always, it is always puzzling.
This is something we were taught in during our PhD days. Especially, there is this man actually, a very famous particle physicist called Henry Primakov. I joined UPenn in 82 and he passed away in 83. But of course, he was so famous in the department, people would quote various comments by him. And one of his famous comments is, insomnia is inability to sleep in seminars. So.
That's a good one. Okay.
Yeah.
No, but that is okay. But how do you ask the question? That is more important.
Yeah, I think the more important part is that how to ask a relevant question after waking up.
Yeah.
He is not alone. There are other people also.
Yeah, most probably he is in a different subconscious level. And he's listening to all of you.
No, he would have thought about that question before the seminar itself.
Yeah, that is quite possible.
Yeah. That is quite possible. Yeah.
Or maybe
No,
he
but
knows
it is very
the talk better than the speaker, so he already knows the questions. And so then he just wakes up, asks the questions, and he
So,
puts the
there are,
speaker on the spot.
By the way, in regarding sleeping and talking, I have one or two memories to share. A lot of you probably know this great man, Professor Probir Roy. He was a professor in TIFR, retired some 12 years ago. For some reason, he used to, while speaking to you, standing in front of you, while speaking to you, he would close his eyes. And you're not sure whether he is awake or not, but he would continue speaking.
And here is one comment.
And I mean, sometimes I find myself doing that, especially if a student comes to talk to me after lunch. I will talk to the student, and suddenly I find, am I making sense? I mean, what I was talking to the student 5 minutes ago and what I am saying now, is there any connection between these two statements? And because suddenly I have the feeling that I have actually dozed off even as I was speaking to the student. So,
but you are taking the first year course at 2 o'clock.
No, I'm talking about talking to project students. And I've had this experience many times.
On YouTube, I see there is a comment by somebody called Abhishek Shahu. Who is that? Anyway, so he says Professor Umar was also in the panel of my bachelor thesis presentation, and I could see him doze off. I was completely taken aback when he came up with the most interesting question. So he says, I am sure you don't know me, but I have been influential you have been influential during my undergrad life.
here, this quality, perhaps I think Umar Shankar shares people like Chandrasekhar and Feynman. Chandrasekhar, of course, was known to do it very regularly, sleeping and waking up to ask questions. Feynman used to do some cheating and really find out first what the speaker is going to speak and then decide on the question.
Anybody else?
There is a comment by Archana Pai. No, I spoke. I think there was some problem with my, yeah. Okay. Yeah.
Okay, so if there are no more comments, we could conclude the session. Yeah, I have not really spoken about Uma. I think as Shanky was saying, he knows him for 3 years. I would say I know him from 91, from my PhD days in math science.
No, sorry. I knew you from 90 summer. You came to TIFR.
That's right.
There he goes.
No.
So I purposely did this to see whether Umar remembers this. Okay.
I particularly remember you because for some reason, Muskan sir could never pronounce your name. He would always call you Ram Devi.
Yeah, agreed. Yeah, a lot of people don't call me Rama. Yeah, I think even Ramesh Kaul has an accent when he calls me Rama. So anyway, so I did meet you during that summer. I remember that. And I think you had come for a brief visit to TIFR, if I'm not wrong, that time. Were you visiting from abroad or something that time?
No, I was a postdoc here.
Oh, I see. Okay, I didn't know that. Anyway, so I did meet you briefly, not almost every day or something. So I know you for the longest time amongst the students and other collaborators, I guess. And I think I attended one of your course on grand unified theory.
Yeah, I
During
taught a half semester course before
during
leaving.
my student days. I remember, all the messy expressions, indices, and all beautifully you handled on the board. And then later on, I think I was in touch with you, but 94 you went to IIT Bombay. And again, I got back when I was a postdoc in TIFR. I used to meet you. And then I also had this chance of discussing the alternating group symmetry, and we and Abhish Day, we got into a collaboration working on this theta 1,3 mixing angle and delta CP violating phase. So I think I am one person who has collaborated initially with Gurjit and then with you. So I feel proud that as an immediate junior, I could work with you both. And for this session to happen, there were a lot of people who have been instrumental. I should really thank Saumyo to be present anytime we have a hiccup to fix it. And then Ritanjali and Ashutosh have been, Ashutosh started with helping me out and fixing things. Everything on a virtual setting, we were very scared whether it will go on fine. So I think without their help, Ashutosh, Ritanjali, then Shushant also helped us out. I think we could try and get this done in a smooth fashion, almost a smooth fashion. You all enjoyed, and I wish you a very happy birthday to you, and healthy and much more fruitful, many more papers, many more collaborations. And thank you. Thank you so much. Thank you, Kajeri, also. And I think Surya is also there.
Surya is there. I am really moved
Oh, I
by
did
this.
not know Surya is there.
No, he
Yeah.
joins sometimes
Hello.
back because this is.
Yeah.
Can we
So
see him for a
I'm
minute?
happy. I'm happy that we
Surya,
could
can you come
get.
on video?
Maybe Rama Kajuri wants to say something.
Yeah. Okay, Rajuri wants to say something. Surya wants to say something. Can say that. Yeah.
You can go ahead, ma.
Surya.
Yeah.
I have to call him Surja. Oh, okay. Yeah. Okay.
Yeah, I just logged in half an hour ago. I just woke up. It was nice to hear everybody speak.
Very nice.
Yeah, I myself am just now getting the taste of research. When I was young, I would see my parents doing research, and it seemed I got one picture. But now, when I'm doing it myself, I realize there are many more facets to it.
Can we see you on the video briefly?
Yeah, my video is
He's
on.
there.
Yeah, he's there. He's there. I can see him.
Achha, no, I can't see.
I can see Surya.
Maybe there are
Ramadevi,
Yeah. Okay.
on speaker's view. Then when he speaks, you can see him.
Yeah. Good. I've seen him now. Good. He has not changed very much from his student days. Good.
Yeah.
Kajuri wants to say something.
No, I just wanted. Okay, Surya, you want to say something? Go ahead.
Yeah, that's what. So right now, as I'm doing PhD, also my father and mother are helping me a lot, telling me about how things really are. And another slightly surprising thing is, I mean, looks like things are quite different between now and when my father did PhD. I mean, it seems in those days everybody would talk about sports and lots of other things, and people just don't talk about those things anymore. Of course, it's true that maybe in my own friend circle there aren't too many Americans, but even when I do speak to Americans, they don't seem to be talking about sports and other things. People just talk about, I don't know, work and TV shows and things like that.
Yeah, I mean, for example, in the morning, Sushant mentioned that I tried to teach him about baseball. I tried to do it with Surya also, but I mean, failed completely.
How come you don't play but you talk about these games?
No, that's the whole
He
point.
follows very much.
No, but well, actually, the answer is very simple. I mean, I went to US and like
all the games in USA he follows.
You take somebody whose world was limited to Vijayawada and Madras and throw him in the middle of the US. There was nothing else to do. And essentially, the only thing I could appreciate of things happening in the US was basketball.
Basketball,
So-
baseball, golf,
So
anything you can.
it started by following basketball, but then the basketball season ended. So I had to pick up some other thing. So that's how the whole thing started off.
So now we know that Uma is an out and out theorist. Even
Yeah.
in sports, he does all the theory part.
Yeah.
And I just wanted to share something, because just now when he was talking about sports, I remember initially when I joined for project in IIT Bombay with Uma, sometimes we used to come back almost at
Can
the
we see you? Can we see you clearly? Clearly, right? Yeah.
My house is so dirty, I'm feeling a bit ashamed to open the video. Okay, let me see.
Okay.
Because it's yeah. So can you see me?
Yeah, it is quite fancy.
No, if I turn the thing, you will see it's terribly in a mess. Anyway, so what I wanted to say is that we used to come back, and after 10 minutes, I used to go down to buy grocery. And several times I saw that Professor Uma Shankar is carrying a ball and taking Shurjo to the playground, almost near to the West Canteen Lounge, means near the seashore, and taking him for play, and they would go and they would play ball, throwing a ball or something. Many times I kind of saw that. So I in fact once told Shurjo that I've seen him, that even after coming back from IIT Bombay, traveling by that local train, he would come down with you to that play field and play with you. Means I just can't imagine how I would do if I were in that situation. So that I remember quite clearly. And I think once I went to Kajaridi's house to discuss with Uma, and while we were discussing, I remember Shurjo was trying to understand how the cycle's tire works and how things are. And in between, he had immense amount of curiosity, and he was asking questions. You can understand two professors, the kid must be with a lot of curiosity. And so he kept on asking, and everything in Bengali. And I saw even not being a Bengali, he was shifting from English to Bengali, explaining to him that why this is bending, why, because he is giving cheap, means chap diche, means that pressing. And then again coming back, explaining me the things on neutrino. That time I was actually doing all this cross-section calculations from Helsen-Martin and all these things on neutrino. So I was astonished, because I just couldn't think that how he could, because you might know Hindi as a language because it's a national language, but shifting from Bengali to English, constantly explaining Shurjo in Bengali and then coming back and continuously talking. And I think I told that also to Shurjo once when we were coming back by, I think, TFR bus. So that's what I wanted to share.
No, of course, we were just now talking about 95, his first teaching courses in IIT. So Surya was, of course, few months old, and then he won't sleep because in the babysitter's place, he will sleep quite a lot in the daytime. So I will be almost in tears in the night when we are very tired and Surya doesn't want to sleep. He wants to spend some active time with us. So he will be moving around in the room trying to put him to sleep. Anyway, we should not stress the day too long. I'm really moved by all of your fondness and the way you spoke about Uma Shankar today. It's really very nice, and it shows your respect and love for him. We are really thankful, and it was very nice day. And I also learned some of about his work from some of you. So nicely you expressed and you told the essential parts, the highlights of your work, the research with him, because I'm always a very limited person and I never kept track of his work. So it was nice to learn various things. And as you know, he never says so, even when he is publishing paper or what is happening. Only recently I know that he reached the count of 50. So it's nice. And also, I always felt very guilty that for me, he had to leave his job in math science and come to Chennai. And then he picked up this of commuting every day, which costed him at least 4 hours, both sides put together. and still he could have such active academic life in the department. It's really very nice. And in contrast, I could do nothing, so I used to always feel bad about it. But after today's the session, I really feel very nice, and definitely he has a fulfilling life in the department in the professional way. It's very nice. Thank you all so much, and I wish you all very good health and good time. I hope we will all meet sometimes, either together and outstation participants. Remember to contact me when you come to Bombay. Okay, we will have the celebration.
Okay,
Thank you, Kajri. Thank you, Surjo or Surya. So I think we had an exciting time. We are going to close this event, and of course,
So thank you all for putting together this day.
It was very nice.
Especially Rama Devi to start with, who has taken the first initiative, and KG Suresh, who supported her fully, and Asutosh, Ritanjali, and Sushant, who helped her to organize the academic sessions, and Shomo, who helped in organizing this video session. And lot of people have said a lot of nice things about me, especially about my teaching. There was a joke I came across once, says insanity is hereditary, you get it from your children. Well, I translate that joke. You actually learn things, probably you learn things less from your teachers and more from your students. Certainly the making the attempt to teach made me understand things much more. So in that sense, I'm very thankful to all the students that I have had. Thank you.
And I hope all of you will continue to remain in the club for Appreciation Society for him. You all spoke so highly of him. We are very honored.
thank you, Uma, thank you, Kajri.
Thank you, sir.
Thank you.
Take care.
Yeah,
Thanks to all
we'll
of
close this event.
Bye.
Bye. Bye. Bye,
Bye,
Kajri.
Kama.
It's really nice. Very nice.
Bye.
Bye, everyone.
Bye.
Bye, Umar. See you.
Bye. Bye, Umar.
Okay, bye, Umar.